Eclipse Architecture. Here you can see Eclipse platform architecture. Eclipse is an integrated development environment IDE used in computer programming. It contains a base workspace and an extensible plugin system for customizing the environment. It is the second most popular IDE for Java development and until 2016 was the most popular. Eclipse is written mostly in Java and its primary use is for developing Java applications, but it may also be used to develop applications in other programming languages via plugins including EDA, AB, AP, C, C++, C Sharp, Clojure, COBOL, D, Erlang, Fortran, Groovy, Haskell, JavaScript, Julia, Lasso, Lua, Natural, Perl, PHP, Prolog, Python, R, Ruby, including Ruby on Rails framework, Rust, Scala, and Scheme. It can also be used to develop documents with LaTeX via a TextClips plugin and packages for the software Mathematica. Development environments include the Eclipse Java Development Tools JDT for Java and Scala, Eclipse CDT for C, C++, and Eclipse PDT for PHP, among others. Here you can see Eclipse platform architecture. The Eclipse platform, or simply the platform when there is no risk of confusion, is designed and built to meet the following requirements: support the construction of variety of tools for application development, support an unrestricted set of tool providers including independent software vendors, ISVs, support tools to manipulate arbitrary content types, for example, HTML, Java, C, JSP, EJB, XML, and GIF, facilitate seamless integration of tools within and across different content types and tool providers, support both GIF and non-GIF based application development environment, run on a wide range of operating systems including Windows, Linux TM, Mac OS X, Solaris, AIX, and HPUX, capitalize on the popularity of the Java programming language for writing tools. The Eclipse platform's principal role is to provide tools providers with mechanisms to use and the rules to follow that leads to seamlessly integrated tools. These mechanisms are exported via well-defined API interfaces, classes, and methods. The platform also provides useful building blocks and frameworks that facilitate developing new tools. Here you can see the major components and APIs of Eclipse platform. Here the platform runtime and the plugin architecture. Plugin is the smallest unit of Eclipse platform function that can be developed and delivered separately. Usually a small tool is written as a single plugin, whereas the complex tool has its functionality split across several plugins, except for a small kernel known as platform runtime. All the Eclipse platform's functionality is located in plugins. Workspaces. The various tools plugged into the Eclipse platform operate on regular files in the user's workspace. The workspace consists of one or more top-level projects, where each project maps to a corresponding user-specified directory in the file system. The different projects in a workspace may map to a different file system directory, so drives through by default. All projects map to sibling subdirectories of a single workspace directory. The Workbench and UI toolkits. The Eclipse platform UI is built around a workbench that provides the overall structure and presents an extensible UI to the user. Workbench API and implementations are built from two toolkits: SWT, the widget set and graphics library integrated with the native Windows system but with an OS independent API; JFace, a UI toolkit implemented using SWT that simplifies common UI programming tasks. The SWT, the standard widget toolkit, provides a common OS independent API for widgets and graphics implemented in a way that allows tight integration with the underlying native Windows system. The entire Eclipse platform UI and the tools that plug into it use SWT for presenting information to the user. JFace is a UI toolkit that classes for handling many. It's a UI toolkit with classes for handling many common UI programming tasks. JFace is Windows system independent in both its API and implementation, and is designed to work with SWT without hiding it. Workbench. Unlike SWT and JFace, which are both general purpose UI toolkits, the Workbench provides the UI personality of the Eclipse platform and supplies the structures in which tools interact with the user. Because of this central and defining role, the Workbench is synonymous with the Eclipse platform UI as a whole and with the main window the user sees when the platform is running. The Workbench API is dependent on the SWT API and to a lesser extent on the JFace API. Workbench implementation is built using both SWT and JFace. Java, AWT and Swing are not used. Team support. The Eclipse platform allows a project in the workspace to be placed under version and configuration management with an associated team repository. The platform has extension points and a repository provider API that allows new kind of team repositories to be plugged in. Help. The Eclipse platform help mechanism allows tools to define and contribute documentation to one or more online books. For example, a tool usually contribute help style documentation to a user guide and API documentation, if it has any, to a separate programmer guide. Here you can see the new tool. Here Workbench, Help, Workspace, Team and Platform Runtime are in Eclipse platform. SWT and JFace are in the Workbench here. New tools are connected to the Eclipse platform. Here you can see a platform architecture. As a separate view. The Eclipse platform is structured around the concept of plugins. Plugins are structured bundles of code and or data that contribute functionality to the system. Functionality can be contributed in the form of a code libraries, Java classes with APIs, public APIs, platform extensions, or even documentations. Plugins can define extension point, well-defined places where other plugins can add functionality. Each subsystem in the system is itself structured as a set of plugins that implement some key function. Some plugins add visible features to the platform using an extension model. Others supply class libraries that can be used to implement system extensions. The Eclipse SDK includes the basic platform plus two major tools that are useful for plugin development. The Java development tools, JDT, implement a full-featured Java development environment. The plugin developer environment, PDE, adds the specialized tools that streamline the development of plugins and extensions. These tools not only serve a useful purpose but also provide a great example of new tools can be added to the platform by building plugins that extend the system. With Runtime Core here, the platform Runtime Core implements the runtime engine that starts the platform base and dynamically discovers and runs plugins. A plugin is a structured component that describes itself to the system using an OSGI manifest.mf file, and a plugin manifest plugin.xml file. Platform maintains a registry of installed plugins and functionality they provide. The general goal of runtime is that the end user should not pay a memory or performance penalty for plugins that are installed but not used. A plugin can be installed and added to the registry, but the plugin will not be activated unless a function provided by the plugin has been requested according to the user's activity. The platform runtime is implemented using OSG iServices model. While implementation details of the runtime may not be important to many application developers, those already familiar with OSGI will recognize that an Eclipse plugin is in effect an OSGI bundle. The best way to get a feel for the runtime system is to build a plugin. Resource management. The resource management plugin defines common resource model for managing the artifact of tool plugins. Plugins can create and modify projects, folders, files for organizing and storing development artifacts on disk. Workbench UI. The Workbench UI plugin implements the Workbench UI and defines a number of extension points that allow other plugins to contribute menu and toolbar actions, drag and drop operations, dialogues, wizards, and custom views and editors. Additional UI plugins define frameworks that are generally useful for the user interface development. These frameworks are used to develop the Workbench itself. Using the frameworks not only eases the development of a plugin user interface but ensures that the plugin have a common look and feel and a consistent level of Workbench integration. The Standard Widget Toolkit SWT is a low-level operating system independent toolkit that supports platform integration and portable API. The JFace UI framework provides a higher level of application construct for supporting dialogues, wizard, actions, user preferences, and widget management. Team support. The team plugins allow other plugins to define and register implementation for team programming, repository access, and versioning. Debug support. The debug plugins allow other plugins to implement language-specific program launchers and debuggers. Help system. The help plugin implements the platform optimized help web server and document integration facility. It defines extension points that plugins can use to contribute help or other plugins documentation as browsable books. The documentation web server includes special facilities to allow plugins to reference file by using logical plugin-based URLs instead of file system URLs. Additional features are provided for integrating help topics in product level documentation configuration. Java Development Tools JDT. The Java Development Tools JDT plugins extends the platform Workbench by providing specialized features for editing, viewing, compiling, debugging, and running Java code. The JDT is installed as a set of plugins that are included in the SDK. The Java Development User Guide describes how to use the Java tools. The JDT plugin developer guide in the documentation describes the structure of API of the JDT. Plugin development environment. The plugin development environment PDE supplies tools that automate the creation, manipulation, debugging, and deploying of plugins. The PD is installed as a set of plugins that are included in the SDK. Here you can see the Java development tooling JTD and plugin developer environment PDE and Eclipse platform are inside Eclipse SDK. Java development tooling JDT and plugin developer environment PDE and new tools are connected to Eclipse platform. Workbench, help, Workspace, team, and platform runtime are inside Eclipse platform. SWT and JFace are inside Workbench. Here you can see Eclipse 4 RCP architectural overview. The Eclipse 4 application platform E4AP for the most part is very similar to Eclipse 3.x application platform. That is all of JTD and PDE and most of the platform are the same bits as in Eclipse 3.x. The E4AP differs from the Eclipse 3.x platform in the implementation of Workbench. That is the org.eclipse.ui.workbench plugin, and the technologies this new implementation is based on. Before the release, the technologies modeled UI modeled UI, dependency injection, and service-based programming model, CSS based styling were called E4, but we are now referring to them as Eclipse for application platform. On top of the Eclipse for application platform, the 4.0 Workbench offers an implementation of the 3.x Workbench API called the compatibility layer to provide backwards compatibility for existing well-behaved Eclipse 3.x applications. Here you can see rest of the platform, JDT, PDE, and Workbench. Inside the Eclipse 4.x SDK, and here you can see Eclipse 4.x application platform. In the rest of the platform includes a debug, text, theme, etc. JDT include Java editor, Java debugging, refactoring, etc. PDE includes manifest editor, launching, API tooling, etc. Workbench, here compatibility and provides 3.x APIs. Modeled UI, CSS styling, dependency injection, application services, Equinox, EMF core, SW2, SWT, JFace inside the Eclipse 4.x application platform. Below here you can see below Eclipse 4.x SDK, you can see Java virtual machine, and then OS, Windows, Mac, Linux. Here you can see Eclipse RCP rich client platform. Eclipse RCP rich client platform applications use the Eclipse frameworks to create feature-rich standalone desktop applications. An Eclipse application consists of individual software components called plugins. Plugins can use and extend other plugins. For example, plugins can create new menu entries for menu defined by another plugins. Eclipse IDE can be viewed as a special Eclipse RCP application with the focus on supporting software development. For example, the Java development tools JDT provide the functionality to develop Java applications. An Eclipse RCP application typically uses the same base component as Eclipse IDE. On top of this, the developer of the RCP client add this application specific component. This is depicted in this graphic. Here you can see user interface, server communication, data model, and more things are in client plugins here. Here you can see user interface on top, and below server communication, data models, and more things. Application model, rendering engine, CSS styling, dependency injection, services, Equinox runtime, OSGI, EMF core with Eclipse framework plugins. Here you can see below client plugins, Eclipse plugins, application model, rendering engine, CSS styling, dependency injection, and services here. Below that, Equinox runtime, OSGI, and EMF core. Here you can see Eclipse SDK architecture. Here Java Development Tools JDT, Plugin Development Environment PDE, and Eclipse Platform are inside Eclipse SDK. Java Development Tools JDT, Plugin Development Environment PDE, your tool and their tool and another application are connected to Eclipse platform here. Their tool is connected to your tool here. With the Workbench IDE level, you can see Java Development Tools JDT, Plugin Development Environment PDE here, and some tools here, and here you can see Workbench IDE UI, Workbench text editor, update forms, outline and properties views, JFace, Workbench UI, SWT, and platform runtimes are inside the Eclipse platform. With Workbench IDE level, you can see here Java Development Tools JDT, Plugin Development Environment PDE, and some tools here, and Workbench IDE UI here, and here with here work-based document editors, compare, search, team, workspace, and workspace or resources are inside Workbench IDE UI here, and this is in the Workbench IDE level, and here you can see with the rich client platform level, which is optional, and you can see here Workbench text editor, update forms and outline and properties views. JFace text is inside Workbench text editor. With the rich client platform level, you can see JFace, SWT, Workbench UI, platform runtime based on OSGI, and here you can see another application. Help is inside Workbench UI, editors, views, perspectives here. Here the rich client platform, the base. The E4 programming model starts with an existing principles of programming in Eclipse. Applications are made up of modular, loosely coupled components called plugins or bundles. Bundles can be made up of code written in Java and other languages, or other resources such as documentation and source code. Bundles can declare points where they can be customized or extend using extension points, and customize extend other bundles by defining extensions. Very large number of bundles can be installed at a time, but only those bundles that are actually in use will be loaded and consume system resources. Where eForce differs from the traditional Eclipse programming model is in how bundles interact with each other outside extension registry mechanism. Bundles often need to provide data and software services to other bundles in the ways that aren't suited to Eclipse extension registry. This is most commonly achieved by bundles reaching out to other bundles by directly referencing methods and constants defined in the API Java classes. Bundles would typically define entry points for obtaining singleton instances of services, for example, classes such as platform, ID, resource plugin, Java core, etc. This practice of reaching out led to tight coupling from bundles using services to a particular provider. Of that service, and the prevalence of singleton access made it difficult or impossible for alternative service implementations to be substituted, or for multiple implementations to be available at the same time. The resulting bundles were therefore difficult to reconfigure or reuse in different environments where different or multiple service implementation would be needed. The service programming models generally define the three distinct principles: service providers, service consumers, and a broker or container that manages binding service providers to consumers. Normal model, this arrow is in the other side. Basic implementation of this programming model, such as OSGI service API or Eclipse extension registry, nicely decouple service providers from consumers, but often require service providers and consumers to have explicit knowledge of particular container or service broker. The E4 programming model aims to further decoupling these participants by reducing or eliminating these explicit links from the service producers and consumers to a specific service broker technology. This new flexibility is the best explained by looking at how these three service participants are defined in E4. Context: the service broker. E4 introduces the notion of context as a generic mechanism that stores or knows how to locate services and provide them to the service consumers. At its basic level, an E4 context looks much like a Java map storing values associated with some key. A client can put values into the map or retrieve values from the map. The map can also store context functions that are pieces of code that know how to compute the context value lazily when values are requested by the client. When a client asks for a value not currently defined in the context, it will delegate to a parent context. This allows services or data to be stored in a central place and consumed by many clients. Finally, contexts have a pluggable lookup strategy that allows external parties to reach and context how to retrieve certain kind of values. Lookup strategy enables interoperability between E4 context and other service brokers such as OSGI service registry. This flexibility means all manner of different service lookup and brokerage systems can be integrated into the E4 context mechanism. This ability to create context hierarchies and insert service lookup strategies allow context to scale up from very simple map like service registration and lookup to highly complex and dynamic service abstraction, service arbitration mechanisms. Injection: service consumers. The best practice in modern service programming models is that consumers receive dependencies via dependency injection. This theoretically allows application code to completely eliminate its dependency on a particular container technology, thus enabling greater reuse. E4 directly supports and encourages dependency injection as a means to supply services to clients. Constructor, method, and field injections are all supported. The injection points can be identified in client code, either naming conventions or Java annotations. For clients that find inversion of control confusing and prefer code clarity over framework dependencies framework independence, for the E4 context API can also be used directly. The service locator design pattern. Service providers. There is a great variety in services and data that bundles make available for consumption of by other bundles. Some services are very lightweight and may be consumed and discarded thousands of times, while others are heavyweight services designed to live for long period of time. There are many different life cycles to these services. Some come and go based on the existence of a particular UI widget. Others may be tied to a life cycle of a bundle. Due to this great variety, there is no single method of service publication that is appropriate for all service providers. In general, services are published in E4 using OSGI service mechanism. Services can either be registered and removed programmatically or via OSGI declarative services. Declarative services allow the service instantiation to be delayed until required by some client. Of course, there are a wide variety of helper framework that can be used for publishing OSGI services, such as SpringDM, iPocho, Peerberry, etc. By using OSGI services as the foundation for service publication, all of these frameworks can be used seamlessly in E4. While most client code will use services, frameworks that create context can simply add services directly to a context where appropriate. For example, a service associated with the widget may want to register with the context with the widget constructor and withdraw the service when the widget is disposed. Manual registration allows the service to be made available only to a specific context rather than making it globally available via OSGI services. Finally, context supports outjection, reverse injection of services back into the context via a field or accessor method. Putting this all together, we have a model where a typical service consumer knows nothing but who provided the service, about what broker is used to bind and obtain service. The service producer can also be largely decoupled from the service broker by separating the service configuration data from the service implementation itself, either using declarative mechanisms such as DS outjection, or simply by separating the framework aware code doing registration from the service implementation itself. This model is illustrated in this figure. And Eclipse application services, the 20 things. To support this decoupled service programming model, Eclipse API need to be made available as services rather than via the singleton accessor model in the past, platform, Workbench, etc. However, over the years, Eclipse platform has accumulated a vast API, of which many components use only a few. This API breadth alone make Eclipse a challenging platform to build applications on. The steep learning curve increases time to value and discourage casual developers from building on platform. This is being addressed in E4 by defining a core set of services that capture a broad swath of platform functionality. The goal is that many developers should be able to build well integrated E4 bundles using only these core services. These core services are occasionally referred to in E4 discussions as 20 things to capture the fact that it is bounded the set of important services. The core services also define good starting point for integration of the Eclipse platform with other programming languages. Here you can see a service broker context. Service broker context is connected to here service declaration through service introspection or outjection. Service declaration is connected to producer here. Here service broker context is connected to consumer through service injection. Here you can see renderer and style data flow. While the basic translation of Workbench model into widget is performed by the renderer, a pluggable styling engine is used to customize the fonts, colors, and other aspects of widget representation. As we have learned from the evolution of web presentation technologies, separating document structure HTML from CSS, from style, CSS is a powerful way to ensure the consistent look and feel across many documents, and to allow style changes to be made easily in a single place. The E4 styling engine has no knowledge of the model-based UI, and in fact it can run as completely independent piece on earlier Eclipse versions. It can run as a completely independent piece on earlier Eclipse versions. The engine takes concrete widgets and styling data as input and perform the styling on the instantiated widgets to produce the styling result. This figure shows the flow from the model into widget via one or more renderers, and then to styled output using the styling engine and the declarative styling engine and the declarative styling data, the CSS files. The declarative styling support in E4 is based on standard CSS syntax. A large subset of standard HTML CSS property names and type formats are supported, as such as fonts, margins, and colors. In addition, E4 has custom properties and pseudo selectors specific to many Eclipse widgets. CSS supports the standard set of selectors mapped where appropriate to SWT, where in CSS you would use type selectors. In E4 you can use the widget class name as a selector. CSS selectors and IDs are also supported, so that the same widget can be styled in different ways. For example, the views might be tagged .views and editors with the different styling rules for each. Here you can see inside model, M application is connected to M window is connected to M menu, and M part is connected to M shash. Model is connected to widgets via renderers. Inside widgets you can see shell is connected to menu and composite, and composite interacts with the shash. Here you can see style data, widgets and style data are connected to styled widgets via styling engine. Here you can see E4 JavaScript framework. The past few years has been a blurring of distinction between browser-based applications and traditional desktop applications. Browsers and widgets and the language frameworks within them are beginning to approach the sophistication of desktop operating systems. At the same time, desktop applications are becoming more web-enabled and are adopting some of the user interaction and stylistic trademarks of web applications. While there will be demand for both traditional desktop and browser applications for some time, there is increasing demand for software components to be able to live in both of these worlds. In component-oriented software such as Eclipse, we no longer select the target platform and then build a monolithic software stack on top. We begin with a large collection of available components and then stitch them together to build an application that suits our requirements. If we can reuse the same components in multiple runtime environments, it greatly reduces development and maintenance costs. E4 is exploring component reuse across multiple target platforms and technologies in a number of ways. One such area is writing Eclipse component in JavaScript. As the de facto standard language for client-side browser programming, JavaScript is a good choice for anyone seeking to write components that will run in a broad set of runtime environments. To that end, E4 is investigating bringing both the benefits of Eclipse to the JavaScript world, modularity, extensibility, and tooling, and JavaScript components into the Eclipse desktop environment. While the current E4 focus is on JavaScript, the intent of this work more generally is to make it easier to write Eclipse components in a variety of different languages. While JavaScript has long been used as a browser scripting language, it has rarely been used to build large-scale applications like we see in the Java world. One weakness in this area is lack of good modularity mechanism. There is no mechanism for defining and accessing namespaces for expressing the dependencies of segments of JavaScript code or for querying and consuming services defined in other components in an extensible way. In Java and Eclipse, we have the powerful and mature OSGI modularity system, among others, that satisfy these requirements. To address this limitation, E4 includes a modularity framework based on OSGI for use in JavaScript applications. As well as integration of JavaScript bundles in a traditional Java-based OSGI runtime. This figure illustrates the architecture of E4 JavaScript framework and its relationship with pure JavaScript bundles as well as regular Java bundles. The E4 JavaScript framework is written in Java and runs as a pure OSGI bundle. It is responsible for parsing the manifest of JavaScript bundles and performing resolution of dependencies between JavaScript bundles. The OSGI framework has no knowledge of JavaScript bundles or their dependencies. The JavaScript framework essentially runs as a complete nested framework within an OSGI instance. Here you can see a JS bundle is inside JavaScript, and in Java side you can see these bundles and registration, extension registry, service registry, OSGI framework, Rhino, and Java virtual machines are inside Java section. Here bundles are connected to bundles, and this bundle is connected to plugged into a JS bundle, and here JS bundle is connected to bundle here, and bundle is connected to here service registry, and this bundle is connected to OSGI framework. Here extension registry is extension registry, service registry, and this bundle, and E4 JS framework are connected to OSGI framework here, and here JS bundle is connected to E4 JS framework. E4 JS framework is connected to OSGI framework and Rhino. OSGI framework and Rhino are connected to Java virtual machine here. And as an extra information, I can describe furthermore this architecture. The OSGI framework has no knowledge of JavaScript bundles or their dependencies. The JavaScript framework essentially runs as a complete nested framework within OSGI instance. Dependencies between JavaScript bundles and bundles can be expressed as at the bundle level, as with the require bundle OSGI header, or at the level of individual script files similar to the import package OSGI header. These dependencies are expressed in JavaScript manifest written as JSON file. The JavaScript bundle can be defined and installed into the framework programmatically, and or the presence of JavaScript bundle can be declared in a regular OSGI bundle using an additional manifest header, JavaScript bundle colon script manifest.json. Although JavaScript and Java bundles can interact with each other by direct invocation, the recommended way to interact between two worlds is via the OSGI service registry or Eclipse extension registry. For example, the JavaScript bundle can also declare itself as a regular OSGI bundle and contribute a service to OSGI service registry, either programmatically or using declarative mechanisms such as OSGI DS. Regular OSGI bundle can then consume that service without ever knowing the implementation of that service is written in JavaScript. Similarly, the E4 JavaScript framework provides an Eclipse extension factory for instantiating Eclipse extensions written purely in JavaScript. A JavaScript bundle can simply declare a plugin.xml file with their contribution to the extension registry without writing a line of Java code. Bundles written in Java can then consume those extensions without knowing they are written in another language. Conversely, a JavaScript bundle can declare an extension point with some corresponding Java API that can be implemented by Java bundles. and then load and use extensions contributors to that extension point in JavaScript code. This type of interaction between JavaScript and Java bundles are illustrated in this figure. The E4 JavaScript framework itself defines API in both Java and JavaScript. Thus, pure Java bundles can query and manipulate the JavaScript framework. For example, install a new JavaScript bundle, and bundles written in JavaScript can interact with the framework through its JavaScript API. This is illustrated in this figure by the E4JS framework block extending across the Java and JavaScript boundary. The E4 programming model also facilitates integration of components written in other languages. With service-based interaction between components and dependency injection, components never need to know what language services are implemented in or what languages are being used to consume the services they expose. Similarly, the pared down Eclipse application services can be exposed as API stubs in other languages, so that a broad segment of Eclipse platform functionality can be quickly made available to other bundles written in other languages. A small JavaScript API for interacting with these core E4 services is currently available in the bundle org.eclipse.e4.ui.web. As a proof of concept, E4 includes a re-implementation of plugin development environment (PDE) update site editor written purely in JavaScript. This editor can be run in a web browser or seamlessly integrated into the Eclipse platform user interface. Here you can see XWT architecture. XML UI XML UI for SWT is a framework for writing SWT widgets declaratively in XML. In XWT, the complete structure of an application or widget hierarchy is expressed declaratively along with bindings of widgets to some underlying application model. Or to a Java-based callbacks implementing the widget behavior. XWT takes declarative UI as input along with the application model that will be bound to the widgets at runtime. XWT includes a simple model for classes that will be bound to the classes that conform to Java Bean conventions of simple data accesses and setter methods. Additional models can also be defined and contributed to XWT via an extension point. The declarative UI data and model definition are, are combined by the XWT UI generator to produce the resulting SWT and JFace controls at runtime. This XWT architecture is illustrated in this figure. Here you can see XML data. The and here the model data. Here person is connected to name and address. Here XML data and model data are connected to XWT. Here XML load is here XML load is connected to UI generator. Here Java Bean model and other models are connected to model provider, model and metadata meta model provider. Meta model provider is connected to UI generator. Here XWT is connected to widgets. Here composite is connected to label, list viewer and group. Group is connected to label and button. Here you can see toolkit model architecture. The toolkit model TM is an abstract EMF model of user interface elements. This model is bound to a set of concrete widgets such as SWT. At runtime, the TM builder maintains synchronization between this model and the concrete widgets as application runs, propagating changes in both directions as required to keep the model and widgets synchronized. Applications typically interact at runtime with the toolkit model rather than concrete widgets, resulting in a simpler abstraction for application developers to work with. The higher level widgets abstraction makes it possible to change widgets implementation either in subtle ways or radical changes such as interacting with the concrete widgets instances running in different processors or different physical machines. For example, an application running on a web server can be manipulating a toolkit model living on a server. The TM runtime can transparently implement that model with widgets running on a different machine, such as a browser-based web client. Events in the toolkit model are handled by event handlers written in JavaScript, although Java can also be used. JavaScript interacts with toolkit model in much the same way the JavaScript manipulate an HTML document object model. Object model DOM in a web browser. Since graphical tools are available for building and manipulating EMF models, this combination of EMS and JavaScript allows for rapid prototyping of application design behavior. This figure illustrates the toolkit model architecture. A builder is responsible for creating widgets and binding them to the model. The builder does this by finding a suitable binder for each kind of widgets being constructed. The binder constructs the concrete widgets and manages the synchronization between widgets and model elements after construction. There is no one binder for each kind of widgets, rather than one binder per widget instance. JavaScript code supplies the model with the behavior both callbacks from widget events and other application behavior. Here you can see JavaScript is connected to toolkit. Here you can see the code. In toolkit here you can see here composite, tab folder and push button. Here composite is connected to tab folder and push button. Toolkit model interacts with binders. And builders is connected to binders. Here SWT builder and other builders are inside builders. Binders interacts with toolkit model and widgets. Control binder, layout binder and tab binder is inside the binders here. In widgets you can see composite is connected to label and list viewer, and group is connected to label and button. Now we are considering a project and its corresponding folders. The basically how files are organized. The truth is it's entirely up to you. You have basically two options for organizing your files. Eclipse can do it for you. You can do it yourself. If you are not interested in letting Eclipse organize your files for you, you may feel free to skip the rest of the description, and also skip setting up your workspace part. Workspaces and projects. Eclipse uses two basic abstractions to manage your code: a workspace, a working directory for all of your projects. Think of it like My Documents in the Windows operating system. It's a folder which contains a lot of your documents, but there's nothing to prevent you from creating another folder called My Other Documents, for instance, to house other documents. Typically you only need one workspace, and you can think of it as your My Documents for Java code. If you wanted to, you could have more than one, but chances are you won't have a use of more. Projects, a collection of related code, generally speaking. Each project encompasses one independent program. Each programming assignment you do will typically require its own projects. In short, your workspace is going to contain a lot of projects. It will be the folder that holds all your projects, and that's mostly all it is, a folder on your hard drive. Workspace and project organization. Whenever you make a project inside of Eclipse will automatically create a new folder in your workspace with the same name. Inside that folder, it will create two folders, bin and src source. The bin folder can be ignored. This is nothing more than the folder in which Eclipse stores the .class files generated by compiling your code, which it does automatically. The source folder is where all your Java files will be saved. So in the end, there's no voodoo going on under the hood. It's very simple. Your workspace is the containing directory for your projects, which are in turn directories named after corresponding projects. Pros and cons. Pros, you don't need to create directories or move files by hand. Your workspace is self-contained. You keep it on flash drive, or for instance, you can pop it into the lab computer, boot Eclipse, and just point Eclipse to your on USB key workspace directory, and voila, all your projects load along with your projects and workspace configurations. Cons, you can't put different projects in completely different directories without making separate workspaces. It may not always be clear to you where your stuff is. Here you can see bin and source and .class path and .projects under the project directory, and fibogui.java and fibonacci.java inside the src directory. This is a navigator view. In the package view, you can see the package structure here. The source, the default package is in source src here. Now we are focusing on Workbench. The Workbench provides the user interface structure for Eclipse. The purpose of the Workbench is to facilitate the seamless integration of tools. These tools contribute to extension points defined by the Workbench. The Workbench is responsible for the presentation and coordination of the user interface. The tools metaphor is not specific to development tools but can apply equally well to arbitrary applications. Note that the Workbench is sometimes called the generic Workbench to distinguish it from its instantiation in the Eclipse IDE, where it is called the IDE Workbench. Unlike SWT and JFace, which are both general purpose UI toolkits, the Workbench provides the UI personality of the Eclipse platform and supplies the structures in which tools interact with the user. Because of this central and defining role, the Workbench is synonymous with the Eclipse platform UI as a whole, and with the main window the user sees when the platform is running. The Workbench API is dependent on the SWT API and to a lesser extent on the JFace API. The Workbench implementation is built using both SWT and JFace. Java AWT and Swing are not used. Here you can see ownerships of views and editors. The Workbench contains one or more Workbench windows, each of which contains 0 or more Workbench pages. The Workbench window supplies the trim widgets, and the Workbench page supplies the window contents. In theory, The Workbench window can contain any number of pages, but in practice there is never more than one page in a window. Views and editors are owned by page. Through a view factory and editor manager respectively. Editor manager stores the list of editors and their shared resources, and view factory stores a reference counted list of views. The Workbench works in terms of editor references and view references, and in situations where the distinction between editors and views is not important, we will simply use the term part. The implementation of the part, typically an iEditor part or iView part, is created lazily when it is first needed. A part reference exists for every tab, but the implementation is only created the first time it becomes visible. The page owns a set of perspectives. Perspectives contains a layout and information about what action sets to enable. Although perspectives appears to contain views and the editor area, they only own a layout. Page itself maintains a reference count for how many perspectives are using each view, and has complete ownership of the parts and editor area. Not shown in this figure are classes perspective helper and editor area helper. Workbench contains Workbench windows. Workbench window contains Workbench pages, and Workbench page contain a editor manager, a view factory, and perspectives. Editor manager contains editor references, and editor reference contain 0 or 1 iEditor part. View factory contains reference counts, and reference count is connected to view reference. View reference contains 0 or 1 iView part. Perspective is connected to reference count, and increments are passed from perspective to reference count. Here you can see Workbench objects and what they look like. The Workbench contains one or more Workbench windows. Each of which contains 0 or more Workbench pages. Workbench window supplies the trim widgets, and the Workbench page supplies the window contents. In theory, a Workbench window can contain any number of pages, but in practice, there is never more than one page in a window. View and editors are owned by the page through a view factory and editor manager respectively. Editor manager stores the list of editors and their shared resources, and view factory stores a reference counted list in a list of views. Workbench works in terms of editor references and view references, and in this art and in situations where the distinction between editors and views are not important, and we will simply use the term part. The implementation of the part, typically iEditor part or iView part, is created lazily when it is first needed. As shown in this figure, a part reference exists for every tab, but the implementation is only created the first time it becomes visible. The page owns a set of perspectives. Perspectives contains a layout and information about what action sets to enable. Although perspective appears to contain views, an editor area, they only own a layout. Page itself contains a reference count for how many perspectives are using each view, and has complete ownership of the parts and editor area. Not shown in this here are the classes perspective helper and editor area helper. Now here you can see the workbench, some of the visual components that make up the workbench. The workbench provide an extensive set of classes and interfaces for building complex user interfaces. Fortunately, you don't need to understand all of them to do something simple. We will start looking at some concepts that are exposed in the workbench user interface and their corresponding structure under the covers. Workbench. We have been using the term workbench loosely to refer to that window that opens when you start the platform. Let's drill down a little and look at some of visual components that make up the workbench. For the rest of the discussion, when we use the term workbench, we will be referring to the workbench window. iWorkbench window. The workbench window is the top level window in a workbench. It is the frame that holds the menu bar, toolbar, status line, shortcut bar, and pages. In general, you don't need to program to the workbench window. You just want to know that it's there. Note, you can open multiple workbench windows. However, each workbench window is a self-contained world of editors and views. So, well, Yeah, so we will just focus on single Workbench window. From the user's point of view, the Workbench contains views and editors. There are a few other classes used to implement the Workbench window. Page, inside the Workbench window, you will find one page, iWorkbench page, that in turn contains parts. Pages are an implementation mechanism for grouping parts. You typically don't need to program to the page, but you will see it in the context of programming and debugging. Perspectives. Perspectives provide an additional layer of organization inside the Workbench page. A perspective defines an appropriate collection of views, their layout, and applicable actions for a given user task. Users can switch between perspectives as they move across tasks. From an implementation point of view, the user's active perspective controls which views are shown on the Workbench page and their positions and sizes. Editors are not affected by a change in perspectives. Views and editors. Views and editors are where we move beyond implementation details into some common plugin programming. When you add the visual components to the Workbench, you must decide whether you want to implement a view or an editor. How do you decide this? A view is typically used to navigate a hierarchy of information, open an editor, or display properties for the active editor. For example, Project Explorer view allows you to navigate to the workspace hierarchy. The properties and outline views show information about an object in an active editor. Any modification that can be made in a view, such as changing property value, are saved immediately. Editor. An editor is typically used to edit or browse a document or input object. Modification made in an editor follows an open save close model, much like an external file system editor. Platform text editor and Java editor are examples of Workbench editors. Here you can see a Workbench window, and here you can see the page, and here you can see the views and the here editor. So inside the Workbench you can see page, menu bar, toolbar. So views and editor are inside the page. Now we are considering building your Vivo editor according to a common life cycle. Here you implement create part control method to create SWT widgets that represent your visual components, you must determine which widgets to use and allocate any related UI resources needed to display your view or editor. When your view or editor is given focus, you will receive a set focus notification that you can set the focus to the correct widget. When your view or editor is closed, you will given a dispose message to signify the view or editor being closed. At this point, the control allocate create part control have already been disposed for you, but you must dispose any graphic resources such as cursors, icons or fonts that you allocate for the view or editor. Throughout this life cycle events, throughout this life cycle, event will fire from containing workbench page to notify interested parties about opening, activation, deactivation, and closing of views and editors. Seems simple. It can be. That's the beauty of workbench views and editors. They are just widgets holders and can be as simple or complex as you need them to be. We saw the simplest of views earlier when we built a hello world view. Let's look at it and look at this code again. Notice that we didn't have implement the dispose method, since we didn't do anything but create a label in the create part control parent method. If we had allocated any UI resources such as images, fonts, we would have disposed of them here. Since we expect the view part class, we inherit the do nothing implementation of dispose. As an example, we can consider a workbench class. The workbench class represents the top of the Eclipse user interface. Its primary responsibility is the management of workbench windows, dialogues, wizards, and other workbench related windows. Note that any code that is run during the creation of a workbench instance should not require to access to the display. This class is in package org.eclipse.e4.ui.internal. As an example 2, setting workbench preferences lets you set up the workbench to suit your needs. Open the step 1. Open the workbench and click Tools, Preferences. The Preferences dialog appears. The step 2. Set the preferences you want to use for your workbench sessions and click OK to save changes and dismiss the dialog, or click Apply to apply changes only. Step 3. Optional. Click the Restore Default button to restore dialog settings for the currently displayed preferences to their default values. Your workbench preferences are set. As an example 3, we are considering package org.eclipse.e4.ui.workbench. Application programming interfaces describing Eclipse for handlers and the workbench. Now we are considering a quick tour of the workbench in extending the workbench. When you open your workbench on a set of projects, it looks something like this. The workbench is the cockpit for navigating all of the functionality provided by plugins, By using the workbench, we can navigate resources and we can view and edit content and properties of these resources. When you open your workbench on a set of project, it looks something like this. The workbench is just a framework that can present various visual parts. These parts fall into two major categories: views and editors. Editors allow the user to edit something in the workbench. Editors are document-centric, much like a file system editor. Like file system editors, they follow an open save close file lifecycle. Unlike file system editors, they are tightly integrated into the workbench. Views provide information about some object that the user is working with in the workbench. Views often change their content as the user selects different objects in the workbench. Views often support editors by providing information about the content of the active editor. Views, the workbench provides several standard views that allow the user to navigate or view something of interest. For example, the Project Explorer lets the user navigate the workspace and select resources. Editors allow the user to open, edit, and save objects. The workbench provides a standard editor for text resources. Additional editors such as Java code editors or HTML editors can be supplied by plugins. Now we are considering views and editors. Let's look at it. Look this code. Class view part, abstract based implementation of all workbench views. This is in the package org.eclipse.ui.part. Views and editors are where we moved beyond implementation details into some common plugin programming. When you add the visual components to the workbench, you must decide whether you want to implement a view or an editor. How do you decide this? A view is typically used to navigate a hierarchy of information, open an editor, or display properties for the active editor. For example, Project Explorer view allows you to navigate workspace hierarchy. The properties and outline view show information about an object in the active editor. Any modification that can be made in a view, such as a change in property value, are saved immediately. Editor is typically used to edit or browse document or input object. Modification made in an editor follows an open save close model, much like an external file system editor. Platform text editor and Java editor are examples of workbench editors. In either case, you will be building your view or editor according to a common lifecycle. You implement a create part control method to create the SWT widgets that represent your visual component. You must determine which widgets to use and allocate any related UI resources needed to display your view or editor. When your view or editor is given the focus, you will receive a set focus notification so that you can set the focus to the correct widget. When the view or editor is closed, you will receive a dispose message to signify that the view or editor is being closed. At this point, the controls allocated in create part control have already been disposed for you, but you must dispose any graphical resources such as cursors, icons, or fonts that you allocated for the view or editor. Throughout this life cycle, events will fire from the containing Workbench page to notify interested parties about the opening, activation, deactivation, and closing of views and editors. Seems simple. It can be. That's the beauty of Workbench and views and editors. They are just widget holders that and can be as simple or complex as you need them to be. Here, notice that we didn't have to implement the dispose method, since we didn't do anything but create a label in the create part control parent method. If we had allocated any UI resources such as images or fonts, we would have disposed them here. Since we extend the view part class, we inherit the do nothing implementation of dispose method. This set focus to my widget for a label. This doesn't make much sense, but for more complex sets of widgets, you would decide which one get the focus. Now we are considering org.eclipse.ui.views in basic Workbench extension point using commands. First, let's take a look at the declaration of the extension in the plugin.xml. Here the identifier org.eclipse.ui.views. This extension point is used to define additional views for the Workbench. A view is a visual component within a Workbench page. It is typically used to navigate hierarchy of information like the workspace, open an editor, or display properties for the active editor. User can make a view visible from the window, then show view menu, or close it from the view local title bar. A view is a Workbench part that can navigate a hierarchy of information or display properties for an object. Only one instance of any given view is open in a Workbench. When a user makes selections or other changes in a view, those changes are immediately reflected in the Workbench. Views are often provided to support corresponding editor. For example, an outline view shows a structured view of information in an editor. A properties view shows the properties of an object that is currently being edited. At the extension point, org.eclipse.ui.views allows plugins to add views to the Workbench. Plugins that contribute a view must register the view in their plugin.xml file and provide configuration information about the view, such as its implementation class. The category or group of views which it belongs, and the name icon that should be used to describe the view in menus and labels. the interface for views is defined in iViewPart, but plugins can choose to extend the viewPart class rather than implement an iViewPart from scratch. We implemented a minimal view extension in the here. Now we will look at one that is aware to other Workbench views and responds to user navigation and selection changes in the Workbench. First, let's take a look at the declaration of the extension in the plugin.xml. This look pretty familiar. We will see that the new view info view is contributed to the Workbench. The view ID name and category are specified as we seen before. When we show the info view, the view within a list, pops up the list pre-populated with some data. We will start with the familiar create part control method as we show before. This is where the widgets are represented, a view created. We will ignore some of the code to get started. The view creates and stores a list viewer and sets the content and label providers. It also registers itself as a selection provider. Here you can see it's register itself as the view creates and stores a list viewer here. And label providers. It also registers itself as a selection provider for this view. The concept of selection provider, label provider, and content provider come from the JFace viewers. It obtained the service from its iView site. Which contains the information about the view's context, such as its Workbench window, its containing page, its local services, and its plugin. We have covered a lot of common Workbench concept by studying this extension here. Now service will be providing our input. Register myself as a selection provider for this view. Now we are considering plugin definition in plugin class. The readme tool plugin is defined in the manifest.mt file. The plugin definition includes bundle name, bundle symbolic name, plugin ID, bundle version, and bundle vendor of the plugin. We saw the most of these parameters before in our we can see the parameters here. The contribution plugin also defines a specialized plugin class org.eclipse.ui.examples.contributions.activator. The require bundle element informs the platform of the contribution plugins dependencies. The Workbench UI plugins are listed as required plugins. Along with the various core and expression plugins. Now we are considering contributing preference page in preference pages. The readme tool uses this extension point to add the readme example preference page. Here the identify org.eclipse.ui.preference pages. The workbench provides one common dialog box for preferences. The purpose of this extension point is to allow plugins to add pages to the preference dialog box. When preference dialog box is opened, initiated with from the menu bar, pages contributed to this way will be added to the dialog box. The org.eclipse.ui.preference pages extension point allows you to contribute pages to the general preferences window preferences dialog. The preference dialog presents a hierarchical list of user preference entries Each entry displays a corresponding preference page when it's selected. The readme tool uses this extension point to add the readme example preference page. This markup defines the preference page name readme example. Which is implemented by the class readme preference page. The class must implement the iWorkbench preference page interface. The Workbench uses core runtime preference mechanism to access all nodes in the preference tree and their corresponding pages. This list can be initialized from the information in the preferences services without running any plugin code. Now we are considering new Shift Alt N in file menu in Workbench menus. Enables you to create new resources before you can create a new file. You must create a project in which to store the file. The undo in edit menu. This command reverses your most recent editing action. Go into in navigate menu. This command refocuses the active view so that the current selection is at the root. This allows web browser style navigation within hierarchies of artifacts. Open project in project menu. This command opens the currently selected project or projects. The selected projects must currently be closed for this command to be available. New window in window menu. This command opens a new Workbench window with the same perspective as the current perspective. Help contents in help menu. This command displays the help content in a help window or external browser. The help contents contains help books, topics, and information related to the Workbench and installed features. Now we are here we are considering exiting the Workbench. To exit the Workbench, select File, then Exit from the menu bar or close the Workbench with the window close button X. Each time the Workbench is exited, the Workbench is automatically saved, including all open perspectives and windows. The next time the Workbench is reopened, it will appear exactly as it was when it was last closed. To exit the Workbench, select File, then Exit from the menu bar or close the Workbench with the window close button X. When the latter option is used, a prompt will ask if you ready to wish to exit the Workbench. Note, this dialog also presents an option to turn off the prompting. To turn it back on, open the preferences dialog and choose the general, then startup and shutdown preference page. Check the confirm exit when closing last window checkbox. Now we are considering files in resources. Files comparable to files as you see them in the file system. Now we are considering a root in resource hierarchies, the top level of the workbench content in the file system. Now we are considering linked resources. The linked resource target path can be changed by selecting edit button in the file, then properties, then resource property page of the linked resource. Linked resources are files and folders that are stored in locations in the file system outside of the project location. These special resources can be used to add files and folders to your project that for some reason it must be stored in a certain place outside of your project. For example, a linked resource folder can be used to store built output separately from your resource file. You can even use linked resource to overlap the other resources in the workspace, so resources from one project can appear in another project. If you do want to have overlapping resources in your workspace, do so with caution. Keep in mind that this means changing a resource in one place will cause simultaneous changes in the duplicate resource. Deleting one duplicate resource will delete both. Deleting a linked resource will not cause the corresponding resource in the file system to be deleted. However, deleting child resources of linked folders will cause them to be removed from the file system. Linked resource target paths can be either defined as absolute path or relative to a path variable. The linked resource target path can be changed by selecting edit button in the file, then properties, then resources property page in the linked resource. A list of linked resources that exist in the project can be seen and edited from the file, then properties, then resource, then linked resource property page under the linked resource tab. Some plugins built on top of the Eclipse platform are not compatible with linked resources. If this is the case, you can completely disable the linked resource feature to prevent them from being created in your workspace. Linked resources can be disabled from the general, then workspace, then linked resources preferences page. Certain types of project or team repository providers may also disallow linked resources from being created in some projects. Now we are considering virtual folders. Virtual folders are folders that exist only in the Eclipse workspace tree and have no file system location. By using virtual folders, files and folders can be organized in a project hierarchy independently of the file system location of those resources. Regular file and folder resources cannot be created under virtual folder since they need the file system location as their parent in order to exist in the file system. Only other virtual folders or linked resources can be created directly under a virtual folder. Now we are considering path variables. Each project contains a predefined set of path variables available for defining linked resources, including Eclipse _home, parent _lock, project locked, and workspace lock. Path variables specify location on the file system. Location of linked resources may be specified relative to these path variables. They allow you to avoid reference to a fixed location on your file system. By using path variable, you can share projects containing linked resources with team members without requiring the exact same directory structure as on your file system. Path variables can be either defined at the project level or at the workspace level. Creating path variables at the project level ensures that projects that contain linked resources using those path variables remain portable across workspace and computers. Each project contains a predefined set of path variables available for defining linked resources, including Eclipse home, parent lock, project lock, and workspace lock. Now we are considering resource filters. Ensure resource filters can be created, edited, and removed in the file system. Removed in the file, then properties, then resource, then resources filters property page for a project or folder resource. Resource filters allow you to configure which files and folders are included automatically in a project resource hierarchy when refresh is performed. By adding resource filters to a project or folder, you can systematically prevent some file system entries to be displayed in the resource tree. A resource filter is either include only or exclude all type and can apply to either files, folders, or both. Resource filters only apply to files and or folders that are implicitly included in the workspace by the refresh operation. Link files and folders are not affected by resource filters since they need to be created explicitly by the user. The include resource filter allows only files or folders that match the filter condition to be included in the workspace during refresh operation. If multiple include filters exist, the element included will those who match any of the existing include filters. The exclude resource filter prevent all files or folders that match the filter condition to be included in the workspace during refresh operation. If the multiple exclude filters exist, the element excluded will be those who match any of the existing exclude filters. If both exclude and include filters exist in the given folder or project, only files or folders that match any of the include filters and do not match any of the exclude filters will be included in the workspace. Resource filter can apply recursively to all children of the project or folder it is created in. In such case, the resource filter will apply to a subfolder as if it was created in that subfolder itself following the rules mentioned above. Resource filters can be created, edited, and removed in the file properties, resources, and then resource filters property page for a project or folder resource. Resource filters can also be created in a folder before that folder is created in the workspace by setting resource filters button in the advanced section of the new folder wizard. Now we are considering working sets. In order to modify the window working set, you need to enable the window working set command group via window, then perspective, then customize perspective. Working sets group elements for display in views or for operations on a set of elements. The navigation views use working sets to restrict the set of resources that are displayed. If a working set is selected in the navigator, only resources, children of resources, and parents of resources contained in the working set are shown. The problems view, task view, and bookmarks views can also be filtered based on the working set via the filters view menu item. When using the search facility, you can also use working sets to restrict the set of elements that are searched. Different views provide different ways to specify a working set. The views in the Eclipse SDK use window working set by default. The window working set is initially empty. In order to modify the window working set, you need to enable window working set command group via window, then perspective, then customize perspective. You can then modify the window working set via window, then working set menu, or via corresponding toolbar button. Views that supports the working set use the working set selection dialog to manage existing working sets and to create new working sets. Now we are considering builds. You can configure your preferences, command link general, then workspace to perform builds automatically on resource modification. A build is a process that derived new resources from the existing ones, updates the existing resources or both. In the workbench, different builders are invoked for different types of project. For example, when a build is triggered for a Java project, a Java builder converts each Java source file .java files into one or more executable class files .class files. Builders usually enforce the constraint of some domain. For example, a web link builder could update links to files whose name or location changes. There are two kinds of builds. An incremental build leverages a previously built state and applies the forms of the configured builders to the resources that have changed since the previous state was computed, that is, since the last build. The other one is a clean build, discard any problems and previously built state. The next build after a clean will transform all resources according to the domain rules of the configured builders. Incremental and clean builds can be done over a specific set of projects or workspace as a whole. Specific files and folders cannot be built. These are two ways that builds can be performed. Automatic builds are performed as a resource are saved. Automatic builds are always incremental and new operate over entire workspace. You can configure your preferences, general then workspace, to perform builds automatically on resource modification. The other way is manual builds. Manual builds are initiated when you explicitly select a menu item or press the equivalent shortcut key. Manual builds can be either clean or incremental and can operate over collections of projects or the entire workspace. Now we are considering local history. A local edit history of a file is maintained when you create or modify a file. A local each time you edit and save the file, a copy is saved so that you can replace the current file with the previous edit or even restore a deleted file. You can also compare the content of all the local edits. Each edit in the local history is uniquely represented by the date and the time of the file was saved. Only files have local history. Projects and folders do not. Sorry, it means only files have local history. Projects and folders do not. Now we are considering customize welcome dialog in customizing welcome in customizing the workbench. Option home page theme. This option will change the overall appearance of welcome. Default to circles. Now we are considering rearranging the main toolbar. You can rearrange sections of the main toolbar. Toolbar sections are divided by a thin vertical line. Step 1, make sure the toolbar is unlocked. The toolbar is unlocked if it has thick vertical bars next to the thin vertical bar dividers. If it is locked, unlock the toolbar by right-clicking the toolbar and selecting the lock the toolbar's menu item. Step 2, grab the section of the toolbar you want to rearrange by moving the mouse over the thick vertical line on the left side of the desired segment. the mouse cursor change its shape to indicate that you can click to move the toolbar section. Click and hold the left mouse button and to grab the toolbar section. Move the step 3, and step 4, move the section left and right, or up and down, and release the mouse button to place it to its new location. To prevent accidental changes to the toolbar, lock it again by right-clicking the toolbar and selecting Lock the Toolbars menu item. Now we are considering changing the key bindings. Use command general, then keys preference page to assign key sequences to many of the commands in Eclipse. The function of the keyboard can be extensively customized in Eclipse. Now we are considering changing fonts and colors to change these fonts here. By default, the Workbench uses fonts and colors provided by operating system. The Workbench lets you to directly configure the following fonts: banner fonts, dialog fonts, header fonts, text font, ignored resource font, outgoing change font, console font, detail pane text, memory view table font, Java editor text font, properties file editor text font, compare text font, Java compare text font, Java properties file compare text font, part tile font, view message font. To change these fonts, open the command, open the general, then appearance, then colors and fonts preference page. Select the font you want to change. Then step 3, click edit, and step 4, use the dialog which opens the select a font. Step 5, click OK. Note you can also click use system font to set the font to a reasonable value chosen by the operating system. For example, on Windows, this will use the font selected in the display properties control panel. Plugins that use other fonts may also provide preference entries to allow them to be customized. For example, Java development tools provide a setting for controlling fonts used by the Java editor. See Java, then Java editor text font on the preference page. In addition to the above, some text is always displayed in the system font. For example, the navigator tree always does this. To change the font used in these areas, you can use the configuration tools provided by the operating system. For example, the display properties control panel on Windows, or the .xdefault file in Motif. Now we are considering controlling single and double click behavior. To do this, you can follow these steps. You can control how the Workbench responds to single and double clicks. To do this, open the general preference page. Select the behavior you want to change from the open mode group. Click OK. The effect of these selections varies by view. For example, in one of the navigation views, double click will cause a single click on a resource to select it, and a double click to open it in the editor. Single click will cause the single click on a resource to both select it and immediately open an editor on it. The checkboxes are under single click radio button further refine the single click behavior. Checking select on hover will cause the resource to be selected if you hover over it with the mouse. Checking open when using arrow keys will cause the resources to be open if you use the arrow keys to navigate it. Now we are considering importing and exporting preferences. To import preference file, you can follow these steps. Preference files can be both imported to and exported from the Workbench, allowing you to easily share individual or group preferences. The import wizard can be used to import preferences from the file system to the Workbench. To import a preference file, select file, then import. Step 2, in the import wizard, select general, then preferences, and click next. Click browse and locate the preferences file on the file system. Click import all to accept all the preferences defined in the file. If you want to import only few preferences, choose them from the list, then click finish. The export wizard can be used to export preferences from the Workbench to the file system. To export the file, select file, then export. Step 2, in the export wizard, select general, then preferences, and then click next. In step 3, click export all to add all of the preferences to the file. Step 4, if you want to export only few preferences, choose them from the list. Step 5, click browse and locate the preferences file on the file system. Step 6, click finish. Note, if no changes have been made to the original preferences settings, the preferences file will be empty. Now we are considering large file associations per product customization. Example products customization file contents to specify large file associations. The product customization file can be specified via command line parameter, plugin customization, path to file. Example products customization file contents to specify large file associations. All type with the preference needed by the preferences page UI. Default show prompt for all types that don't have preference. Specify edit associations per type and file size. Now we are considering Workbench toolbar. Here is an example of the toolbar in resource perspectives. Now we are considering performing a TCL search from the Workbench. In searching the Workbench in TCL or TCL development. Step 1, copy the contents of the http.tcl from the HTTP 1.0 standard package and paste it to the new TCL file in an exemplary project. Step 2, in the TCL perspective, click search button in the Workbench toolbar, or use TCL use search then TCL from the menu bar. If it is not already selected, select the TCL search tab. In the search string field, type http_config. In the search for area, select method, and in the limit to area, select declaration, verify that the scope is set to the workspace. Then click search. While searching, you may click cancel at any time to stop the search. Partial results will be shown. And step 5, in the TCL perspective, the search view shows the search results, and the first match is highlighted in the editor. Search results view, you may show next match, and show previous match buttons to navigate each match. In this example here, the single match. Note that if the file in which a match was found is not currently open, it is opened in an editor when you select the match in the search view. Step 6, when you navigate to a search match using the search view buttons, the file opens in the editor at the position of the match. Search matches are triggered with the search marker in the vertical ruler as on the screenshot. It's not shown here at the moment. Now we are considering performing a Java search from the workbench in searching the workbench. Step 1, in the Java perspective, click the search button in the workbench toolbar, or use search then Java from the menu bar. If it is not already selected, select Java search tab. Step 3, in the search string field, type run test. In the search for area, select method, and in the limit to area, select references. Verify that the scope is set to workspace. Then click search. While searching, you may click cancel at any time to stop search. Partial results will be shown. Step 4, in the Java perspective, the search view shows the search results. Use the show next match and show previous match buttons to navigate to each match. If the file in which the match was found is not currently open, it is open in an editor. When you step 5, when you navigate to a search match using search view buttons, the file opens in the editor at the position of the match. The search matches are tagged with the search marker in the rulers. Now we are considering workbench menu contributions in advanced workbench concepts. The extension point name menus. The command this location of actions. The commands can be placed in the main menu and toolbar. Command can be placed in part context menus as well as view menus and view toolbars. The placement is controlled by the location URI, and the visibility is controlled by the visible when co-expression. The details The extension point should be used to place commands in menus and toolbars so they can be executed by the user. Now we are considering undo and in the IDE workbench in undoable operations. This model-based registration allows plugins that manipulate the workspace to obtain the appropriate undo context, even if they are headless and do not reference any workbench classes. The interface undo context, and undo context is used to tag operations as being applicable to certain context. The undo context is used to filter the history of operations available for undo and or redo, so that only operations appropriate for a given undo context are shown when the application is presenting that context. The interface iOperation history. iOperation history tracks a history of operations that can be undone or redone. Operations are added to the history once they have been initially executed. Clients may choose whether to have the operations history perform initial execution or to simply add an already executed operation to the history. These are in the package org.eclipse.co.commands.operations. We have the notion of workbench wide undo context is fairly general. It is up to the workbench application to determine what specific scope is implied by the workbench undo context, in which views and or editors use the workbench context when providing undo support. In the case of Eclipse IDE workbench, the workbench undo context should be assigned to any operation that affects the IDE workspace at large. This context is used by the views that manipulate the workspace, such as a resource navigator. The IDE workbench install an adapter to the workspace for undo context that returns the workbench undo context. This model-based registration allows plugins that manipulates the workspace to obtain the appropriate undo context, even if they are headless and do not reference any workbench classes. Other plugins are encouraged to use these techniques for registering model-based undo context. Undoable operations are provided by IDE plugin that allows you to execute undo or redo common workspace manipulations. Operations are provided for creating, moving, copying, and deleting projects, folders, and files. IDE plugins uses these operations to provide undo support in the resource navigator. The classes that also be used by client, they are available in the package org.eclipse.ui.ide.undo. Using the workspace undoable operations is similar to the example shown for using undoable operations here. The primary difference is that the sum of the details, such as assigning the appropriate undo context, are handled internally by the operation. The following snippet here shows how to use an undoable operation for creating a new file. The operation is here. The operation is configured with the file handle for the file to be created and input stream with the initial context. And the label describing the operation. Internally, the operation will assign the workspace undo context and handle other details such as keeping track of the resources. The operation manipulates. To execute the operation, caller use the standard I operation history protocol. Note that the caller is responsible for providing the progress monitor if desired. And the I adaptable that can provide the shell that should be used for any prompting. The utility class workspace undo util provides a utility method for creating necessary adapter from the shell. Callers are also responsible for determining whether to execute the operations in the UI thread, the background, or a workbench job. If the operation should be executed in the background, then the caller should create the appropriate progress monitor and run the snippet shown here, appropriate runnable. The undo and redo of the operation will be performed by the undo and redo action handlers when the user initiate undo or redo. The standard workbench action handles use I advanced undoable operation tool protocol to determine how to perform the undo and redo operations. All of the workspace operations implement protocol that instruct client to run the undo or redo of the operation in the background if possible. Get the operation history, obtain the appropriate undo context for my model, create an operation and assign its context. Handle exceptions here. Now we are considering org.eclipse.ui perspectives in perspectives. The following markup is used by the Workbench in defining its own resource perspective. The identifier org.eclipse.ui.perspectives perspective perspectives. This extension point is used to add perspective factories to the Workbench. A perspective factory is used to define initial layout and visible action sets for the perspective. The user can select perspective by invoking open perspective submenu of the window menu. The platform itself defines one perspective, the resource perspective. Other platform plugins such as help system and the Java tooling define additional perspectives. Your plugin can define its own perspective by contributing to the org.eclipse.ui.perspectives extension point. The specification of the perspective in the plugin.xml is straightforward. the following markup used by the Workbench by defining its own resource perspective. A plugin must supply ID and name for the perspective along with the name of the class that implements the perspective. An icon can also be specified. The perspective class should implement iPerspective factory. Now we are considering decorators. This decorator is contributed by PDE using the org.eclipse.ui.decorators extension point. The identifier org.eclipse.ui.decorators. This extension point is used to add decorators to views that subscribes to the decorator manager. As of 2.1, there is the concept of a lightweight decorator that will handle the image managed for the concept of the lightweight decorator that handle the image management for the decorator. It is also possible to declare lightweight decorator that simply overlays an icon. When enabled, that requires no implementation from the plugin. Your plugin can use decorators to annotate the images for the resources and other objects that appear in the Workbench views. Decorators are useful when your plugin adds functionality for existing resource types. Many of the standard Workbench views participate in showing decorations. For example, PDE contributes decorators that allow you to distinguish between binary and source projects. The com.example.helloworld project is the only source project shown in the Project Explorer. Note how all of the other binary projects show the binary decorator at the top of the left of the project icon. This decorator is contributed by PDE using org.eclipse.ui.decorators extension point. There are several different ways to supply a decorator implementations. The markup uses the simplest way, known as the declarative lightweight decorator. When the declarative lightweight decorator is defined, the markup contains a complete description of the decorator's icon, placement, and enabling conditions. Declarative decorators are useful when only an icon is used to decorate the label. The plugin needed only to specify a quadrant where the decorator should be overlaid on the regular icon and the icon for the overlay. As shown in the picture, the PDE binary icon is overlaid in the top left quadrant of the package icon. If your plugin needs to manipulate label text in addition to the icon, or if the type of the icon is determined dynamically, you can use the non-declarative lightweight decorator. In this case, an implementation class that implements lightweight label decorator must be defined. The designator class is responsible for supplying a prefix, suffix, and overlay image at runtime, which are applied to the label. The mechanics of concatenating the prefix and suffix with the label text and performing overlay are handled by the Workbench code in the background thread. Thus, any work performed by your plugin is lightweight label decorator implementation must be UI thread safe. Now we are considering key bindings in Workbench key bindings. Plugins can define key bindings along with the commands in the org.eclipse.ui.binding extension point. The identifier org.eclipse.ui.bindings, the org.eclipse.ui.bindings extension point is used to declare bindings and schemas. Schemas are a set of one or more bindings, and a binding is a mapping between certain groups of conditions, some user input and a triggered command. Here the extension pointed code is not shown here. The association between the command and the key combinations that should invoke the command is called key binding. Plugins can define key bindings along with the commands in the org.eclipse.ui.bindings extension point. There is our friend org.eclipse.ui.file.save. In Eclipse, the Workbench registers the save action as a handler for this command ID in every Workbench window. The sequence attributes for the key binding defines the key combination that is used to invoke the command. When Workbench save action is active, the key combination Ctrl+S will invoke it, since the Workbench uses the same command ID for the save action. Now we are considering element factories in element factories. When the following code snippet is from the Workbench in the Workbench plugin.xml. The identifier org.eclipse.ui.element factories. This extension point is used to add elements factories to the Workbench. An element factory is used to recreate adaptable objects which are persisted during Workbench shutdown. When the Workbench is shut down, shown by the user, it must save the current state of the adaptable object that are shown in the Workbench, and object state is stored in by the saving the primitive data parameters of the object in a special format and memento. The ID of the factory that can recreate the object from the iMemento is also stored, and the data is saved in the file system. When a platform is restarted, the Workbench finds its element factory associated with iMemento's factory ID. It finds the factory by checking the plugin in the registry for the contribution to the org.eclipse.ui.element factories extension. The markup is pretty simple. We just have to specify the ID of the factory and the corresponding class that implements the factory. The following code snippet is from the Workbench plugin.xml. Now we are considering considering SWT and accessibility in accessible user interfaces. The SWT implements an interface, accessible listener, which provides basic accessibility information such as description of controls, help text, and keyboard shortcuts to clients. The interface accessible listener classes that implement this interface provide methods that deal with the events that are generated when an accessibility content sends a message to the control. This is in the package eclipse.swt.accessibility. Because of SWT uses the operating system's native widgets, user interface built with SWT will inherit any assistive technologies that has been installed on the host operating system. SWT implements an interface accessible listener which provide basic accessibility information such as description of controls, help text, and keyboard shortcuts to clients. If you are developing assistive technologies that need more information or want to improve upon the basic accessibility of the Workbench, you can add your own listeners and override the default accessibility behavior in the platform. See the package org.eclipse.swt.accessibility for more detail. Now we are considering single click in SWT controls. In this way, you are shielded from knowledge that which widgets event triggered the open event. The class open strategy implementation of single click and double click strategies. This is in the package org.eclipse.jface.util. In the general preferences, allow user to specify whether view should open their object on single or double click. The JFace provides a utility class open strategy to handle the logistics of single and double click at the SWT control level. The open strategy is configured by the general preferences dialog so that it honors the current Workbench open preferences. In fact, the JFace viewers use this class to implement the open listener. You must create open strategy for and associate with it with your SWT control. The open strategy will hook the appropriate events and interpret them based on your preferences. Your job is to add an open listener to the strategy that implements the code for open. In this way, you are shielded from knowledge about which widget's event triggered for open event. The other Workbench preferences for open select on Hoover open using arrow keys are also handled by open strategy. If you use JFace viewer, so open strategy class to implement this means that the right thing will happen if you use JFace viewer, so open strategy class to implement open behavior. Code to handle the open event. Now we are considering working sets. You can obtain an iWorking set iWorking set manager using iWorkbench API. The interface iWorking set manager. A working set manager stores working sets and provide property change notification when a working set is added or removed. This is in the package org.eclipse.ui. Users often find it necessary to filter views such as navigator view in order to reduce clutter. Plugins can assist in filtering using different techniques. Resource filters can be used to filter by file name. Plugins contribute resource filters that the user can enable using a viewer's filter selection dialog. Working sets can be used to filter resources by only including specified resources. Working sets are selected using the views working set dialog. If your plugin implements a view that shows resources or objects that are adaptable to iResource, you should support working sets. iWorking set manager provides API for manipulating working sets. You can obtain an iWorking set manager using iWorkbench API. iWorking set manager allows you to manipulate and create working sets. Create working set selection dialog returns a working set dialog that shows the user's current working set. You can get the selected working set from the dialog once it is closed. Create working set edit wizard returns a working set edit wizard for editing the specified working set. Get working set method returns a list of all defined working sets. Get working set string name method returns a working set specified by the name. iWorking set manager also provide property change notification as working sets are added, removed, or as they change. If your view or editor needs to respond to changes in the selected working set, it can add a listener for change underscore working underscore set underscore content underscore change. Now we are considering defining activities in filtering large user interfaces. Let's look at the first at a simplified version of how Eclipse SDK plugin defines two conventional activities, one for developing Java software and one for developing plugins. Activities are defined using here you can see the identifier org.eclipse.ui.activities. The org.eclipse.ui.activities extension point is used to declare activities and associated elements. Activities are used by the platform to filter certain plugin contributions from the user's view until such a time they express interest in them. This allows Eclipse to grow dynamically based on the usage pattern of a user. Activities are defined using org.eclipse.ui.activities extension point. Let's look at the first simplified version of how the Eclipse SDK plugin defines the two conventional activities, one for developing Java software and one for developing plugins. Activities are assigned a name and a description. Name and the description can be shown to the user whenever they are enabling and disabling conventional activities, or otherwise shown information about the activity. The ID of the activity is used when defining patterns, bindings, or other relationships between activities. Now we are considering progress service in Workbench concurrency support. The method void busy cursor while I runnable with progress runnable. Set the cursor to busy and run the runnable in a non-UI thread. Calling thread will be blocked for the duration of the execution of the supplied runnable. After the cursor has been running for get long operation time, replace with the progress monitor dialog so that the user may cancel. Do not open the progress monitor dialog if there is already a module dialog open. Interface iProgress service. The progress service is the primary interface to the Workbench progress support. It can be obtained from the Workbench and then used to show progress for both background operations and operations that run in the UI thread. This is in the package org.eclipse.ui.progress. The Workbench progress service, iProgress service, is the primary interface to the Workbench progress support. It can be obtained from the Workbench and then used to show progress for both background operations and operations that run in the UI thread. The main purpose of this class is to provide one-step shopping for running operations, removing need for plugin developers to decide what mechanism should be used for showing progress in a given situation. Another advantage is that the progress dialog shown with these methods provide the good support for indicating when an operation is blocked by another and give the user control to resolve the conflict. Where possible, long-running operations should be run using iProgress service busy cursor while. This method will initially put up busy cursor and replace it with the progress dialog if the operation lasts longer than the specified time threshold. The advantage of this method over using a progress dialog is that the progress dialog won't be shown if the operation is short running. If your operation must update the UI, you can always use display.async exec or display.async exec to run the code that modifies the UI. Non-UI work. Now we are considering contributing a property page in Workbench resource support. The README tool contributes two property pages. Identifier org.eclipse.ui.property pages. This extension point is used to add additional property page for objects of a given type. Once defined, use property pages will These property pages will appear in the properties dialog for object of that type. You can contribute a property page for an object using the org.eclipse.ui.propertypages extension point. An object property page is invoked using properties menu in any view that shows the object, such as resource navigator view. This menu is available when a single object is selected. README tool contributes to property pages. When you define a property page, you specify object class for which this page is valid. Objects of this class will include your page when the properties are shown. You may optionally supply a name filter that further refines the class. In the README tool example, the both pages are contributed for objects of type ifile with the .readme file extension. Property pages are not limited to Workbench resources. All objects showing up in the Workbench, even domain-specific objects created by other plugins, may have property pages. Any plugin may register property pages for any object type. Property pages look a lot like preference pages, except there is no hierarchy or categorization of property pages. In the dialog box, both the README property pages appear in the main list of pages. Now we are considering logging with the use of the default login mechanism in status handlers in status handling. This code is the example of addlog status property page. The class status adapter. The status adapter wraps an instance of status subclass and can hold additional information either by using properties or by adding new adapter used during status handling process. This is the package org.eclipse.ui.statushandlers. In order to log extra information with the use of the default logging mechanism, it is necessary to perform some additional steps. The status manager provides you with an API that allows you to hook into the mechanism. And this code example add logger status status proper use. Now we are considering services. For example, here the interface iHandler service provides service related to activating and deactivating handlers within the Workbench. This is in the package org.eclipse.ui.handlers. The Workbench define number of services that can be retrieved from org.eclipse.ui.services.iService locator. Services provide a way for components to retrieve information about the Workbench without always having to go to the global singleton platform UI.get Workbench. For example, here, some services provide two optional abilities which are usually specified in the services interface Java doc. Services that support listeners can clean up the listeners automatically when the component org.eclipse.ui.services.iService locator used to get the service is disposed. And other optional abilities, services can provide more localized services depending on which component they are requested from. Now we are considering Docker bow in drop cursors in Workbench window layout. Here, Docker bow here. The view will appear above the view underneath the cursor. Now we are considering editing files outside the Workbench in working with other editors. The same external editor can also be used by launching it outside of the Workbench. External editor can be launched by on a .ini file by double clicking on it in the Project Explorer. The same external editor can also be used by the launching it outside the Workbench. Step 1, close any editors that are open on the .ini file. Step 2, in the File System Explorer, navigate to the directory where the Workbench was installed and go to the Workspace subdirectory. Step 3, edit the .ini file and save it. Do not use the Workbench Project Explorer to open the editor. Step 4, return to the Workbench and in the Project Explorer view, select your project. Step 5, choose the refresh from the project's context menu. This instructs the Workbench to look for any changes to the projects that have been made in the local file system by external tools. Step 6, select the .ini file. Step 7, for the little variety, choose open with, then choose open with, then text editor from the files pop-up menu. Step 8, observe that the Workbench own default text editor is opened. In the default text editor, verify that the externally made changes are reflected in the Workbench. The Workbench stores all of its resources in the local file system. This means the System File Explorer can be used to copy files from the Workbench workspace area even when the Workbench is not running. Resources can also be copied to the workspace directly. Use refresh to update the Workbench with any changes made outside the Workbench. Now we are considering org.eclipse.ui.new wizards in Workbench wizard extension points in dialogues and wizards. The readme tool example uses this extension point definition to add readme file wizard. The identifier org.eclipse.ui.new wizards. This extension point is used to register resource creation wizard extensions. Creation wizards appear as choices with the new dialog and are typically used to create folders and files. You can add a wizard to the file new menu options in the Workbench using the org.eclipse.ui.new wizard extension point. README tool example uses this extension point definition to add the README file wizard. The category describes the grouping for the wizard. An optional parent category establishes the new category as a child of an existing category. Top level categories will appear in the file new menu. In this example, the parent category is set to an example category. Where did the parent category where did the parent category come from? The org.eclipse.ui plugin defines the standard example category in this markup here. This category appears in the file new menu. The README tools category name defines the label that is used for next layer of grouping underneath the parent category. These categories are shown as the second level in the tree shown in the new example wizard. Wizard's name and icon are shown underneath when you expand the category. The description of the selected wizard is shown at the top of the wizard when you select it. This information about the wizard appears solely because of the markup of the plugin.xml. None of the plugin code runs until the cursor and the user chooses to the next button. Once this happens, the Workbench will instantiate the wizard class specified in the markup and pass it to the expected selection class. This class identified in this extension, README creation wizard, must implement iNew wizard interface. Most wizards do so by extending the platform wizard class through this. Although this is an implementation mechanism and not required by the extension point. The wizard itself does little but create pages inside it. Let's now we are considering org.eclipse.ui.import wizards. The wizards appear uncategorized in wizard dialog. The identifier org.eclipse.ui.import wizards, this extension point is used to register import wizard extensions import wizard appear as choices within the import dialog and are used to import resources into the workbench. You can add the wizard to the file then import menu option in the workbench using org.eclipse.ui.import wizard extension point. The process for defining the extension and implementing the wizard is similar to org.eclipse.ui.new wizards. The primary difference is the markup is that import wizard do not define or assign categories for the wizards themselves. Wizards appear uncategorized in a wizard dialog. The wizard supplied in the class parameter for the markup must implement iImport wizard. Its pages are typically extended from wizard import page. Now we are considering org.eclipse.ui.export wizards. The wizards appear uncategorized in the wizard dialog. The identifier org.eclipse.ui.export wizards. This extension point is used to register export wizards extensions. Export wizards appear as choices within the export dialog and are used to export resources from the workbench. You can add a wizard to the file then export menu option in the workbench using the org.eclipse.ui.export wizards extension point. The process for defining the extension and implement the wizard is similar to org.eclipse.ui.new wizards. The primary difference is the markup is that export wizards do not define or assign categories for wizard themselves. The wizards appear uncategorized in a wizard dialog. The wizard supplied in the class parameter of the markup must implement iExport wizard. Its pages are typically extended from wizard export page. Now we are considering properties view in Workbench integration with web editors in creating web applications. The properties view window then show view then properties contains a list of attributes and editable attributes values. For example, when you select an image tag img, width and height values appear for editing. In addition, any other attributes allowed by the standard specified in the doc type for the file, such as the HTML 4.0, 4.0.1 DTD, are listed. When you click the value column of the property, you can select from among the list of available attribute values. The pop-up menu in the properties view enables you to undo, cut, copy, paste, delete, and select all. The options that are available at a given time depends on where the cursor is located. When you right-click to display the pop-up menu, to see the pop-up menu that contains undo, cut, and so on, the property value field must be active. This is accomplished by selecting the property and then selecting its value. Otherwise, the pop-up menu will contain different options. Use the restore default value button to change any value back to the default setting. After you are in the properties view, you can modify the property values for specific tags. To edit another tag using properties view, move the cursor within the editing area of the source page or design page to the tag where you want to edit. The appropriate properties and values are displayed in the properties view. Now we are considering assigning the default JRE for the workbench in working with JREs in tasks. Here's how you can change the default JRE. The default JRE is used for compiling and launching Java programs in all projects unless you specifically override the default JRE on a project build path or on a launch configuration. Here's how you can change the default JRE. Step 1, open the Java, then install JRE preference page. Step 2, click the box on the line for the JRE you want to assign as the default JRE in the workbench. If the JRE you want to assign as the default does not appear in the list, you must edit, then click OK. Note, change in the default JRE may cause a build to occur if you have a auto build enabled project, then built automatically, or in the general then workspace preference page. Now we are considering workbench options preferences in debug preferences in PHP preferences. The workbench options preference page is accessed from the window or preferences or PHP or window preferences, PHP debug, then workbench options. The workbench options preference dialog will allows you to configure the default behavior of the workspace during the debugging process. The workbench options preference page is accessed from window, then preferences, then PHP, then debug, then workbench options. The workbench options configuration options are the workbench options configuration options here allow multiple debug sessions. Select whether to allow multiple debug sessions to run simultaneously, always, never, or prompt. Switch back to the PHP perspective when the debug is terminated. Select whether the PHP perspective will open when the debug is terminated. Always, never, prompt. And workbench options open in browser. Mark the checkbox for the debugged file to be displayed in the browser during debugging. Open PHP debug views. Mark the seven checkbox for PHP debug views to be displayed when the debug session is launched. By default, a dialog will appear when a debug session is launched asking whether you want to open the debug perspective when the debugging session is run. To change this behavior, open the perspective preference dialog box by going to window, then preference, then run or debug, then perspectives, and select always, never, or prompt. In the open the associate perspective when launching category. Now we are considering restoring a deleted workbench element in using the local history in tasks. Step 1, ensure that a Java view that show the Java elements inside files such as the outline view is visible. Step 2, open the compilation unit to which you want to add the previously removed data element from the local history. Step 3, activate the editor by clicking its tab in the editor area, and the Java view shows the content of the Java file. Step 4, in the Java view, select the element to whose container type you want to restore the deleted element. Step 5, from the type pop-ups menu in the Java view, select restore from local history. Step 6, in the upper left pane of the resulting dialog, all available editions of the selected element in the local history are displayed. Step 7, in the left pane, check all element that you want to replace. Step 8, for every checked element, select an edition in the right hand pane and view its content in the bottom pane. Step 9, when you have identified the edition you want to restore, press restore. The local history editions are added into the editor. Now we are considering creating web service using ant tasks in the workbench in creating web services and clients using Apache CXF and ant task in tasks. To begin, you need to modify the ant properties file, then was imported using the ant files wizard in the prerequest. You can use ant through the Eclipse Workspace to generate a web service using CFX runtime environment. Both top-down and bottom-up web services development is supported with ant tasks. Before creating the web service, you must complete the prerequisites in point 2. Next point, if you are creating a top-down web service, create or import a WSDL file into the web content folder of the dynamic web project. Next point, if you are creating a bottom-up web service, create or import Java Bean into the source folder of the dynamic web project. Note there are certain limitations when developing a bottom-up web service using ant task as opposed to the web services wizards. If an explicit service endpoint interface SCI is requested, one must be extracted beforehand, and both the implementation class and SEI must be annotated with at javax.jws.webservice before running the ant build file. To begin, you need to modify the ant properties file than was important using the ant files wizard in prerequests. Edit step 1, edit cxf underscore td java.properties if doing top-up top-down development, or the cxf underscore bu java.properties file for bottom-up development. Ensure scenario type parameter is set to service. Set the initial selection parameter to the local location of your WSDL file, top-down or Java Bean bottom-up. All other parameters are optional and should be deleted if not explicitly set. The default values for the remaining properties will be retrieved from the dynamic web project settings and preferences. For additional information on how to set parameters, refer to top-down CFX web service and task properties file reference in the documentation, or bottom-up CFX web service and task properties file reference in the documentation. Save the properties file. Step 2, select the CFX underscore td java xml top-down or CFX underscore bu java.xml bottom-up, and from the top level menu, and then select run, then external tools, then external tools configuration. Step 3, in the dialog that opens, select and build, and then select new launch configuration button. In the toolbar, select JRE tab, then select run in the same JRE as Workspace and click apply, and then click then run. A build successful message will be output to the console once the web service has been generated. Now we are considering creating a web service client using the ant task in the Workbench in creating web services and client using Apache CFXF and ant task in tasks. You can use ant through the Eclipse Workspace to generate the web service client using CXF runtime environment. Before creating the web service, you must complete the prerequisiting. To begin, you need to modify the ant properties file than was the imported using ant files wizard in the prerequisites. Step 1, edit the cfx underscore client.properties file that you imported in the prerequisite step. Then ensure the scenario type parameter set to client. Then set the initial selection parameter to the location of your WSDL file. All other parameters are optional and should be deleted if not explicitly set. The default values for the remaining parameters will be retrieved from the dynamic web project settings and preferences. For additional information on how to set parameters, you can refer the CFX web service client and task properties file reference in the documentation, and save the properties file. Step 2, select the cfx underscore client.xml file, and from the top level menu and select run, then external tools, then external tool configuration. In the Step 3, in the dialog that opens, select and build, and then select new launch configuration button. In the toolbar, select JRE tab, then select run in the same JRE as the workspace. Click apply and then run. Step 4, build successful message will be output to the console once the web service has been generated. Now we are considering creating web services using and task in Workbench, in creating Access Runtime environment web services, and client using web services and task in developing web services applications. In order to create the web service, you need to modify the AND file and the service and properties file. You can use AND through the Eclipse Workspace to generate a web service using Access Runtime environment. Both top-down and bottom-up web services development is supported with the AND tasks. Before creating the web service, you must complete the prerequisite listed in. And next point, if you are creating a top-down web service, create or import the WSDL file from the web content folder of the dynamic web project you created. The next point, if you are creating a bottom-up web service, create or import the Java Bean into the SRC folder of the dynamic web project. In order to create the web service, you need to modify the AND file and the service and properties file. Step 1, edit the AND file, access_tdjava.xml or access_bujava.xml that you imported in the prerequisite steps. Ensure that it points to the service and properties file. It should contain the line stating property file equal access_tdjava.properties or property file equal access_bujava.properties. Save any changes that you have made. Step 2, edit the properties file that you imported in the prerequisite steps. Ensure that the scenario type parameter is set to service. Set the workspace parameter so that it points to the location of your WSDL file or Java Bean. All other parameters are optional and should be deleted if not explicitly set. The default values for remaining parameters will be retrieved from the dynamic project settings and preferences. For additional information on how to set these parameters, refers to top-down access web service and task properties file reference, bottom-up access web service and task properties file reference in the documentation. Save the properties file. Step 3, right click access_tdjava.xml or access_bujava.xml and select run as, then run build. In the dialog that opens, select JRE tab, then select run in the same JRE as the workspace. Click apply and then click run. Once your web service has been generated, the console displays the built successful message. The WSDL file for the service will have been created and placed in the dynamic web project's web content /WSDL folder. The following files will have been created and placed in the subdirectory of the dynamic web project's web content /web-inf folder: web.xml, undeploy.wsdd, deploy.wsdd. If you are creating top-down web service files similar to the following will be created and placed under the dynamic web project's SRC folder. Depending on the WSDL file on which the web service is based, the file form for your web service may be different. Service_name_port type.java, service name service Java, service name servlet locator Java, service name SOAP impl Java, service name SOAP skeleton.java, service name SOAP stub.java. Here the top-down access web service and task properties file reference. The access_tdjava.properties file is used to pass the data to the services, data to the web services and task when creating an access web service. This file shows the available options. Bottom-up access web service and tasks properties file reference. This access the axis underscore bu java.properties file is used to pass the data to the web services and task when creating an Axis web service. This file shows the available options. We can consider this as an error example. Problems occurred when invoking code from plugin org.eclipse.ui.workbench. If you want to start your Eclipse, choose your Workbench to load and then Eclipse stops. You probably have a Workbench error. To fix this, follow the steps. Go to workspaces, then your workspace, then .metadata, then .plugins. Find the folder org.eclipse.e4.workbench, delete it, restart Eclipse. Now the problem is fixed and Eclipse will start again, but be aware that your workspace layout will be back to default. This error can be found in the file workspaces / your workspace / .metadata / .log file. Now we are focusing on JFace. JFace is a UI toolkit with classes for handling many common UI programming tasks. JFace is a Windows system independent in both its API and implementation, and is designed to work with SWT without hiding it. JFace includes the visual UI toolkit components of image and font registries, text, dialog, preference, and wizard frameworks, and progress reporting for long-running operations. Two of its more interesting features are actions and weavers. The action mechanism allows user commands to be defined independently from their exact whereabouts in the UI. Weavers are model-based adapters for certain SWT widgets, simplifying the presentation of application data structured as lists, tables, or trees. Here you can see JFace architecture. JFace establishes a layer between application's business logic and the bare bones SWT widgets. JFace uses methods like setText and setIcon to actually display data in widgets, and registers for low-level event as necessary. It also offers events to the application itself, but these are special in that they translate from the widget level to the model level. For instance, when a user selects a row in table widgets, SWT reports the index of the row. JFace translates that index into the model element, and it has previously rendered in the row, and reports that this model element has been selected. In effect, the application is shielded from the cumbersome details and can always work in terms of its own data structures. In effect, of course, it still listens to the events such as button clicks directly on the SWT widgets, and translate this into operations in the model. JFace follows model view separation in getting data to be displayed from the model and listening to the change notification of the model to keep the display up to date. Here you can see SWT interacts with JFace. Set text and set icons are passed from JFace to SWT. Events are passed from SWT to JFace. JFace interacts with model. Get data is passed from JFace to model. Change is passed from model to JFace. And SWT is connected to listeners, and events are passed from SWT to listeners. JFace is connected to listeners. Model and view events are passed from JFace to listeners, and listeners are connected to model, and invoke operations are passed from listeners to model. Here you can see a bit more detailed JFace architecture. We will now discuss the various roles and relationships. Here we focus on viewers and their collaborations. The listeners, which implement the application reactions to user input in the sense of controllers. JFace viewers target specific widget types. The core contribution of JFace layer relates to its selection of generic viewers, each of which targets a specific type of widgets. A table viewer targets tables. A combo viewer targets a combo box, and so on. Viewers use the widget specific methods for displaying data and listen for widget specific events. JFace viewers access the application data through adapters. One question not addressed is how JFace will actually access the application specific data. How is a generic viewer supposed to know the right get data method and the implementation of observer pattern of specific data structures? First, each viewer holds a reference to the model in its property input. However, that input is a generic object, so the viewer never accesses the model itself. Instead, the viewer is parameterized by two adapter objects that enable it to inspect the model just as required. The content provider is responsible for traversing the overall data structure and for splitting it up into elements for displaying purposes. For a table or list, it provides a linear sequence of elements for a tree-like display. It also accesses the child and parent-like links between the elements. Furthermore, content provider must observe the model and notify viewer about any changes that it receives. Label provider is called back for each element delivered by the content provider, usually to obtain concrete strings and icons to represent the element on the screen. A list viewer will request one text icon combination per element. A table viewer or tree viewer will request one combination of each column. The viewer will also observe the label provider to be notified about changes of the text and icons to be displayed. The text-related viewers, text viewer and source viewer, deviate from the schema in that they expect an implementation of iDocument as their model. The document itself then includes a text-specific access operation without requiring a separate adapter. The framework includes a deliberate redundancy regarding changes in the model. When values change within a data element, then those may be translated for the viewer either by the content provider by calling the viewer's update method, or by the label provider by firing change events. Each mechanism has its merits. On the one hand, the content provider observes the model anyway, so the label provider can often remain passive. On the other hand, some generic label providers, such as those used in data binding, may wish to avoid relying on a specific content provider. Here you can see widgets interacts with viewer. Set icon and set text are passed from viewer to widgets, and selection is passed from widget to viewer. Viewer interacts with content provider. Get elements are passed from viewer to content provider, and refresh is passed from content provider to viewer. Content provider interacts with model. Get data is passed from content provider to model, and change is passed from model to content provider. Viewer is connected to model, and input is passed from viewer to model. And widget is connected to listeners. Events are passed from widget to listeners. Viewer is connected to listeners. Model level events are passed from viewers to listeners. Viewer is connected to label provider. Get text, get icons are passed from viewer to label provider. Listeners are connected to model, and invoke operations are passed from listeners to model. Now we are considering here you can see wizards. A wizard is composed of several different underlying parts. Wizards are used to guide user through a sequence of tasks. Your plugin can contribute wizards at predefined extension points in the Workbench. It can also create and launch its own wizards. When you contribute to a Workbench wizard extension point, the actions that launch the wizard are already set up by the Workbench. You need only supply the wizard that will be used. If you need to launch other wizards that are not already defined in the Workbench wizard extension points, you must launch them yourself. You can launch your own wizards by adding an action to a view, editor, pop-up, or an action set. A wizard is composed of several different underlying parts. Wizard dialog. the wizard dialog. Wizard dialog is the top level dialog in the wizard. It defines the standard wizard buttons and manages a set of pages that are provided to it. When you contribute to a Workbench wizard extension, you do not have to create a wizard dialog. One is created on your behalf by the Workbench, and your wizard is set into it. The wizard dialog performs the enabling and disabling of the next, back, and finish buttons based on the information it obtained from the wizards and the current wizard page. The wizard controls the overall appearance and behavior of the wizard, such as title bar text, image, and availability of a help button. Wizards often use corresponding dialog settings to obtain and store the default values for the settings of the control on the wizard pages. Wizard class implements many of the details for standard wizard behavior. You typically extend this class to implement behavior specific to your wizard. The primary responsibilities of your wizard will include creating and adding your pages to your wizard, implementing the behavior that should occur when the user presses the finish button. Wizard page, iWizard page define the controls that are used to show the content of the wizard page. It responds to events in its content areas and determines when the page is completed. Your wizard page typically extends the wizard page class. The primary responsibilities of your wizard page will include creating the SWT controls that represent the page, determining when the user has supplied enough information to complete the page, that is, when the user can move to the next page. With regarding important classes and interfaces, here we can consider wizard dialog. The class wizard dialog in package org.eclipse.jface.wizard, a dialog to show a wizard to the end user. In the wizard we can consider iWizard, the interface iWizard in package org.eclipse.jface.wizard. Interface for a wizard. A wizard maintains a list of wizard pages stacks on top of each other in the card layout fashion. We can also consider wizard class wizard, package in the package org.eclipse.jface.wizard, an abstract based implementation of wizard. A typical client subclasses wizard to implement a particular wizard. We can consider interface iWizard page in package org.eclipse.jface.wizard. Interface for a wizard page. We can also consider class wizard page in package org.eclipse.jface.wizard, an abstract based implementation of a wizard page. Here you can see the wizard and back and next and finish and cancels are inside the wizard dialog. Wizard page, the content is inside wizard, the page set. Wizard is connected to page set. Page set consists of a number of wizard pages. Wizard page is connected to wizard page in page set is connected to wizard page here in wizard. Example, we can consider this code. Here you can see a hello world extend application window, and this class has run method and control and create contents method. As an example 2, we can consider setting up an Eclipse project to use SWT and JFace. Step 1. Identify the required external jar files for JFace. Step 2. Create an Eclipse project called org.eclipse.swt that will have all the required SWT and JFace jar files on its build path, and configure the order and export tab of the build path to export these files. This project will supply the required jar files to any other Eclipse project that needs them. Step 3. On any new Java projects that need to use SWT or JFace, simply add the org.eclipse.swt project as a required project on the projects tab of the build path. As an example 3, we are considering package org.eclipse.jface.action provides support for shared UI resources such as menus, toolbars, and status lines. Now we are considering JFace dialog wizard in SWT or JFace or RCP in wizards. The wizard generates the following code. The class dialog. A dialog is a specialized window used for narrow focus communication with the user. This is in the package org.eclipse.jface.dialogs. Subclasses of the JFace dialog class can be created using JFace dialog wizard. The wizard can be selected from the drop-down designer wizards menu, or from the Eclipse new wizard. To use the wizard, select the project's source folder and package to contain the class. Then enter the class name and hit finish button. This wizard generates the following code. When editing JFace dialogs, any widget may be added to the main content area. In the button bar area, only dialog buttons may be added on the Java viewers palette. Here the class dialog, a dialog is a specialized window used for narrow focus communication with the user. Now we are considering JFace title area dialog wizard. The wizard generates the following code. The class title area dialog, a dialog that has a title area for displaying a title and an image, as well as a common area for displaying a description, a message, and an error message. This is in the package org.eclipse.jface.dialogs. Subclass of the JFace title area dialog class can be created using the JFace title area dialog wizard. The wizard can be selected from the top-down drop-down designer wizard menu or from the Eclipse new wizard. To use the wizard, select the project source folder and package to contain the class. Then enter the class name and hit finish. The wizard generates the following code. When editing JFace title area dialogs, any widget may be added to the main content area. In the button bar area, only dialog buttons may be added on JFace viewers palette. The class title area dialog, a dialog that has a title area for displaying a title and an image, as well as a common area for displaying a description, a message or an error message. Now we are considering JFace application window wizard. The wizard generates the following code, including main method when the toolbar template is selected. The class here subclasses of the JFace here, sorry, the class application window is an high-level main window with built-in support for an optional menu bar with status menus, an optional toolbar, and optional status line. This in the package org.eclipse.jface.window. Subclass of the JFace application window class can be created using JFace application window wizard. The wizard can be selected from the drop-down designer wizard menu or from the Eclipse new wizard Eclipse new wizard. To use the wizard, select the project source folder and package to contain the class. Then enter the class name and hit the finish button. By default, wizard will generate templates using standard SWT toolbar. Under Eclipse 3.0 and higher, the wizard presents two templates using toolbar and one with cool bar. The menu the menu bar is composed of menu managers and JFace actions, and the toolbar is composed of toolbar managers and JFace actions. The special JFace actions palette is provided to manage this. Here you can see again the menu bar is composed of menu manager and JFace actions, and the toolbar is composed of toolbar managers. Sorry, this is JFace actions and toolbar managers and JFace actions. The special JFace actions palette is provided to manage this. The wizard will generate the following code, including main method when the toolbar template is selected. The class application window, and application window is a high-level main window with built-in support for an optional menu bar, an optional with menu bar with standard menus, an optional toolbar, an optional status line. Now we are considering JFace wizard. The wizard generates the following code. The class wizard, an abstract base class implementation of a wizard. Typical client subclasses wizard to implement the particular wizard. This is in the package org.eclipse.jface.wizard. Subclass of the JFace wizard class can be created using JFace wizard. The wizard can be selected from the drop down wizard menu or from the Eclipse wizard from the Eclipse new wizard. To use the wizard, select the project source folder and the package to contain the class. Then enter the class name. Use the add button to add individual wizard pages. That have already been created, and hit finish button. The wizard will generate the following code. Now we are considering JFace wizard page wizard. The wizard generates the following code. The class wizard page, an abstract base implementation of a wizard page. This is in the package org.eclipse.jface.wizard. A subclass of the JFace wizard page class can be created using the JFace wizard page wizard. The wizard can be selected from the drop down wizard menu or from the Eclipse new wizard. To use the wizard, select project source folder and package to contain the class. Then enter the class name and hit the finish button. The wizard generates the following code. When editing JFace wizard pages, widgets may only be added to the main content area. Now we are considering viewers in JFace UI framework. We first saw a viewer in README tools view contribution inside the README sections view here. The class list viewer, a concrete viewer based on an SWT list control. This is in the package org.eclipse.jface.viewers. Why would you ever want to use a viewer when we have already seen that the Workbench UI contributions like viewers, editors, wizards, and dialogues can be implemented directly with SWT widgets? Viewers allow you to create widgets while still using your model objects. If you use SWT widget directly, you have to convert your objects into the strings and images expected by SWT. Viewers act as an adapters on SWT widgets, handling the common code for handling widget events that you would otherwise have to implement yourself. First, we saw a viewer in the README tool view contribution inside the README section view here. Note, viewers can be used to provide the implementation for both Workbench views and editors. The term viewer does not imply that they are only useful for implementing views. For example, text viewer is used in the implementation in many of the Workbench and plugin editors. Now we are considering actions in actions and contributions is deprecated. The code below implements the about action. This is one of the simplest simple actions in the Workbench. The class action, the standard abstract implementation of an action. This is in the package org.eclipse.jface.action. An action, iAction, represent a command that can be triggered by the end user. Actions are typically associated with buttons, menus, menu items and items in toolbars. Although actions do not place themselves in the UI, they do not have UI oriented properties such as tooltip text, label text and an image. This allows other classes to construct widgets for the representation of the action. When the user triggers the action in the UI, the action's run method is invoked to do the actual work. A common pattern in the run method is to query the workbench selections and manipulate the objects that are selected. Another common pattern is to launch a wizard or dialog when action is chosen. You should not directly implement the iAction interface. Instead, you should subclass an action class. Browse the subclass of the class to see the menu of the common patterns for actions. Code below implements the about action. It is one of the simple actions in the Workbench. You can see the run method here. Now we are considering image descriptors and the registry. Basically, image descriptor in image descriptors and the registry in user interface resources. The following code shows an example for this. The class image descriptor. An image descriptor is an object that knows how to create an SWT image. It does not hold into images or cache them, but rather just create them on demand. An image descriptor is intended to be a lightweight representation of an image that can be manipulated even when no SWT display exists. This is in the package org.eclipse.jface.resources. The image descriptor class can be used as a lightweight description of an image. It specifies everything that is needed to create an image, such as the URL or file name where the image can be obtained. Image descriptors do not allocate an actual platform image unless specifically requested using the create image method. Image descriptors are the best strategy when your code is structured such that it defines all the icons in the place and allocate them as they are needed. Image descriptors can be created at any time without concern for OS resources, making it convenient to create them all in initialization code. When designing APIs, prefer image descriptors over images whenever possible. Clients of your API only client of your API only hand image descriptors to your API. Your implementation handles the creation and disposal of images, and clients of your API don't need to care about disposing of images. And good example for this approach is in the wizard class. The following code shows an example of this. Now we are considering model operations in long-running operations. The model context class is provided to run an operation that is modeled from the client's code's perspective. It is used inside the different implementations of iRunnable context. The class model context utility class for supporting model operations. The runnable passed to the run method is executed in a separate thread, depending on the value of the passed fork argument. If the runnable is executed in a separate thread, then the current thread either waits until the new thread ends, or if the current thread is in the UI thread, it polls the SWT event queue and dispatches each event. This is in the package eclipse.jface.operation. The model context class is provided to run an operation that is modeled from the client code's perspective. It is used inside the different implementations of iRunnable context. If your plugin needs to wait on the completion of a long-running operation before continuing the execution, model context can be used to accomplish this while still keeping the user interface responsive. When you run an operation in a model context, you can choose to fork the operation in a different thread. If the fork is false, the operation will be run in the calling thread. If the fork is true, the operation will be run in the new thread. The calling thread will be blocked, and the UI event loop will be run until the operation terminates. Now we are considering creating a control decoration in control decorations in field assist. A decoration can be created for the control. The class control decoration renders an image decoration near a control. It allows clients to specify an image and a position for the image relative to the control. A control decoration may be assigned a description text, which can optionally be shown when the user hovers over the image. Clients can decorate any kind of controls. This is in the package org.eclipse.jface.fieldassist. Creating a control decoration is straightforward. Clients simply specify the control to be decorated, and the SWT constants describing the position of the decoration relative to the control. Consider the snippet in which the application creates text control inside one of its dialogues. A decoration can then be created for the control. Once the decoration is created, its image and text can be specified. Clients can use set show only on focus method to specify whether decoration should be shown when the control has focus, or whether it should be shown at all times. To set the set show hover method allows clients to configure whether the description text is shown in a hover when the mouse hovers over the decoration. Create a text field. Specify here the create control decoration for the control. Specify the decoration image and the description. Now we are considering new JFace bindings in JFace data bindings in SWT or JFace in data binding. New bindings are created by selecting viewer and input and clicking the bind button. When creating a binding, content provider and label provider can be label provider may be specified. Now we are considering presenting Java elements in JFace viewer in JDT UI. If you understand the basic platform mechanism when then putting the Java content and label providers together is quite simple. The interface iJava model represent the root Java element corresponding to the workspace element. Correspond to the workspace. Since there is only one such root element, it's commonly refers to as the Java model element. The Java model element need to be opened before it can be navigated or manipulated. Java model element has no parent. It is the root of the Java element hierarchy. Its children are iJava projects. The JDT UI API provides classes that allows you to present the Java model or parts of it in a standard JFace viewer. This functionality is provided primarily by standard Java element content provider. Translates the Java element hierarchy into a data structure accessible by a tree, table, or a list viewer. Java element label provider provides corresponding images and labels for a standard JFace viewer. Java element labels provides corresponding text labels for Java elements. Contents and label providers for JFace viewers you can see here. If you understand the basic platform mechanism, then putting the Java content and label providers together is quite simple. The example here uses the Java model, iJava model, as the input element for the viewer. The standard Java element content provider also supports iJava project, iPackage fragment root, iPackage fragment, and iFolder as input elements. Provide members of a compilation unit or a class. There are more flags defined in the class Java element label provider. Using the Java model as the viewer's input, present Java projects on the first level. Now we are considering JFace data bindings in code generation, in preferences, in SWT, in Window Builder Pro, Window Builder. This page used to control the various JFace data bindings. Add initial data bindings invocation to GUI creation method. This preference determines whether the initial data bindings method should be generated into the GUI creation method, constructor, create contents, init GUIs method, JB init method, etc. Assign return value of init data bindings method invocation to field. This preference determines whether the data binding context returned by the init data bindings method should be assigned to a field or future access. Don't use deprecated method of beans observables. This preference determines the deprecated methods of beans observables are used. When turned on, the tool will generate Eclipse 3.5 compatible code only. When turned off, the tool will generate the code that will run earlier versions of the Eclipse using code that was deprecated in Eclipse 3.5. Enclosing data binding code in try-catch block. This preference determines whether the data binding code will be generated within a try-catch block. Generate observable code for version 1.3 over properties. This preference determines whether the data binding version 1.3 API will be used for generated observables code. Use viewer support for generating JFace viewer bindings. This preference determines whether viewer support is used for generating JFace viewer bindings. Add init bindings invocation to composite constructor. This preference determines whether the init data bindings method should be generated into the constructor for a composite. Default value for new strategy object. This preference determines the default values used for new update value strategies, update list strategies, and update set strategies. This is the default values for new strategies, and here update value strategy, update list strategy, and update set strategy. Generic init data bindings with access. This preference determines visibility of the visibility access of the init data bindings. Init data bindings method. preview. This shows the sample. This shows a sample of the generated data binding code given the preference settings. Now we are considering standard dialogues in dialogues and wizards. The message dialog. Message dialog displays a message to the user. You can set the dialog title, image, button text, and message in the constructor for this dialog. The class message dialog, a dialog for showing messages to the user. This is in the package org.eclipse.jface.dialogs. Now we are considering application dialogs. Now we are ready to look at the implementation of this action in the README tools window action delegates. The class dialog. A dialog is a specialized window used for narrow focused communication with the user. This is in the package org.eclipse.jface.dialogs. When a standard dialog is too simple for your plugin, you can build your own dialog using the dialog class. Earlier we for example, we can consider open readme browse action in an action set. This action set is shown in the Workbench toolbar and window, then readme file editor menu. Now we are ready to go look at the implementation of this action in the README tools window action delegates. The window action delegate for the action set uses the current selection in the resource navigator view, the .readme file, to get the list of sections in the readme file. In this list and the Workbench window shell are passed to the selections dialog. When the user select an action, the selection dialogs is opened. The selection dialog is implemented in the README tool plugin by subclassing the dialog class in the org.eclipse.jface.dialogs package. The dialog class provides the basic support for building a dialog shell window, creating a common dialog buttons, and launching the dialog. Subclasses are responsible for handling the content of the dialog itself. Create dialog area creates the SWT controls that represent the dialog contents. This is similar to the creating the controls for the view or editor. The selection dialog creates an SWT list to display the list of sections. It uses JFace viewer to populate the list. We note that our dialog does not have to create any of the buttons for the dialogs since it is this is done by our superclass. Configure shell is overridden to set the appropriate title for the shell window. OK button pressed is overridden to perform the whatever action is necessary when the user presses the OK button. You can also override the cancel button pressed or button pressed int depending on the design of your dialog. Selection dialog does not implement an OK button pressed method. It inherits the do nothing implementation from dialog. This is not typical. Your dialog usually performs some processing in response to one of the dialog buttons pressed. Dialogs can be simple or as complicated as necessary. When you implement a dialog, most of your dialog code is concerned with creating the SWT controls that represent its content area and handling any events necessary while the dialog is up. Once a button is pressed by the user, the dialog can query the state of the various controls or viewers make up the dialog to determine what to do. Now we are considering dialog settings. The following snippet shows how you could obtain the dialog settings for the README tool. The interface iDialog settings, an interface to use and an interface to store to a storage mechanism for making dialog settings persistent. The store manages a collection of key value pairs. The keys must be strings and the values can be either strings or array of strings. The convenience API to convert primitive types to strings is provided. This is in the package org.eclipse.jface.dialogs. The org.eclipse.jface dialogs package provide a utility class dialog settings for storing and retrieving keyed values. You can use this class to save and retrieve primitive data types and strings values that you associate with key names. The settings are loaded and saved using an XML file. The Abstract UI plugin provides a support for plugin wide dialog settings stored in an XML file in your plugins directory. If a dialog settings file is not found in your plugins directory, an empty dialog settings will be created for you. When the plugin is shut down, any strings that were added to it will be saved in an XML file and retrieved the next time the plugin is starting up. You can access your dialog settings where anywhere in your plugin's code. The following code snippet showed how you could obtain the dialog settings for README tool. Values are stored and retrieved using get and put methods. Get methods are named after the type of the primitive that is being accessed. You can store and retrieve Boolean, long, double, float, int, array, and string values. The following snippet shows how we could get dialog settings to initialize control values in a dialog. The value of the settings can be stored later when the OK button is pressed. Initialize the checkbox according to the dialog settings. Store the value of the generate sections checkbox. Now we are considering wizard dialog. in wizards. The wizard dialog is a top level dialog in a wizard. It defines the standard wizard buttons and manages a set of pages that are provided to it. The class wizard dialog, a dialog to show a wizard to the end user. This is in the package org.eclipse.jface.wizard. When you contribute to a Workbench wizard extension, you do not have to create a wizard dialog. One is created for you by one is created on your behalf by the Workbench, and your wizard is set into it. The wizard dialog performs and the enabling and disabling of the next, back and finish buttons based on information it obtains from the wizards and the current wizard page. Now we are considering wizard dialogs. The following code snippet shows how this could be done from some action delegates. This method assumes that we know the Workbench and the selection. The class wizard dialog, a dialog to show a wizard to the end user. This is in the package org.eclipse.jface.wizard. Some examples supplied the wizard for a specified extension point. Another perhaps more common case is that you want to launch your own plugins wizard from the some action that you have defined. Wizards are displayed in the UI by placing them in a containing dialog. This detail is handled for you when you contribute to a wizard extension. When you are launching your own wizard, you must display it yourself by wrapping it in a wizard dialog. For example, the README creation wizard could be launched independently by creating a wizard dialog and associating it with the README creation wizard. The following code snippet shows how this could be done from some action delegates. The method assumes that we know the Workbench and the selection. If you need to embed a wizard where you are anywhere else in your plugin's user interface, the interface iWizard container defines the necessary protocol for hosting a wizard. Create the wizard. Create the wizard dialog. Open the wizard dialog. Now we are considering validation and page control in multi-page wizards. This means the page will be validated whenever an event is received from a widget to which the page added a listener. The class wizard new file creation page, standard main page for a wizard that creates a file resource. This is in the package org.eclipse.ui.dialogs. The class wizard new file creation page and create readme one show a common pattern for implementing page validation. Wizard new file creation page define a common event handler for all SWT events, which validates the page, which means the page will be validated whenever an event is received from the widget to which the page is added to a listener. Once the readme creation page creates its own controls, it sets the state of the page using validate page. Using this pattern, a wizard page can put all of its validation code in one method, validate page. This method that determines the initial state of the page and recalculate the state anytime it received an event from the widget on its page. Since we added the listener to the checkbox, we will recompute the valid state of the page whenever the checkbox received the selection event. Note that the page's handle event method must call a super to ensure that the inherited page validation behavior occurs in addition to any specific event handling for this page. Create controls, add listeners, and lay out the page. Simple section generation checkboxes. Simple section generation checkboxes. Now we are considering creating a custom filtered items selections dialog. In this example, we will contribute the basic search dialog to illustrate the steps needed to create a custom subclass of filtered items selection dialog. Step 1, create a new plugin project using hello world template. Step 2, create a class extending org.eclipse.ui.dialogs.filtered item selection dialog. Let's name it filtered resources selection dialog example. Step 3, choose a source of the resource that will be used during filtering. In our example, we will generate our own set of random strings as strings. Step 4, now let's implement abstract method from the filtered item selection dialog class. Step 5, add the title of the dialog and set simple implementation of selection history in the dialog. Step 6, change run iAction method from the simple action to. Step 7, change tooltip of the simple action from hello Eclipse world to filtered item selection dialog example. Run Eclipse with created plugin and the resulting dialog will look as follows. Here I omit the example codes. You can see the resulting dialog looks as follows here. As an error example, we can consider this entry org.eclipse.jface 4/2/2010 0810 10:37:22.148 message. Problems occurred when invoking code from plugin org.eclipse.jface stack 0 java.lang. Illegal argument exception at org.eclipse.jdt.internal.core.util.scan type signature util.java 2710. This error occurred in Eclipse Java EE IDE for web developers, build ID 2009-09-20-1017. As an SW2 example, now we are focusing on SWT. SWT is an open source widget toolkit for Java designed to provide efficient portable access to the user interface facilities of the operating systems on which it is implemented. The standard widget toolkit provides a common OS independent API for widgets and graphics implemented in a way that allows tight integration with the underlying native Windows system. The entire Eclipse platform UI and the tools that plug into it use SWT for presenting information to the user. Here you can see a demo application on Windows 10. Here you can see communication from Java SWT layer to C native layer, native GTK layer. SWT is a layer between platform UI and the underlying JTK 3 or JTK 4 experimental of the system. It can be launched to use JTK 3 or JTK 4, but cannot use them both at the same time. Communication from Java SWT layer to C native GTK layer occurs through calls defined in os.java. The image here describe this hierarchy better. Here we are considering the Linux environment. Here platform UI is connected to SWT. SWT is connected to os.java. os.java is connected to the SWT underscore JTK3 selection via static calls, and os.java is connected to os.h, and then dynamic calls via flag equal dynamic, and os.h is connected to SWT underscore GTK3 selections. If the SWT underscore GTK3 equals 0, then it's connected to GTK2. If the SWT underscore GTK3 equal 1, it's connected to GTK3. GTK2 and GTK3 are connected to GDK. Now we are considering the widget hierarchy. Widget is the widget is the main widget. Everything else extends widget. The most interesting classes are widget, control and composite. Most widgets fork off this. As such, it is useful to be aware of fields, methods in parent classes in which methods get overridden by children. In Eclipse, you can control plus click on a method to see its super implementation or derived implementation. This is very useful. The illustration here shows the widget hierarchy. Here widgets interacts with menu, control, scroll bar, item and tracker. Control interacts with button, label, progress bar, sash, scale, slider and scrollable. Scrollable interacts with list, composite and text. Composite interacts with canvas, C combo, toolbar, C tab folder, drill down composite, group, SAS form, scroll composite, tab folder, table, table tree, toolbar, tree, view form. Here item interacts with cool item, C tab item, menu item, tab item, table column, table item, table tree item, tool item and tree item. Here we are considering an incomplete diagram of some widgets and their handles in GTK handles. GTK handles are basically GTK pointers to the widgets. When you first look at a widget, you generally first look at the handles that are defined in the widget. For example, each SWT widget is often made up of several GTK widgets or has pointers to GTK widgets. In general, create handle is good place to start when you first look at a widget. Also inspect asterisk handle asterisk methods of the current widget and the widgets above the hierarchy. Parent handle, font handle, child handle, etc. They all contain subutilities which are useful. Handle decorations are inherited, but they are allocated and assigned at a specific widget level. For example, a widget declares handle. Control declares fix handle, but they never allocate them. This will be allocated further down the widget tree. In individual widgets themselves. For example, here is an incomplete diagram of some widgets and their handles. You may observe that the widget has widgets has handle defined. The combo has button handle. Combo has the button handle defined. Here you can see widget and you can see handle here. Control is control inherits widget. You can see fix handle here. Button inherits button and scrollable inherits control. In button you can see box handle, label handle, image handle, arrow handle and group handle. Text and composite inherits scrollable. In text you can see buffer handle. Combo inherits composite. In combo you can see a button handle, entry handle, text renderer, cell handle, pop-up handle, and menu handle. Here you can see a flowchart describe the process of adding a new function to os.java very well. Here does the function exist in the in os.java already? If it doesn't exist, or no, then it is connected to add method signature to os.java. It is connected to selection do I need to make it dynamic? If it is yes, it's connected to add dynamic flag to method in the os.java, and it is connected to add function signature to os.h, and it is connected to rebuild GTK tools SO file. Do I need to make it dynamic? If it is no, then it's connected to rebuild GTK2 OS GTK2 SO file. It is connected to rebuild GTK3 SO file, and it is connected to life is good here, the function. Does the function exist in os.java already? If it is yes, then it's connected to the function. Here life is good. In adding new functions are introduced in JTK3, and old functions are deprecated. In these situations, we need to manually add these method signatures to os.java and os_custom file. Dynamic versus static function. Dynamic functions are not built during compile time. They are only called at runtime. This allows us to have GTK3 functions in GTK4 in a GTK4 build, or run deprecated functions only in GTK3 or some specific GTK strict version range. Dynamic functions have an annotation at method flag equal dynamic. Rebuilding SO files. After you add a new function to os.java and os.h, you need to rebuild the SO file for GTK 3 and GTK4. Dynamics methods and os_custom.h. Before adding a new function to os.java, you should understand dynamic functions. If you inspect os.java and look at the Java doc of some of the functions, you will notice the flag like this at method flags equal dynamic. This means the command is not compiled but called dynamically on the fly runtime. This is useful for functions that are specific for certain versions of GTK. For example, some functions were only introduced in GTK4. As such, these won't compile on the GTK3 build. Such, you made those dynamic. Similarly, some GTK3 functions are deprecated in GTK4, and so that we only use them in GTK3. Thus, we make them dynamic. Not all functions have to be dynamic. You should only make them dynamic if there is a need for it. That is, in general, you should only make functions dynamic if they have to be dynamic. This is because if error does exist, this postpones them from compile time to runtime. Now we are considering debugging SWT, fixed container, and GTK. To debug the C part of a running Java application, you need to attach yourself to the Java virtual machine JVM inside Eclipse. But before doing so, you need to compile GTK and SWT binding with debug flags and optimizations turn off. Here's a diagram to illustrate. Further, since eclipse.platform.swt is a Java project that contains C code, you will have to create a C project that link to that folder to debug the C code. As a note, the source and binaries will be in a different folders, so you will need to create a source and a debug C project. Here you can see Java SWT, and here SWT fix container and GTK needs to be compiled with debug support and optimized stations turn off. SWT fix container is connected to GTK here. SWT is connected to GTK here. Here JVM C code we attach to a JVM to debug this part. Here you can see SWT widgets. This is screenshots for many of the widgets included in SWT. SWT widgets are located in packages org.eclipse.swt.widgets and org.eclipse.swt.custom. Widgets extend either the widgets or the control class. Several of these widgets are depicted in this here. The composite class. Composite class is a container which is capable of containing other widgets. The group class is another container which is able to contain other widgets. Additionally, draws a border around itself and allows you to set a header for the grouped widgets. Here, browser instance of this class implement the browser user interface metaphor. It allows the user to visualize and navigate through HTML documents. Button class button instance of this class represent a selectable user interface object that issues a notification when pressed and released. Here you can see a button with SWT.arrow, and here SWT.push. Here SWT push here, and here SWT.check, and here button with SWT.radio. Here button SWT.toggle. Here you can see canvas class canvas. Instance of this class provide a surface for drawing arbitrary graphics. Combo, the class combo. Instance of this class is control. Instance of this class controls that allow user to choose an item from a list of items, or optionally enter a new value by typing it into an editable text field. Often combos are used in the same place where the single selection list widget could be used, but space is limited. A combo takes less space than a list widget and shows similar information. Composite, the class composite. Instance of this class are controls which are capable of containing other controls. coolbar. Class coolbar. Instance of this class provide an area for dynamically positioning the items they contain. Class ctab folder. Instance of this class implement the notebook user interface metaphor. It allows the user to select a notebook page from the set of pages. Class here date time. Instance of this class are selectable user interface objects that allows the user to enter and modify the date or time values. Expand bar. Class expand bar. Instance of this class support the layout of selectable expand bar items. Group. Class group. Instance of this class provide an H border with an optional title. Label. Class label. Instance of this class represent a non-selectable user interface object that displays a string or image. When separator is specified, displays a single vertical line or horizontal line. Link. Class link. Instance of this class represent a selectable user interface object that displays text with links. List. Class list. Instance of this class represent a selectable user interface object that displays the list of strings and issues notification when a string is selected. A list may be single or multi-select. Menu. Class menu. Instance of this class are user interface object that contain menu items. Progress bar. Class progress bar. Instance of this receiver represent represent an unselectable user interface object that is used to display progress, typically in the form of a bar. Shash. Class shash. Instance of this receiver represent a selectable user interface object that allows the user to drag a rubber band outline of shash within the parent control. Scrolled composite. Class scrolled composite. A scrolled composite provide the scroll bars and will scroll its content when the user uses the scroll bars. Shell. Class shell. Instance of this class represent the windows which the desktop or window manager is managing. instances of that do not have a parent, that is, they are built using the constructor which takes a display as the argument, are described as top level shells. Instances that do not have the parent are described as instances that do have a parent are described as secondary or dialog shells. Slider. Class slider. Instances of this class are selectable user interface objects that represent a range of positive numeric values. Scale. Class scale. Instance of this receiver represent a selectable user interface object that represent a range of continuous numeric values. Spinner. The class spinner. Instance of this class are selectable user interface objects that allow the user to enter and modify the numeric values. Styled text. The class styled text. A style text is an editable user interface object that displays lines of text. The following style attributes can be defined for the text: foreground color, background color, font style, bold italic, regular, underline, strikeout. In addition to the text style attributes, background color of the line may be specified. Tab folder. Class tab folder. Instances of this class implement the notebook user interface metaphor that allows the user to select a notebook page from a set of pages. Table. Class table. Instance of this class implement a selectable user interface object that displays a list of images and strings and issues notification when selected. Text. Instances of this class are selectable user interface objects that allow the user to enter and modify text. Text controls can be either single or multi-line. When a text control is created with a border, the operating system includes a platform-specific inset around the content of the control. When created without a border, an effect is made to remove the inset that such that the preferred size of the control is the same size as the contents. Here you can see text with the SWT.single. Here text with the SWT.multi. Toolbar. The class toolbar. Instance of this class support the layout of selectable toolbar items. Tray. Class tray. Of instance of this class represent the system tray that is a part of a taskbar status area on some operating systems. The instance of this class represent the system tray. class tree, the instance of this class provide a selectable user interface object that displays a hierarchy of items and issues notifications when an item in the hierarchy is selected. Here you can see a few general terms that are used when discussing layout. When writing applications in SWT, you may need to use layouts to give your window specific look. A layout controls the position and size of children in a composite. Layout classes are subclasses of abstract class layout. SWT provides several standard layout classes. You can write custom layout classes. In SWT, positioning and sizing does not happen automatically. Applications can decide to size and place composites children initially or resize or in a resize listener, or they can specify a layout class to position and size the children. If children are not given a size, they will have zero size and they will have cannot be seen. The diagram here illustrates a few general terms that are used when discussing layout. The composite, in this case tab folder, has location, client area, and trim. The size of the composite is the size of the client area plus the size of the trim. The composite has two children that are laid outside by the side. Layout is managing the size and position of the children. The layout is managing the size and position of the children. This layout allows spacing between children and margin between children and the edges of the layout. The size of the layout is the same as the size of the composite's client area. The preferred size of the widget is the minimum size needed to show its contents. In the case of composite, the preferred size is the smallest rectangle that contains all of its children. If children have been positioned by the application, the composite computes its own preferred size based on the size and position of the children. If a composite using a layout class to position its children, it asks the layout to compute the size of its client area and then adds the trim to determine its preferred size. Here you can see composite location here XY and composite client area here XY. Here you can see the composite client area with layout width. Here you can see the composite width. Here you can see the trim, and here you can see the trim. Here you can see the height Here you can see the composite client area height or layout height, and here you can see composite height. As an example, we can consider this code segment. The following is the basic hello world program using SWT. It shows a window shell and a label. Contrary to swing, display class is necessary to access underlying operating system, and its resources must be explicitly disposed of when they are no longer used. As an example too, we can consider steps to import SWT library. Right click on Java project, click properties. Step 2, click Java build path, then libraries, then add variable, then configure variable. Step 3, click new, then type a new variable name SWT_lib in names field. Step 4, click file and browse to SWT library file. PS SWT library is located at Eclipse plugin folder. Its name usually formatted as org.eclipse.swin32.win32.x86 _version number.jar. Here you can see the step 2. Click Java build path, then libraries, then add variable, then configure variables. Now we are considering package org.eclipse.swt, SWT constant and error handling support. Now we are considering package org.eclipse.ui.swt, application programming interfaces for interaction with an extension of the Eclipse platform user interface. Now we are considering widgets application structure in widgets. Since the application only displays string hello world, it does not need to register for any widget events. The class label. Instances of this class represent a non-selectable user interface object that displays a string or image. When a separator is specified, displays a single vertical or horizontal line. This is in the package org.eclipse.ui.widgets. When you are contributing UI elements using platform Workbench extensions, the mechanics of starting up SWT are handled for you by the Workbench. If you are writing an SWT application from scratch outside the Workbench, you must understand more about SWT's application structure. A typical standalone SWT application has the following structure. Create display which represent SWT session. Create one or more shells which serve as main windows for the application. Create any other widgets that are needed inside the shell. Initialize the sizes and other necessary states for the widgets. Register listeners for widgets events that needed to be handled. Open the shell window. Run the event dispatching loop until exit conditions occurs, which is typically when the main shell window is closed by the user. Dispose the display. The following code snippet is adapted from the org.eclipse.sw.examples.helloworld.helloworld2 application. Since application only displays the string hello world, it does not need to register for any widgets events. The display represents the connection between SWT and the underlying platform's GUI system. Displays are primarily used to manage platform event loop and control communication between the UI thread and other threads. For most applications, you can follow the pattern that is used here. You must create a display before creating any windows, and you must dispose of the display when your shell is closed. You don't need to think about the display much more unless you are designing a multi-threaded application. Shell. A shell is a window managed by OS Platform Window Manager. Top-level shells are those that are created as child of the display. These windows are the windows that users move, resize, minimize, and maximize while using application. Secondary shells are those that are created as a child of another shell. These windows are typically used as dialog windows and other transient windows that only exist in the context of another window. Parents and children. All widgets that are not top-level shells must have a parent. Top-level shells do not have a parent, but they created associated with a particular display. You can access the display using getDisplay. All other widgets are created as descendants, direct or indirect, of top-level shells. Composite widgets are widgets that can have children. When you see application window, you can think of as a widget tree and hierarchy that roots is the shell. Depending on the complexity of the application, there may be a single child of shell or several children or nested layers of composite with children. Style bits. Some widgets properties must be set at the time a widget is created and cannot be subsequently changed. For example, a list may be a single or multi-selection and may or may not have scroll bars. These properties called styles and are set of the constructor. All widgets constructors take an int argument that is specified bitwise or of all desired styles. In some cases, a particular style is considered a hint, which means that it may not be available on all platforms, but will be gracefully ignored on platforms that do not support it. The style constants are located in the SWT class as public static fields. A list of applicable constants for each widget class is contained in the API reference for SWT. Resource disposal. Platform underneath SWT require explicit allocation of freeing of OS resources. In keeping with SWT design philosophy of reflecting the platform application structure in widget toolkit, SWT requires that you explicitly free any OS resources that you have allocated. In SWT, the widget dispose method is used to free resources allocated with the particular toolkit object. The rule of thumb is that if you create the object, you must dispose it. Here are some specific ground rules for further explain the philosophy. If you create a graphic object or widget using a constructor, you must explicitly dispose of it when you are finishing and using it. When a composite is disposed, the composite and all of its child widgets are recursively disposed. In this case, you don't need the disposed of widgets themselves. However, you must free any graphic resource allocated in conjunction with the widgets. If you get any graphic object or widget without using a constructor, for example, control.getBackground, do not need do not dispose of it since you did not allocate it. If you pass a reference to your widget or graphics object to another object, you must take care not to dispose all of it while it is still being used. If you create a graphic object for use during the lifetime of one of your widgets, you must dispose of the graphics object when the widget is disposed. This can be done by registering a dispose listener for your widget and freeing the graphics object when the dispose event is received. There's one exception to these rules. Simple data objects such as rectangle and point do not use operating system's resources. They do not have dispose method, then you do not need to have to free them. If in doubt, check the Java doc for the particular class. Now we are considering events. This simple example is adapted from the org.eclipse.swt.example.helloworld.helloworld3. The class control adapter. This adapter class provides the default implementation for the methods described by the control listener interface. This is in the package org.eclipse.swt.events. Once we create a display and some widgets and start up the application's message loop, where does the real work happens? It happens every time an event is read from the queue and dispatched to the widget. Most of the application logic is implemented as a response to the user event. Basic pattern is that you add the listener to some widget that you have created, and when the appropriate event occurs, the listener will be executed. This simple example is adapted from org.eclipse.swt.examples.helloworld.helloworld3. For each type of listener, there is an interface that defines the listener XYS listener, a class that provides the event information XYZ event, and an API method to add the listener, add XYZ listener. If there is more than one method defined in the listener interface, then there is an adapter, XYZ adapter, that implements the listener interface and provides the empty methods. All of the events listeners and adapters are defined in the package org.eclipse.swt.events. Now we are considering layouts. The next snippet uses a layout to achieve the same effect. Class fill layout. Fill layout is the simplest layout class. It lays out controls in a single row or column, forcing them to be the same size. This is in the package org.eclipse.swt.layout. Often the best way to handle simple widget positioning is in the resize event listener. However, there are common patterns used by applications when placing widgets. These patterns can be structured as configurable layout algorithms that can be reused by many different applications. SWT defines layouts that provide general purpose positioning and sizing of a child widgets in composite. Layouts are subclasses of the abstract class layout, the SWT standard widgets can be found in the org.eclipse layout. There are some general definitions used when resizing and positioning widgets. The location of a widget is its XY coordinates location within its parent widgets. Preferred size of a widget is the minimum size that needed to show its contents. This is computed differently for each kind of widgets. The client area is the area which the child can be placed without being clipped. Trim is the distance between the widget's client area and its actual border. Trim is occupied by the widget's borders or extra space at its edge. The size of appearance of a trim is widget and platform dependent. These concepts are relevant for application regardless of whether a layout is used. You can think of a layout as a convenient way to package resize functionality for reuse. Some additional concepts are introduced by layouts. Some layouts support spacing between widgets in the layout. Some layout supports margin between edge of the layout and widget displacement widget adjacent to the edge. The following code snippet shows the simple case of an application using resize callback to the size of a label to size of its parent shell. Next snippet here uses the layout to achieve the same effect. Even for this simple example, using a layout reduces the application code. For more complex layout, the simplification is much greater. Here, the fill class fill layout. Fill layout is simplest layout class. It lays out control in a single row or column, forcing them to be the same size. This is in the package org.eclipse.swt.layout. Now we are considering SWT UI thread in threading issues. The main thread, including the event loop for an SWT application, has the following structure. The class display, the instances of this class are responsible for managing the connection between SWT and the underlying operating system. Their most important function is to implement the SWT event loop terms of the platform event model. They also provide various methods to accessing information about the operating system and have overall control over the operating system resources which SWT allocates. This is in the package org.eclipse.swt.widgets. The SWT follows the threading model supported directly by the platform. The application program runs the event loop in its main thread and dispatches the event directly to this thread. UI thread is the thread in which the display was created. All other widgets must be created in the UI thread. Since all event code is triggered from the application's UI thread, application code that handles events can freely access the widgets that and make the graphics calls without any special techniques. However, the application is responsible for forking the computational threads when performing long operations in response to an event. Note, the SWT will trigger SWT exception for any calls made from non-UI thread that must be made from the UI thread. The main thread included in the event loop for SWT application has the following structure. Once the widgets are created, the shell is opened, and the application reads and dispatches the event from the OS queue. Until shell window is disposed. If there are no events available for us in the queue, we tell the display to sleep to give other application a chance to run. SWT provides special access method for calling widgets and graphics code from the background thread. Start the event loop. We stop when the user has done something to dispose our window. Now we are considering SWT exception in error handling. SWT exception is thrown when a recoverable error occurs internally in SWT. The error code and the message text provide the further description of the problem. The class SWT exception. This runtime exception is thrown whenever a recoverable error occurs internally in SWT. The message text and error code provide the further description of the problem. The exception has a throwable field which holds the underlying exception that caused the problem. If this information is available, that is, it may be null. This is in the package org.eclipse.swt. SWT exception is thrown when a recoverable error occurs internally in SWT. The error code and message text provide the further description of the problem. SWT remains a stable state after throwing the exception. For example, this exception is thrown when the SWT call is made from a non-UI thread. Now we are considering painting in graphics object life cycle. In graphics, the color red was previously allocated when creating the widget, so it can be used here. The class GC. The class GC is where all drawing capabilities that are supported by the SWT are located. Instances are used to draw on either an image, a control, or directly on a display. This is in the package org.eclipse.swt.graphics. Once you have allocated your graphics object, you are ready to paint. You should always do your painting inside the paint listener. There are rare cases, particularly when implementing custom widgets, when you paint while responding to some other events. However, this is generally discouraged. If you think you need to paint while handling some other event, you should first try to use redraw method, which will generate another paint event in the OS. Drawing outside of the paint method defeats the platform optimizations and cause bugs depending upon the number of pending paints in the event queue. When you receive a paint event, you will be supplied with GC pre-configured for drawing the widgets. do not free this GC. You did not create it. Any other graphics object must be allocated while handling the event or beforehand. Below is a snippet on the org.eclipse. swt.examples.helloworld5 example. The color red was previously allocated when creating the widget, so it can be used here. Here you can see hello world in SWT examples. Now we are considering SWT application wizard. This wizard generates the following code, including main. SWT application window SWT application window wizard creates a main class that instantiates and shows the top level shell. The wizard can be selected from the drop down menu or from the Eclipse new wizard. To use the wizard, select the project source folder and the package that contain the class, and enter the class name to and hit the finish button. The wizard generates the following code, including main method. When editing SWT applications in Windows, all of the SWT layouts, all of the standard SWT layouts containers and widgets and menus are available. Custom or third-party control may be added via the choose component command. Now we are considering SWT composite wizard. The wizard generates the following code. Subclass of the SWT composite class can be created using SWT composite wizard. The wizard can be selected from the drop down wizard menu or from the Eclipse new wizard. To use the wizard, select the project source folder and package that contain the class, and enter the class name, then hit the finish button. The org.eclipse.swt.widgets.composite class is the default superclass. You can select org.eclipse.swt.widgets.group as the superclass if you prefer. The wizard generates the following code. When editing SWT composites, all the standard SWT layouts, containers, widgets, and menus are available. Custom or third-party controls may be added via the choose component command. Disable the check that prevents subclassing of SWT components. Now we are considering SWT dialog wizard. The wizard generates the following code, including open method. Subclass of the SWT dialog class can be created using SWT dialog wizard. The wizard can be selected from the drop-down wizard menu or from the Eclipse new wizard. To use the wizard, select the project source folder and the package that contain the class. Enter the class name and hit the finish button. The org.eclipse.swt.widgets.dialog class is the default superclass. The wizard generates the following code, including the open method. When editing dialogues, all the standard SWT layouts, containers and widgets and menus are available. Custom or third-party controls may be added via the choose component command. SWT shell wizard. The wizard generates the following code, including the main method. Subclass of the SWT shell class can be created using the SWT shell wizard. The wizard can be selected from the drop-down wizard menu or from the Eclipse new wizard. To use the wizard, select the project source folder and the package containing the class. Enter the class name and hit the finish button. swt.widgets.shell class is the default superclass. The wizard generates the following code including the main method. When editing SWT shells, all of the standard SWT layouts, containers, widgets, and menus are available. Custom or third-party controls may be added via the choose component command. Disable the check that prevents subclassing of SWT components. Now we are considering object SWT fields in RAP Web Client API reference. Here is static SWT.alt, keyboard or mouse event mask indicating that the alt keys was pushed on the keyboard when the event is generated. This is in the object SWT. This object defines the public constants used by RWT scripting, specifically event types and key codes. Now we are considering event code generation in event handlers. In code generation in preferences in SWT, this preference determines how event handlers are generated. First option, create anonymous class, generates anonymous adapter class located in line with the widget definition. Second option is create inner class, generates an adapter class as an inner class. Options are provided to add inner class at the beginning or end of the class, as well as specify the pattern used to name the inner class. The pattern can include the template variables names enclosed between $ open curly brace and close curly brace shown here. Capitalizing the name of any variable will cause the value of the variable to be capitalized before it is inserted into the resulting text. The pattern can include component name, the name of the component to which the handler is being attached, component class name, the name of the class of the component to which handler is been attached, listener name, it's not there, the name of the event being handled, listener class name, name of the event listener, third option is implement the listener interface in parent class, adds the listener interface to the parent class and adds the appropriate method to the class definition. Here you can see the example. Here you can see Forms API. This page is used to control SWT Forms API options. Generate paint border for method for new composites. This preference control whether a call to paint border for method is generated for each added composite. When borders are turned on for a composite, various widgets are automatically drawn with the flat border. When borders are turned off, widgets are drawn without borders. Automatically adapt method new non-form controls. This preference whether new form controls are automatically adapted using the form toolkit. Now we are considering absolute in layouts in SWT in preferences. This page is used to control the various SWT, then layouts, then absolute options. Use free component placement style. This preference determines whether free mode is used for aligning widgets. Free modes uses widget snapping similar to that used for group layouts. Component gaps. This preference determines the default gaps are used between components and their containers in free mode. Container gaps. This preference determines what default gaps are used between components and their containers in free mode. Apply grid creation flow. This preference determines whether the creation order of the widgets will be adjusted to reflect their position in the left to right or top to bottom grid flow. This will affect the default tab border. Use grid snapping. This preference determines whether grid mode is used for aligning widgets. Grid mode uses use a customized snapping grid. Grid step. This preference determines the grid step used in the grid mode. Display grid. This preference determines whether the grid is displayed in grid mode. Display locations and size hints. This preference determines whether location and size hints are shown when moving or sizing widgets. Automatically resize component on text or image property change. This preference determines whether a widget is automatically auto-sized anytime its text or image property is changed. Now we are considering preference page. This page is used to control various SWT preference page options. Editor use same code generation settings as control. This preference determines whether new field editors use the same code generation settings as new controls. Now we are considering new SWT bindings in SWT data bindings. When creating a binding, the update strategy from target to model and model to target may be specified. As well as any strategy specific properties validators and converters. New bindings are created by selecting target, a target property, a source or source property, and clicking the bind button. When creating binding, the update strategy from target to model and model to target may be specified, as well as any strategy specific properties, validators and converters. When the target or model is a text widget and text property is selected, the triggering event may be specified as SWT dot modify, SWT dot focus out, or SWT dot none. Predefined update strategies predefined update value strategies, policy underscore update, policy underscore never, policy on request, and policy convert may be selected, or custom or a custom strategy class may be chosen. Now we are considering main features of absolute layout. Selects absolute layout from the layout panel. Layout palette, and drop it on the window or composite. Absolute layout or null layout is a simple XY oriented layout. During layout, the live component is shown moving with the tooltip showing its current location or size. Dynamic snap alignment points are provided to make the convenient to align the composite with other component or the window margin. Resizing a component also snaps to the preferred size of the resized component, or to the size vertical or horizontal of any other component on the same parent. Graphical feedback is provided for all widgets size and position operations. Now we are considering main features in SWT fill layouts. Select fill layout from the layouts palette and drop it on the window or composite. Fill layout is the simplest layout class. It lays out controls in a single row or column, forcing them to be the same size. Initially, the controls will be as tall as the tallest control and as wide as the widest. Fill layout does not wrap, but you can specify margins and spacing You might use the two layout buttons in this taskbar or in a taskbar or toolbar, or to stack checkboxes in a group. Fill layout can also be used when a composite only has one child. For example, if a shell has a group child, fill layout will cause the group to completely fill the shell if margins are 0. Graphical feedback is provided for all drops and move interactions. The spacing can be specified using property pane. Now we are considering main features in form layout. Select form layout from the layouts palette and drop it on window or composite. A form layout class that implements an constraint-based layout manager. With constraint-based layout, you have independent control over sizing and over the sizing behavior of each of the 4 sides of the widget. The top, bottom, left and right sides can be independently attached to the sides of the parent container or sides of any sibling widget within the same container using either fixed or relative offsets. This proves to be surprisingly powerful and can be used to emulate almost any of the other layout managers. The form layout class is very simple and only specifies the margins of the container. The real power is in the form data object, which holds up our 4 element form constraint objects. The graphical feedback is provided for all widget size and position operations. Support for automatic placement mode and classic mode. Now we are considering main features in grid layout. Select grid layout from the layout palette and drop it into a window or composite. Grid layout lays out the control children of a composite in a grid. The grid layout has a number of configuration fields. And the controls it lays out can have the associated layout data object called grid data. The power of grid layout lies in ability to configure grid data for each control in the layout. Num columns field is the most important field in the grid layout. Widgets are laid out in columns from left to right, and a new row is created when the number of columns num columns plus 1 controls added to the composite. Graphical feedback is provided for all column, row, and cell interactions. Column and row properties may be changed via a pop-up menu, and convert existing layout from layouts null from form layout etc. to grid layout with intelligent column and row creation. Now we are considering main features in SWT group layout. Select group layout from the layouts palette and drop it on a shell or composite. Group layout is a layout manager hierarchically groups components in order to the position them in a container. Group layout is intended to use by builders but may be hand-coded as well. Grouping is done by instances of the group class. Group layout is intended for use by builders but may be hand-coded as well. Grouping is done by the instances of the group class. Group layout supports two types of groups. Sequential groups and sequential group positions its child elements sequentially and one after another. The parallel groups aligns its child element in one of four ways. Each group may contains a number of elements where an element is a group component or gap. A gap can be thought of as an invisible component with a minimum minimum and preferred and maximum size. In addition to group layout supports the preferred gap whose values come from layout style. Elements are similar to a spring. Each element has a range and as specified by the minimum, maximum and preferred size. Gaps have either developer specific range or a range determined by layout style. The range for components is determined from the components get minimize size, get preferred size and get maximum size methods. In addition, when adding components you may specify a particular range to use instead of that from the component. The range for a group is determined by the type of group. The parallel group's range is maximum of the ranges of its element. The sequential group's range is sum of the ranges from its elements. Group layout treats text each axis independently. That is there is a group representing a horizontal axis and the group representing vertical axis. The horizontal group is responsible for determining the minimum preferred and maximum size along the horizontal axis as well as the setting the x and width of the component contained in it. Vertical group is responsible for determining the minimum preferred and components contained in it. Each component must exist in both a horizontal and vertical group, otherwise an illegal state exception is thrown during layout or when the minimum preferred or maximum size is requested. Graphical feedbacks is provided for all widget size and position operations. Now we are considering main features in SWT row layout. Select row layout from the layout palette and drop it on a window or composite. Row layout determines the size and position of children of a composite by placing them either horizontal rows or vertical columns with the parent's composite. Row layout aligns its control in one row if the type is set to horizontal, and one column if the type is set to vertical. It has the ability to wrap and provide configurable margins and spacings. Row layout has a number of configurable fields. In addition, height and width of each control the row layout can be specified by setting the row data object into the control using set layout data. The graphical feedback is provided for all drop and move interactions. Spacing can be specified by property pane. Now we are considering main features in stack row layout. The select row layout now we are considering main features in SWT stack layout. Select stack layout from the layouts palette and drop it on the window or composites. Stack layout object is a layout manager for container. It treats each component in the container as a card. Only one card is visible at a time, and the container acts as a stack of cards. First component is added to the stack layout object is the visible component when the container is first displayed. The ordering of card is determined by the container's own internal ordering of its components objects. Stack layout defines a set of methods that allow an application to flip through these cards sequentially or to show the specific card. When adding a new widget, the current drop point is highlighted in green. Switch between cards use the using the up down arrows in the upper right corner. Now we are considering main features in swing border layout. Select border layout from the layout palettes and drop it on a window or composite. Border layout lays out the container, arranging and resizing its component to fit 5 regions: north, south, east, west, and center. Each region may contain no more than one component and is defined by the corresponding constant north, south, east, west, and center. When adding component to the container with the border layout, use one of these 5 constants as convenient. And as convenient, border layout interprets the absence of a string specification, same as the constant center. Graphical feedback is provided for all drop and move interactions. Horizontal and vertical gaps can be specified by using the property pane. Now we are considering main features in swing box layout. Select box layout from the layouts palette and drop it to on the window composite. Box layout box allows multiple components to be laid out either vertically or horizontally. Components will not wrap so. For example, vertical alignment of component will stay vertically arranged when the frame is resized. Nesting multiple panels with different combinations of horizontal and vertical gives an effect similar to grid back layout without complexity. Box layout manage is constructed with an access parameter that specifies the type of the layout that will be done. For all directions, components are arranged in the same order as they were added to the container. Box layouts attempts to arrange the components at their preference widths for horizontal layout or heights for vertical layout. For horizontal layout, if not all the components are in the same height, box layout attempt to make the components as height as the highest component. If that's not possible, for a particular component, the box layout aligns the component vertically according to the component's Y alignment. Of 0.5, which means that the vertical center of the component should have the same Y coordinate as the vertical centers of the other component with 0.5 alignment. Similar for a vertical layout. Box layout attempts to make all components in the column as wide as the widest component. If that fails, aligns them horizontally according to their X alignments. Graphical feedbacks is provided for all drop and move interactions. Graphically show area occupied by struts and springs. Now we are considering compatibility to SWT in differences between RWT and SWT in RAP widgets toolkit. Here you can see the example. RAP generally follows the rule if it compiles, it works. That means that all SWT API implemented in RWT is working within the requirements set by SWT. If an SWT feature is not implemented, the corresponding API is also missing. If this is the case, it is likely because it's hard or impossible to implement in RWT. In some cases, SWT classes and methods are implemented as empty stubs to enable single single sourcing, but only where this is valid according to SWT documentation of AP. Examples are accessing API and some SWT constants that are marked as hint. SWT has developed for desktop application, but RWT is used to build a web application. For this reason, there are some features that SWT supports that RWT does not, while RWT adds some features that are tailored to the specific requirement of web application development. However, RWT does not add any new API to the classes adapted from SWT. All RWT specific features are accessible by API in the namespace org.eclipse.rap.rwt. Many are activated using widgets setData method with the constant from RWT class as the key example here. Other additional features may be accessed via client services. Now we are considering local variable mod in variable generation in SWT, code generation in bidirectional code generation in features in window builder. In local variable generation style, each component is assigned to the unique local variable and initialized at the point of declaration. An option is provided to declare each variable as final. Note that component types marked as final on the variable, then type specific reference page will always be assigned to fields. As an error example, we can consider this. An SWT error has occurred. You are recommended to exit the workbench. Subsequent error may happen and may terminate the workbench without warning. See the .log file for more details. Exception struct trace org.eclipse.swt.swt error. No more handles at org.eclipse.swt.swt.error. swt.java 4517 etc. Now we are focusing on help. The Eclipse platform help mechanism allows tools to define and contribute documentation to one or more online books. For example, a tool usually contributes help style documentation to a user guide and API documentation if it has any to separate programmer guide. Here you can see creating a book. Eclipse platform can display any number of books, tables of contents. Each table of contents contains a collection of topics. These are books, and sometimes a higher level component or product team is responsible for weaving together the documentation and topics supplied by any number of component teams. Here you can see help context abstraction in data tools platform. Help context abstraction is a technique to simplify the handling of help context IDs and help search expression in the UI code by abstracting them to help keys. Help context abstraction provide the following benefits. Development teams are free to associate new help contexts with UI controls without necessitating that corresponding help context IDs so help search expressions exist. Documentation teams are free to define UI help context, modify help context IDs, and control the mapping from abstract help context to concrete help context IDs without necessitating any change in the UI code. Documentation teams are free to define and modify the context specific help search expressions and mapping from abstract help context to the help search expressions without necessitating any change in the UI code. Tip help search expressions include human readable text, so they must be externalized for localization. This separation of responsibilities enable the project team to provide higher quality and project precisely targeted, more precisely targeted dynamic context sensitive help. Together, the DTP helper and the context sensitive help UA plugin provide an abstraction layer which enables dynamic context sensitive help with practical and easy maintained implementation in the UI code. Here you can see a UI plugin implements iContext provider methods and help key interface class. Help key interface class is inside UI plugin here, declares help key constant. Help key interface class is connected to help key property file. Help key property file and context XML files are inside the abstraction layer. Help key property file defines mapping of help key constants and the help context IDs. Help key property file is connected to context XML file, defines mapping of help context IDs to context specific help context content. Context XML file is connected to dynamic help view, presents context sensitive help content. Dynamic help view is inside Eclipse help system, looks up iContext objects and displays context sensitive help. Here you can see some context sensitive help UA plugins in data tools platform plugin development. How a dedicated context sensitive help plugin interacts with DTP helper and the Eclipse help system runtime to provide dynamic context sensitive help for UI plugin. Context sensitive help UI plugins handle the mapping of help context to context specific help content and related online documentation topics. For projects that use DTP DTP helper, context sensitive help plugins contributes Eclipse context XML files which supply the context specific help content for each help context and point to other help topics contributions related to the help context. Java properties file which define the property key value parts that maps the abstract help key constant to concrete help context IDs and context specific help search expressions. Tip: the help key properties files usually contributed in pairs, each one for help context IDs and help search expressions. Following this diagram shows how the dedicated context sensitive help plugin interacts with the DTP helper and the Eclipse help system at runtime to provide dynamic context sensitive help for a UI plugin. During Workbench startup, DTP helper registers help key properties file contributions declared by context sensitive help plugins. Eclipse help system registers context content contributions declared by context sensitive help plugins. Online help TOC and topics contributions declared by documentation plugins. After Workbench is initialized, the GUI is presented with Workbench parts and controls contributed by UI plugins. Context sensitive help requests are usually handled by a UI plugin or its delegated help event listener for the Workbench parts and UI controls that contributes. When the user requests context sensitive help, for example by pressing F1 or clicking help icon, the following sequence occurs. One UI plugin requests a concrete help context IDs from the DTP helper plugin by passing an abstract help key. Two, DTP helper looks up the help context IDs by its associated help key in the help key properties file that was registered for the UI plugin. Step 3, the DTP helper returns a help context ID to the UI plugin. Step 4, the UI plugin sets the concrete help context IDs on its associated Workbench part or UI control, then passes that help context ID to the Eclipse help system to request the display of context sensitive help. Step 5, the Eclipse help system look up the context specific content and related topics by the help context ID, retrieves them from the context XML file that was registered for the UI plugin and then display them in the help view. Upon user request by clicking a related topic link, the Eclipse help system retrieves a help topic content contributed by a documentation plugin and displays it in the help view. Eclipse context XML file system Eclipse context XML files extension. Each plugin that contribute an Eclipse context XML file must declare an extension to org.eclipse.help.context in its plugin and plugin manifest plugin.xml file. Help key properties files extension. Each plugin that contributes help key properties files must declare an extension to org.eclipse.datatools.help key properties in its plugin manifest plugin.xml. Context sensitive help plugin IDs. Context sensitive help plugin IDs. Plugins can be supplied as dedicated plugins which point to related help topics that are contributed by other online documentation plugins, but do not contribute any help topics themselves. You can see here in the startup context sensitive help plugin is connected to helper plugin and Eclipse help system. Doc plugin is connected to Eclipse help system. In runtime, here you can see the UI plugin implements UI objects, dialog editor, etc. Define UI context as abstract help key. Handles context sensitive help request events. Request external context IDs from helper. Sets concrete context IDs ID on control and passes request to Eclipse help system. And UI plugin is connected to helper plugin. Registers help key property contributions. Handle context ID request. Looks up help key in properties files to find help context IDs. Returns concrete context ID. Helper plugin is connected to context sensitive help plugin. Declares extension to help key properties to contribute help key properties files. Inside context sensitive help plugin, you can see properties files and context XML file. Map help key constant to context IDs and search expressions which related to properties file. Context XML file maps concrete context IDs to help content and related topics. Here you can see with context sensitive help declares extension to help key properties to contribute help key properties files and declares extension to org.eclipse help key org.eclipse.help.context to contribute context manifest. And then helper plugin is connected to UI plugin here. UI plugin is connected to Eclipse help system. Registers iContext context contributions. Registers TOC contributions. Handles request for context sensitive help by context ID. Looks up context IDs to find context specific content and related topics. Displays context sensitive help to related topics links. Displays related topics on request. Eclipse help system is connected to context sensitive help plugin, and Eclipse help system is connected to then doc plugin here. Declares extension to org.eclipse.help.toc, contributes toc.xml and online documentation help topics. Help content is inside doc plugin. This is help content. Help topics in XHTML files. As an example, we can consider this code for creating book, and this file is books.xml. Here a book is just a table of contents. In fact, we could make a book out of each of the 3 TOC files here. but we will treat them as sections of a larger book instead. The one remaining piece of work is to update our plugin XML to actually contribute the TOC files that we created. Start with updating the plugin.xml to contribute our book. The important thing here is to define the table of contents as primary. And next we contribute the section TOC files, and the important thing here is that primary is not set, so its default value false gets picked up. That's it. You are done. Now take your plugin and drop it into the platform's plugins directory, that Eclipse, and start Eclipse and choose help, then help contents. Once you select the online help sample, then and expand the topics, you will see following. And as a small brief recap, we started by creating our plugin and document files. Next we created TOC files to describe the structure navigation of our content. Then we then created the TOC file for the book and linked the other TOC files as sections of the book. Finally, we contributed all the files in the plugin.xml in the org.eclipse.help.toc extension point. Now we are considering a package org.eclipse.help provides core help system for the platform. The extension point org.eclipse.udt.ui.c help provider, the C help provider here. Now we are considering the help view in help. You can open the help view from the main menu by selecting help, dynamic help, or help, then search. Help view provides help inside the workbench. You can open the view from the main menu by selecting help, dynamic help, or help, then search. Help, then dynamic help, or help, then search. The view will open showing the related topics or search page respectively. You can use link at the top of help view to turn to the other pages. Now we are considering the help window. You can open the help window from the main menu by selecting help, then help contents. The help window provides the same content as the help view, but in a separate window instead of in a view. You can open the help window from the main menu by selecting help, then help content. First view shown in the window is called the content. This view displays the table of contents of the product documentation. Click on one of the link to expand the navigation tree or set of documentation. Note that if your browser does not have JavaScript enabled or is and does not support the features required to display the normal helps application, basic help which will be displayed. This can easily be identified because closed books in the table of contents do not have the expand icon. You can find the user agent of your browser also. Now we are considering context sensitive help. Context sensitive help can be accessed by bringing the focus to the interface part in the question by clicking in it or using the tab key and then pressing F1, shift F1 on GTK plus and the help on the Mac. If you are working through a task and encounter part of the interface that you do not understand, you can summon context sensitive help by default. This will display the help view and give you some specific information about view editor dialog you are using and possibly some link to topics for further help. Context sensitive help can be accessed by bringing the focus to the interface part of the question and by clicking in it or using the tab key, then pressing F1, shift F1 on GTK plus and help on the Mac. Alternatively, in dialogues you can achieve the same result by pressing question mark help button in the dialogues button bar. Now we are considering setting the HTTP port and hostname in Rich Client Platform RCP help in configuration and setup in platform plugin. Here the server port equal port number specifies the port number that the help server will use. Now we are considering completing the plugin manifest in help content. Instead of providing an href for each topic, we use the link attribute to refer to our existing TOC files. The identifier org.eclipse.help.toc for registering an online help contribution for an individual plugin. We started this example by in the beginning we started the example by creating plugin and document files. Next we created the TOC files to describe the organization of our content. I didn't include those codes. The remaining piece of work is to pull everything together into the master TOC and update our plugin.xml to actually contribute the master TOC. We start by creating toc.xml to contribute the 3 docs we created initially. Instead of providing href for each topic, we use link attribute to refer to our existing TOC files. Then we update the plugin.xml to contribute our master TOC. Note the use of primary attribute. Setting these attributes true indicates that the TOC should always appear in the navigation, and even if it is not referenced by any other TOC. This way our master TOC is always guaranteed to show up in the topics list. It appears at the top level list of the book since no other TOC references it. Note, if more files were associated with this TOC but not present in the navigation, but it just linked from the other topics, then to have those topics available to search engine, we would have to use the extra dir attributes in the TOC. Finally, we contribute our individual TOC files. Those TOC files will not appear at the top level list of books because we did not set the primary attribute. TOC files that are not designed as a primary will only appear in the documentation web if they are referenced from some TOC that is primary TOC or is linked in by a primary TOC. That is it. That's it. If you copy your plugins directory to the platform's plugins directory, start the platform and choose help, then help contents. You should see the example appear in the list of books. If you click on the online help sample, you will see your TOC structure. Now we are considering describing and packaging of packaging context sensitive help in context sensitive help. Since 3.1, context elements can optionally override the default title used for which represent the context help information in the help view. The identifier org.eclipse.help.context for defining context sensitive help for an individual plugin. Declaring a help context ID, the set help method in org.eclipse.ui.help.I workbench help system is used to associate the context with the control and iAction menu or menu items. The context ID should be fully qualified with the plugin ID. For example, the following snippet shows the ID com.example.help.example.panic button with the button in the application. The following UI controls cannot have context IDs and therefore cannot have context sensitive help. Toolbar buttons, tool item, C tab item, table column, table item, table tree item. Widgets that do not get focus should not be assigned context IDs since they will never trigger a context sensitive help. Note the default implementation of help will display the dialog tray only if the dialog is either large enough to accommodate it or resizable. Otherwise, an info pop will be shown. Describing and packaging context sensitive help content. Context sensitive help is designed by associating the context ID declared in the UI code with a description and a list of links related to related topics and commands in the online help. These associations are made inside an XML file located within a plugin that contains the topics in question. You can create any number of XML files containing context help association for each plugin. The description and links for elements for each context ID is made inside the context elements in the XML file. Each context element can have optional description element which is used to describe the UI objects and any number of topics elements which link to the online documentation, as well as command links to perform any operations for the user, for example open a cheat sheet. Since 3.1 the context elements optionally override the default title used to present the context help information in the help view. Once contexts have been described in the XML file or files, you are ready to refer the context files in your plugin manifest. Note that the context ID is not qualified. Plugin containing context files contributes them using org.eclipse.help.context extension point. You can reference context file from other plugins by including plugin attribute, which allows you to group all your documentation including context sensitive help in one plugin and refer to it from UI code plugin or some other related plugins. When the context ID is declared in an extension point in the Eclipse help system, will create a fully qualified context ID from the plugin name.context ID and use this when matching against the context ID used for in Java source. Plugin name is the value of the plugin attribute, so if not specified the name of the plugin in which the org.eclipse.help.context extension is declared. Now we are considering plugging in search engines in help search. New engine types are contributed through org.eclipse.ui.search engine. Identifier org.eclipse.help.ui.search engine. This extension point is used to plug in search participant in federated help search. Each search engine can be configured individually. When search is initiated, each search engine is executed as a background job, and the results are collated in the help view immediately under the query. New federated information search in the help system uses the notion search engine types and search engines. In an engine types is the metadata engine from which a number of concrete search engine can be created by parameterization. New engine types are contributed through org.eclipse.ui.search engine. This extension point is used to plug in search participant in the information search. The search engine, each search engine can be configured individually. When search is initiated, each search engine is executed as a background job, and the results are collated in help view immediately under the query. Search engines defined here will not automatically shows up as a federated search participant until engine product binding is established, unless product ID attribute is left undefined. For engines that define it, only those bound to a particular product will show up when the product is running. Search engine can simply compose a URL and provide only one hit containing that URL as href. Popular search engines for for which API support requires license can be plugged like this. On the other end of the spectrum, search engines can communicate with the server and receive individual hits with information like label, href, short description, scores, etc. Local help engine can produce hits this way. Regardless of the search mechanism, engines can provide various search scope settings using JFace preference pages. These pages are shown when advanced settings linked is shown in the help view. In addition to the root preferences pages defined with the engine, additional preference subpages can be plugged in for more advanced settings. Scope settings are loaded and stored using iPreferences store object. Scope settings for all engines are grouped together under a name scope set. When first opened, the default scope set default is created, but users can define more scope sets and flip between them. Since federated search support is part of org.eclipse.help.base plugin, a factory is needed to create a search engine scope objects from the data in the preference store. Clients that plug in scope preference pages are required to plug in the scope factories as well. Engines defined in this extension point do not show up in the UI by default. What is shown here is a concrete instance of a search engine that can be individually modified. Products can be pre-configured the help system with the number of instances of registers engine types, possibly parameterized to perform a desired way. In addition, so users can add their own instances of registered engine and configure them to their liking. Now we are considering deploying the information center as a web archive. The instructions here assume the Tomcat server has been installed, but with minor modification. These steps should work for any full features server. Using Eclipse 3.4 or later, it is possible to configure the help plugins to be deployed as a web archive WAR file, which will act as a fully functioning information center. Instruction below assume a Tomcat server has been installed, but with minor modification. These steps should work for any full features server. Clone the eclipse.platform.ua repository. Here get clone https://git.eclipse.org/r/platform/eclipse.platform.ua.git. In the Git repository locate the info center web directory, and underneath that there will be two directories titled info center app and info center product. Make sure you have the M2E Maven integration for Eclipse feature installed in your Eclipse IDE. Import the info center Maven web Maven projects using file, then import then existing project. Add some documentation plugins to the info center web info center app, src main web app web plugin web info plugins directory. Register the plugins in info center web info center app src main web app web info configuration for then org.eclipse.equinox.simple configure /bundle.inf. Install required Maven pumps from Eclipse platform. This is the command here. execute the Maven build in InfoCenter Web, either within Eclipse. Right click the InfoCenter build.launch and select run as then InfoCenter build, or command from the command line using command mv and w. For Tomcat only, in config /server.xml add URI encoding equal UTF-8 to the connector element. For example, this is the line. If this step is not performed, search will fail if the search term contains none ASCII characters. Start Tomcat and see the help system startup. The default URL is http://localhost:8080/help/. Notes, if you look in the config.ini and help.var file under directory help, then web_inf, then configuration, you will notice the line eclipse.product equal org.eclipse.product name. If your product has help system customization in the product plugin, you can activate this by changing this line to point to your product plugin. Here now we are considering help section in simple cheat sheet editor in editors in plugin development. Example of help link added to a step or introduction defined using the help context ID as input. Note this section is expanded by default when help context ID is specified. This section is accessible by selecting step or introduction mode in the content section. This section contains following field: type, a combo box, help, link type. Select none to remove a help from a step or introduction. Subsequently, the value input field will no longer visible. Select help context ID to make the value input field visible right under the field and ready to accept the help context ID as input. Select a help document link to help the to make the value input field visible and right under this field and ready to accept the help document link as input. And the label here, the label value type text, help document link value or help document ID value. If the help context ID is selected in the type field, specify a value help context ID in this field to add a help link to a step or introduction. In the cheat sheet view, clicking on a step or introduction help link created using a help context ID will open a help context ID in the help view. Format of a valid help context ID is the following: plugin id.help context ID. If help document link is selected, the type field, specify a valid document link in this field to add a help link to a step or introduction. In the cheat sheet view, click on a step or introductions help link created using help document link will open that help document link in the help info center. Format of a valid help document link is following: plugin ID path HTML file. Example of a help link added to a step or introduction defined in the help context ID as input. Note this section expanded by default when a help context ID is specified. Now we are considering help in help preferences. In preferences, open help search configures whether help or search and help or index, if configured, opens the opens the help view or help contents. The default is in the dynamic help view. Now we are considering dynamic context sensitive help in introduction to context sensitive help in data tools platform, helper in data tools platform. The two pieces of dynamic context context sensitive help include an interface class org.eclipse.help.iContextProvider and a help view, a workbench part. The interface iContextProvider, dynamic context provider, classes that implement this interface should be returned from adaptable objects when iContextProvider.class is used as an adapter key. Adaptable objects must implement the org.eclipse.core.runtime.iAdaptable interface. This is in the package org.eclipse.help. To provide dynamic context sensitive help, the UI component must define an association between UI controlled and help context dynamically by implement the methods of iContextProvider. Get context object target returns the help context ID for the given target. Get context change mask returns the mask created by combining supported change triggers using bitwise O operation. Get search expression object target returns the search expression that the help system should use to find more help content related to the current target. Help view tracks the activation of workbench part, view and editors, and it checks to see if they adapt to the iContextProvider interface. If they do, the help view uses iContextProvider methods implemented in the UI component to locate a corresponding iContext object. The iContextProvider.getContextChange mask methods provide the mask that the help view uses to determine when a context change occurred dynamically, for example, as a result of a user gesture to change UI focus. When a help view detects a context change, it updates its context sensitive help presentation to display the content of the iContext object that is associated with the current context, that is the name and the description of UI control and the list of related topics. Dynamic help search results a list of help topics found using the search expression that was returned by the iContextProvider.getSearchExpression method. The content of the iContext object and its associated with particular help IDs is defined by the context XML, which is usually contributed by UA component. Register iContext content contributions with the help system. A UA plugin must declare an extension of org.eclipse.help.context, identifying both the context XML file and the UI plugin for which iContext content is contributed. The DTP, now we are considering DTP helper. DTP helper plugin org.eclipse.datatools.help provides a help key extension point org.eclipse.datatools.help.help grid properties and supplies a context provider delegate implementation org.eclipse.datatools.help.context provider delegate. The help grid properties extension point allows any plugin to contribute resource bundle properties files that define the mapping and abstract help keys to concrete help IDs, help context IDs, and help search expressions. Now we are considering view implementation example in context sensitive help UI implementation. Implementation of the iContextProvider methods look like this. The interface iContextProvider dynamic context provider classes that implement this interface should be returned from the adaptable object when iContextProvider.class is used as an adapter key. Adaptable object must implement org.eclipse.core.runtime.iAdaptable interface. This is in the package org.eclipse.help. The data source explorer view in org.eclipse.datatools.connectivity.ui.dsc First implements the org.eclipse.help.iContextProvider interface, and then it creates an instance of the org.eclipse.datatools.help.iContextProvider delegate. The symbolic name is usually the plugin ID. Providing the symbolic name as shown above will avoid the broken code if the plugin's ID changes. The plugin ID passed to the context provider delegate must get symbolic name here. The plugin ID passed to the context provider delegate must indicate that which plugin the help context is actually associated with. In the example above here, the help context is associated with the DSC plugin. That is the plugin that contributes the Data Source Explorer View UI component. However, the help context should be associated with a separate plugin. For example, if the plugin in owner of the UI component is not the same as the plugin in the contributes UI component. The implementation of the iContext provider methods look like this. After implementing the iContext provider methods, the view must set the help context for the control in the create part control method. The string passed to the help method is actually an abstract key constant whose property key is mapped to the concrete help ID string by the context provider delegate. All help key constant strings must be declared in an interface class. Help key properties files. Now we are considering help key properties files. The following expert is from a help key property file which contributed by the org.eclipse.datatools.doc.user.context plugin to define concrete help context size strings. A help key properties file defines the mapping of help key constant property keys either to actual help context IDs or to a context specific help search expressions. Help key properties files are usually contributed in pairs, one for context IDs and one for search expressions. Help context IDs strings defined in the help key properties files cannot be fully qualified context IDs. They must include any blank. They must not include any blank space or period dot characters. DTP helper handles unqualified help context IDs defined in the properties file to fully qualify them before it returns them to the UI control through context provider delegate. The following expert is from the help key properties file which is contributed by the org.eclipse.datatools.doc.user.context plugin to define concrete help context ID strings. Notice that the two abstract help contexts represented by the help key constant context ID CP wizard page and context ID intro wizard page. This is an example of flexibility afforded by abstract help context, allowing UA component to combine multiple abstract help contexts in a single concrete help context ID, which is independent of the help context implementation in the UI component. Following example shows the mapping of help key constant to a context specific help search expression in the help key properties file. Search expression strings must conform to rules for the Apache Lucene query parser syntax. Note that the keywords in search expressions are not case sensitive, but the Boolean operators, for example, and, not, or, must be all uppercase. Help key properties file names. The names of the help key properties files are arbitrary as long as they end with the dot properties. However, a context sensitive help plugin could contribute pairs of help key properties files for several UI plugins, and the files need to have unique names if they were located in the same directory. Context IDCP property page equal basic profile name description auto connect property page. Context IDCP wizard page, wizard selection page in the connection profile wizard. Context ID intro wizard page, basic intro page for new connection profile wizard. Context IDCP property page, basic profile name description auto connect property page. Here you can see end. Now we are considering context sensitive help UA plugins. Eclipse context we are considering Eclipse context UXML files extension in context sensitive help UA plugins. For example, here each plugin that contributes an Eclipse context XML file must declare an extension to org.eclipse.help.context in plugin manifest plugin.xml file. For example, here now we are considering development team responsibilities in team reps responsibilities and collaboration. Development teams are primarily responsible to this. Development teams should provide list of help key constants in the form of Java source files for help key constant interface classes. Development teams are primarily responsible to implement the Eclipse classes and methods necessary to enable dynamic context sensitive help for all appropriate UI controls. Implement the interface classes that declare help key constants for each UI plugin. Provides a list of help key constants to documentation teams in a timely manner. Test the context sensitive help UI implementation with the context sensitive help UI plugins and online documentation plugins provided by documentation teams. Java source files provided as help key list must include the help context comments to provide information about each associated UI control. Now we are considering documentation team workflow. Following list summarizes the overall documentation team workflow to create context sensitive help plugins. Documentation team has several responsibilities. Documentation team should refer to the product architectural specifications to define the appropriate architecture, that is granularly content partitioning, plugin naming, and so on. For online documentation plugins with that information, documentation teams can begin the process to create context sensitive help plugins. The documentation team workflow described in this section assumes that dedicated context sensitive help plugins will be produced from the DITA XML map documents. The workflow can be adjusted for help content source formats. The following list summarizes the overall documentation team workflow to create context sensitive help plugin. First, step 1, get the help key list provided as a Java source file from the UI development team for each plugin. Step 2, analyze the help key list and associate UI control to define help context. For more information, see defining help context IDs in documentation. Step 3, the documentation team must determine whether the help key constants alone are sufficient to identify actual help context. Thus, help key constants map directly to a concrete help context ID with the same string value as a help key constant. Distinct help context ID strings must be defined to combine groups of help key constants into common help context. Tip: it may be preferable to combine help context in the help key properties file instead of defining a mapping for multiple help context to a single topic in a data map. This is a judgment call for documentation team lead and IA responsible for maintaining data maps. Actually, this is the step 3. Analyze the help context and existing or planned help topics to define context specific help search. So step 2 is this one, and step 3 is this. And step 4, create help key properties files based on the context of each Java source files. Define the mapping help key constant to concrete help context IDs and context specific help search expressions based on the results of the help context analysis and help topic content analysis. Save the help key properties file in a source control as appropriate. The tip: the help key properties files are flat ASCII files, so the authors or IA responsibilities for defining the help key context IDs and context specific help search expressions should use a suitable ASCII text editor to create and edit those files. Step 5, modify existing data maps if used to produce the online documentation plugins to add the markup for context sensitive help. Step 6, test the deployment context sensitive help plugins with UI component provided by development teams. Help context IDs, because help key constants are abstract entities in the Java code and independent of actual help context IDs. Documentation teams are responsible for defining the help context and which Eclipse help system uses to locate the context specific help content and associating each help key a constant with an actual help context ID. Help search expressions: each help context should be associated with the context specific help search expression, which the Eclipse help system will use to provide dynamic help search results in the help view. Context sensitive help plugins with DITA. Any DITA mapped document that define the online documentation doc plugin can be modified to define a corresponding context sensitive help plugin by inserting appropriate context related markup. Now we are considering UI plugins associated with help context. In context sensitive help plugins with data. Data maps for context sensitive help plugins must contain topic meta elements as the first child of the map element. For each UI plugin whose help context ID is identified, the map that topic meta element must contain other meta element that identify the UI plugin. Note the other meta elements that identify UI plugin should be the last element in the topic meta element. The topic meta element may contain any other valid elements preceding other meta elements that identify UI plugins. The other meta elements name and content attributes values will be used to identify UI plugins in the org.eclipse.help.context.extension, which is declared in the plugins manifest plugins.xml file of the context sensitive help plugin. For example, here the name attributes value UI plugin is fixed literal string. The content attributes the value is the Eclipse plugin ID of the plugins in plugin. Nested maps that contribute context related help topics must include the same markup to identify each plugin whose context IDs are identified in that map. Now we are considering debug mode in test dynamic context sensitive help. They use the following command line options to start the platform in debug mode. The Eclipse platform debug mode can be useful for testing and troubleshooting dynamic context sensitive help. Use the following command line options to start the platform in debug mode. Set the following debug options in the .options file. Now we are considering using the help window in navigating help topics in accessing help to navigate the help window here. The help window is a separate window separate from the workbench used exclusively for browsing, searching and printing help. To open the window, select help, then help contents from the menu. This opens the help window with the contents view visible, which shows the table of contents. To navigate the help view, find the topic you want to read in the table of contents by clicking to expand the subtopics. Most topics provide the list of links to related topics at the bottom. Follow these links to learn more. Use the go back and go forward buttons to navigate back and forth. These behave the same way as in the web browsers. And step 4, use the home button to return to the help home page as shown to the help page. Now we are considering query syntax in searching help. For example, here, unless otherwise stated, there is an implied and between all search terms. In other words, topics that contain all search terms will be returned. For example, here. Now we are considering defining a topic-based scope in help contents in using help scopes. If the documentation set does not support scoping by criteria, the dialogues will be similar to the one here. In this case, only the topics in the Workbench users guide will be shown. From help contents, the scope is changed by clicking on the link labeled scope next to the search type in area. This opens a scope selection dialog. Click new to create a new scope. This opens a new scope dialog which allows you to select which topics to show. If the documentation set does not support the scoping by criteria, the dialog will be similar to the one here. In this case, only the topics in the Workbench users guide will be shown. Now we are considering accessing context-sensitive help. To access the context-sensitive help for a given widget, here, select the widget by putting focus on it, and press F1 key. Shift +1 on Linux, help on the Mac, or in dialogs, click the help button, help icon in the button bar. This displays a description of the selected widget and usually a list of links to the related information in the help view. If you want more information than that what is shown in the description, click a link to one of the related topic or one of the search results appearing in the dynamic help section in the help view. Depending on the help preference settings, requesting context-sensitive help may display context help in info pop-up instead of help view. You can dismiss the info pop-up by clicking outside it or by pressing escape. Now we are considering external browser in help display settings. If you prefer to always use the full external browser, you may select this behavior in the command link help preference page. The help system can be accessed in the help view or separate help window. The window can be the default window with an embedded browser or a full external browser of your choice. If the embedded browser is supported on your system, help will use it by default to display the help. If you prefer to always use an external browser, you may select this behavior in the help preference page. Now we are considering help accessibility. To change the help browser's font and color settings here. The help browser uses your operating system settings for font colors, styles, and sizes. Users with visual impairment may wish to change some of these settings to increase the readability of the documentation. In addition, on Windows platforms using Microsoft Internet Explorer, the help browser uses a component of Internet Explorer to display documentation. So change you make to its display settings also affect the help display. To change help browser's font and color settings, open Microsoft Internet Explorer, select Tools, the Internet Options. Step 3, the general page. On the general page, click Colors, Fonts, and Accessibility options. Step 4, set the formatting options you desire. Step 5 is optionally you can specify a cascading style sheet to apply to the content. Step 6, click OK and exit Internet Explorer. 7, restart the Workbench, open the help perspective and browse the documentation to see the changes. Note the help system also uses the icon font settings on the display properties appearance tab. For more information about creating CSS, consult a CSS reference. W3 Consortium www.w3.org has extensive collection of information about CSS and links to valuable resources. Now we are considering help menu in Workbench menus. Help content. This command displays the help content in a help window or external browser. The help content contains the help books, topics, and information related to the Workbench and installed features. Now we are considering contents in help view in views. The content page shows the table of contents. It's a hierarchy of all help topics arranged in a tree. A tree branches can be expanded to browse topics that can be displayed using a single mouse click. Now we are considering help menu in PHP perspective menus. Help contents. Open the online help page. Now we are considering adding new help context in context help editor. To add a new context, click add context button. This will add a new context entry to the XML and it will be displayed in a tree on the definition page. The new context will be selected, opening a detail section in the right column of the editor. In this detail section, you can provide more details, information about the context, including help context ID. That is passed to the UI element to associate the help. Description text that will be displayed to the user in a dynamic help to explain the basic function of the selected UI element. Custom page title. By default, the dynamic help displays the name of the selected UI element as the help title, and entering text here will override the default. Now we are considering contributing marker help in marker help and resolution in Workbench resource support. The readme tool display class several to help context. The identifier org.eclipse.ui.ide.marker help. This extension point is used to associate a help context ID with a specific kind of marker, a marker of a certain type or having certain attributes. Now we already look at how to add the help to the readme tools markers. Adding marker help is done using the org.eclipse.ui.ide.marker help extension point. This extension points allows plugins to associate help context IDs with a particular type of marker. The marker will be qualified by a marker type only, or it can be further qualified by the value of one or more its attributes. The readme tool declares several different topic context. Each marker help context is defined for the readme marker type. However, each help context is associated with the different combination of attributes values. The help contexts are defined. The first marker help context will be used for markers whose ID attributes are set to 1, 3, 2, 4. The help contexts are defined in the plugins help context.html. Sure enough, when we select the readme marker ID 1, 2, 3, 4, and the select help using F1, we see our help in the view help view. Now we are considering about this wizard in new context help wizard, in new file creation wizards, in wizards and dialogues in reference. To start this wizard, click file, then new, then other, then user assistance, then context help. This wizard allows you to create new context help. Upon completion of this wizard, the new context help will be created with basic content and opened in the context help editor. Now we are focusing on Workspace. The various tools plugged into the Eclipse platform operate on regular files in the user's workspace. The workspace consists of one or more top-level projects where each project maps to a corresponding user-specified directory in the file system. The different projects in a workspace may map to different file system directories or drives, although by default all projects map to sibling subdirectories of a single workspace directory. Here you can see select workspace dialog. As an example, we can consider this code segment. iWorkspace workspace equal resources plugin.get workspace. Interface iWorkspace. Workspaces are the basis for Eclipse platform resource management. There is only one workspace per running platform. All resources exist in the context of this workspace. iWorkspace is in package org.eclipse.core.resources. As an exception example, we can consider co-exception. If the method fails to copy some resources, the status contained in the exception may be multi-status, indicating where the individual failures occurred. Here we consider the exception which can occur in public iStatus copy iResources resources iPath destination boolean force iProgress monitor method in interface iWorkspace. And as an example too, we can consider workspace preferences. You can access workspace preferences from Eclipse menu, then window, then preferences. Now we are considering workspace in preferences. Refresh using native hooks or polling in options. If this option is turned on, then the workspace resources will be synchronized with their corresponding resources in the file system automatically using native refresh providers or on Windows or a polling mechanism. Note, this can be potentially be lengthy operation depending on the number of resources you have in your workspace. The default is off. Now we are considering switching workspaces in development environment. In references, the combo will also allow you to select your previously selected workspaces. The current workspace for Eclipse can be switched by using the file then switch workspace command. If you already switched your workspace previously, the previous workspace will be available for selection in switch workspace menu. The switch workspace, then other menu item will open the switch workspace dialog. The dialog will allow you to browse for or manually enter the new workspace location. The combo will also allow you to select your previously selected workspaces. Settings transfers. When you switch your workspace, you can select settings then will be transferred to the new workspace. These settings are supplied by the org.eclipse.ui.preference transfer extension. The SDK supplies transfer for workspace layout, opened views, their size, and selected perspectives, working sets, the user-defined working sets. Now we are considering batching resource changes, modifying the workspace. The code that manipulates the workspace is performed inside the run method. Void run iProgress monitor executes the runnable. Interface iWorkspace runnable. This interface is structurally equivalent to iCore runnable. The new code should use the iCore runnable instead of iWorkspace runnable. This is in the package org.eclipse.core.resources. When you need to modify resources in the workspace, it is important to keep in mind that other plugins might be working with the same resources. The Resources API provides robust mechanisms for keeping plugins informed about changes in the workspace and for making sure that the multiple plugins do not modify the same resource at the same time. Where possible, your plugin modification to the workspace should be batched in units of work inside Workspace Runnable. These runnables help to reduce the amount of change notifications generated by changes. They also allow you to declare which part of the workspace is to be modified so that the plugins can be locked out of changing the same part of the workspace. The protocol for iRunnable is very simple. A workspace runnable looks just like long-running operation or platform job. The actual work is done inside the run method with progress reported to the supplied iProgress monitor. Code that manipulates the workspace is performed inside the run method. When it is time to run the code, your plugins tell the workspace to run the code on its behalf. This way, the workspace can generate any necessary change events and ensure that no two plugins are modifying the same resource at the same time. Even if your plugins is not using background jobs and concurrently framework to modify the workspace, other plugins may be doing so. Do actual work in here. Now we are considering registering a listener in tracking resource changes. First you must register a resource change listener with the workspace. The interface iResource change listener. A resource change listener is notified of changes to resources in the workspace. These changes arise from the direct manipulation of resources or indirectly through a resynchronization with the local file system. This is in the package org.eclipse.co.resources. Your listener will be notified after modifications to the workspace resource have been made. Resource API methods that modify the resources trigger these events as part of their documented behavior. The method comment for the resource API method explicitly state whether or not it triggers a resource change event. For example, the following here included in the ifile.setContents comment. The methods that create, delete, and change a resource typically trigger these events. Methods that read but do not write resources typically do not trigger these events. Now we are focusing on MySpace jobs in concurrency and workspace. The work is moved to the appropriate method of our workspace job type here. The class workspace job, a job that makes an atomic modification to the workspace. Client must implement an abstract method run in workspace instead of usual job.run method. This is in the package org.eclipse.co.resources. A job is a basic unit of synchronous work running concurrently with other jobs. The resource plugin defines workspace job as a convenient mechanism for defining asynchronous resource modifications. Code that would normally be batched in the iWorkspace runnable is instead put into the run in workspace method of workspace job subtype. Instead of running the code using iWorkspace, protocol, the job is scheduled just like any other job. The appropriate scheduling rules must be added on the job before it is scheduled. Let's look at an example workspace runnable and what we should do to make it your job. The work is moved to the appropriate method of our work job space. To do the subtype, our runnable had to invoke especially. Our job is scheduled like any other job. Platform job manager will run it accordingly its priority. Other jobs in the queue and the scheduled rules. Note that we must attach the scheduling rule to the job in order to prevent simultaneous modification of my project. Note that the operation had been structured as a job of all the scheduling mechanism. Priority delay rescheduling can be used. Resource changes event will be batched until the job is finished running. Do the actual work here. Do the actual work here. Now we are focusing on a sample resource tree in resources and the workspace. Each node other than the root is one of the three kind of resources, and each has a name that is different from its siblings. The tree below, represented in Workbench Navigator view, illustrate a typical hierarchy of resources in a workspace. The implied root of the tree is the workspace root. The projects are immediate children of the workspace root. Each node other than the root is one of the three kinds of resources, and each has a name that is different from its siblings. Resource names are arbitrary strings, almost they must be a legal file names. The platform itself does not dictate resource names, nor does it specify any names with special significance. One exception is that you cannot name a project.metadata since this name is used internally. Projects contain files and folders, but not other projects. Projects and folders are like directories in the file system. When you delete a project, you will be asked whether you want to delete all the files and folders it contains. Deleting a folder from a project will delete the folder and all of its children. Deleting a file analogs to deleting file in the file system. Now we are focusing on startup and shutdown workspaces in preferences. Prompt for the option prompt for workspace on startup. If this option is turned on, then the workbench will prompt you each time it is started for what workspace to use. The default is on. Now we are considering implementing a save participant. Let's look at a simple plugin which demonstrates the save process. The interface iSave participant, a participant in the saving of the workspace. This is in the package org.eclipse.ucore.u resources. To participate in workspace saving, you must add the save participant to the workspace. This is typically done during your plugin startup method. This is also where you read any state that you might save when your plugin was last shut down. Let's look at the simple plugin which demonstrates the save process. iSave participant defines a protocol for workspace save participant. Implementers of this interface can provide behavior of different stages of the save process. The plugin instance should read any important state from the file. Now we are considering package org.eclipse.emf.cdo.workspace concepts to check out, open, and further operate CDO workspaces. The package org.eclipse.emf.cdo.spi.workspace server provider interface SPI for CDO workspaces. Package org.eclipse.emf.cdo.transfer.spi.workspace client concept for dealing with transfers of resources between systems. For example, we can consider this situation in Eclipse Oxygen. Eclipse Oxygen stuck loading workspace. Now we are focusing on team. The team component is responsible for providing repository tooling integration into Eclipse and a universal compare facility for use by repository tooling and others. The Eclipse platform allows a project in the workspace to be placed under version and configuration management with an associated team repository. The platform has extension points and a repository provider API that allow new kinds of team repositories to be plugged in. Here you can see in M4, Java implements a team-aware content provider which allows the effects of an update to be shown with respect to the Java model. API has been added in M4 that allows models to provide a team-aware content provider that can be used by team providers to display the effect of a team operation in terms of model elements and hierarchies. The CVS team then update context menu action in Eclipse 3.2 milestone for M4 can be configured to display logical model elements and hierarchies, then previewing the effects of an update. You must run the perform client side merges on update preference on the team, then CVS, then work in progress preference page. There are 3 steps required to create a team aware content provider. Step 1, create extension to the org.eclipse.ui.navigator content extension point. Minimally, you will need to provide the content provider and label provider and an enablement rule that matches the appropriate model elements. The enablement rule should also match both iResource mapping scope and iSynchronization context, as either of these could be used as an input object to a team viewer. Step 2. Associate your navigator content extension with the team viewer using the org.eclipse.ui.navigator.viewer extension point. The team viewer ID is org.eclipse.team.ui.navigator Step 3. Bind your context extension to your model provider using the org.eclipse.team.ui.team content providers extension point. As an example, we can consider team class. The team class provides a global point of reference for the global ignore set and the text binary registry. The team class is in org.eclipse.team.co package. As an exception example, we can consider team exception class. This exception is thrown by the team provider API. It represents a failure in an API call. Since some API calls take multiple arguments, the exception is capable of returning multiple statuses. The API definition determines if the exception represents a single or multiple status response. This can also be tested on the exception instance itself. And team exception class is in org.eclipse.team.co package. Here we are considering identifying yourself. You can always change the information using GIT configuration. Click window, then preferences, then team, then GIT, then configuration. Then next step, click new entry and enter the key value pairs, email, user.email and user.name. Here you can see user.email key value pair. Here Eclipse team provider is EGIT. Now we are focusing on package org.eclipse.team.co application programming interfaces for defining and working with repository providers. The identifier org.eclipse.team.co.file types. This extension point is used to register information about whether particular file type should be considered to contain text or binary data. This information is important to some repository providers as it affects how the data is stored, compared and transmitted. Now we are considering team in preferences. The option show all synchronization information in resources text label. Use this option to have synchronization state of a resource displayed as text in a resources label. By default, only an icon decorator is used to identify the resources synchronization state. The default value is disabled. Now we are considering a repository extension point in repository providers in team support. here is the markup for CVS client. The class repository provider, a concrete class of a repository provider is created for each project that is associated with the repository provider. The lifecycle of these instances is similar to that of the platform's nature mechanism. This is in the package org.eclipse.team.co. The org.eclipse.team.co.repository extension point is used to add a repository definition. Here is a markup for CVS client. This registers your team provider with the team support plugin. And assign an ID that should be used when your provider is associated with the project. The specified class for the repository must extend a repository provider. Implementing a repository provider. This class, the class identified with the extension must be a subclass of repository provider. Its primary responsibilities are to configure and deconfigure a project for repository support and supply any necessary resource modification hooks. The CVS client serves as a good example. Its repository provider is CVS team provider. Implementing a repository provider. Here, the repository provider defines two abstract methods: configure project and deconfigure. All providers must implement these methods. A project is configured when it is first associated with a particular repository provider. This typically happens when a user selects a project, then uses a team wizards to associate project with your repository. Regardless of how operation is triggered, this is an appropriate time to compute or cache any data about projects that you will need to provide your repository function. Assume that mapping the project to your provider has already happened. You will be taking care of this in your configuration wizard. CVS provider simply broadcasts the fact that the project has been configured. We won't follow the implementation of the plugin broadcast mechanism. Suffice is to say that any parties that need to compute or initialize project specific data can do so at this time. A project is deconfigured when the user no longer wants to associate team provider with the project. It is up to your plugin to implement the user action that causes this to happen, and unmapping the project from your team providers will happen there. The deconfigure method is the appropriate time to delete any project related caches and remove any references to the project in the UI. The CVS provider flushes project related to the caches kept in its views and broadcast the fact that project is deconfigured. flush deep here. Now we are considering ignored files in repository resource management. For example, the CAVS client declares the following. In several cases, it may be necessary to keep certain files under repository control. For example, resources that are derived from existing resources can often be omitted from the repository. For example, the compiled source files such as Java .class files can be omitted since their corresponding source *.java file is in the repository. It also may be inappropriate to version control metadata files that are generated by repository providers. The org.eclipse.team.co.ignore extension extension point allows providers to declare file types that should be ignored for repository provider operations. For example, the CVS client declares the following. The markup simply declares a file name pattern that should be ignored and selected attribute which declares the default selection value of the file type in the preferences dialog. It's ultimately up to the user to decide which file should be ignored. The user may select, deselect, and add or delete file types from the default list of ignored files. Now we are considering the basics sync info in synchronization support. The class sync info describes the synchronization of a local resource relative to the remote resource variant. There are two types of comparison, two-way and three-way. The iResource variant comparator is used to decide which comparison type to use. This is in the package org.eclipse.team.co.synchronize. The class in the classes in the org.eclipse.team.co.synchronize are used to describe the synchronization states. The most important class is sync info because it is the class that actually defines the synchronization state. It can be used as follows. The sync info class provides both the two-way and three-way comparison. Both the two-way and three-way comparison algorithms, the client must provide the resources and a class that compare the resources. iResource variant comparator. Here is an example variant comparator. This package also contains collection of specifically designed to contain sync info and filters that can be applied to sync info instances. This is a simulated method of obtaining the sync info for a resource. Do something else. calculate the sync info. Here you can see when we are creating a sync info object, the timestamp comparator is passed as an argument. Here it's not passed. Now we are considering model content theme viewers in repository roadmap for logical model integration in support for logical model integration. The following XML snippets illustrate how the CVS participant class is registered and how its viewer is defined. Identifier org.eclipse.theme.ui.synchronize participant. This extension point is used to register synchronize participant. The synchronize participant is a component that displays the changes between resources and typically allow the user to manipulate the changes. For example, CVS defined the workspace synchronize participant that allows showing changes between its workspace resources and the resources at the remote location, that is to share those resources. Synchronized participants are typically created via a synchronized participant wizard, or they can be created via a plugin action and then registered with the iSynchronize manager. The synchronize view displays the synchronized participants. Support for display of logical models in a team operation is provided using the Common Navigator framework, which was introduced in Eclipse 3.2. The logical models can associate the content extension with the model provider using org.eclipse.theme.ui.theme content providers extension point. Team providers access these content providers through iTeam Content Provider Manager. There are several places where a team provider may wish to display logical models. When the scope of an operation has been expanded due to model provider relationships, the model operation class provides a prompt that uses the registered team content providers to inform the user of a scope expansion. When a merge preview is required, the model synchronization participant class makes the use of the team content providers and the merge context to display a merge preview. Team providers can extend this class in several ways to tailor the preview. The model synchronized participant provide integration into the synchronized view or a container that can display asynchronous pages. The participant make use of both pre-existing synchronization participant capabilities and the Common Navigator capabilities to allow team providers and models to tailor the toolbar, context menu, and other aspect of the merge preview. The model synchronization participant provide the following: a synchronized page that defined link between the scope manager, merge context, and the team content providers. Toolbar actions for displaying direction modes, incoming on outgoing both and conflicting modes. A toolbar action for cycling through models involved, that is show all, show resources, show Java, etc. Refresh and schedules refresh actions. Action to open elements in a compare editor. Change navigation actions. Standard merge actions, merge, overwrite, and mark as merged, for which models can register handlers and team providers can provide appropriate labels. For example, update for CVS. Here's a checklist of steps for tailoring a model synchronized participant for a particular team provider. Define a participant using org.eclipse.theme.ui.synchronize participant extension point. This will require a team provider to create a subclass of model synchronize participant. Define a viewer for a participant using org.eclipse.ui.navigator.viewer extension point. Viewer definition is used to specify what menu groups appear in the context menu. Override override initialize configuration method in the participant in order to set the isynchronize page configuration dot p underscore viewer underscore id to the id of the viewer specified in the previous step. Override the create merge action group to provide custom subclass of merge action group in order to tailor the appearance of the merge related actions. If a participant is persistable, override the create scope manager and restore context methods to recreate the scope manager and merge context for participant when it is restored on startup. Implement a subclass of model participant merge operation for handling the transition from the model based merge to preview a dialog or synchronized view. The following XML snippet illustrates how the CVS participant class is registered and how the viewer is defined. Now we are considering adapting a model to resource mapping. In resource mapping in model roadmap for logical model integration, adapting a model to resource mapping. The following following is the XML markup for contributing an adapter factory in a plugin manifest. Plugins that adapted their model objects to iResource in order to get the specific actions shown in the context menu can now adapt to resource mapping. If a richer description of how the objects adapts to a resource is beneficial. However, they are not required to do so if there is no benefit. For instance, Java compilation unit, that is *.java file shown in the JDT view that now currently adapt to iFile need not adapt to resource mapping since nothing is gained. However, a Java package should adapt to resource mapping in order to indicate that the package consists of only one file, only the files in the corresponding folder and not subfolders. The preferred way to adapt model elements to a resource mapping is to use an adapter factory. The following XML markup is contributing an adapter factory in a plugin manifest. The adapter factory implementation would look something like this. Here you can see iAdapter factory interface. Now we are considering adding team actions in rich team integration. Let's look at the CVS action that demonstrate some interesting points. Identify a org.eclipse.ui.popup menus warning, this extension points is deprecated. Do not use this extension point. It will be removed in future versions of this product. Instead use the extension point of org.eclipse.ui.commands. This extension point is used to add new actions to the context menus owned by other plugins. Action contributions may be made against a specific object type, object contribution, or against a specific context menu of a view or editor part viewer contribution. When using object contribution, the contribution will appear in all view or editor part of the context menus where objects of the specified type are selected. In contrast, you are using viewer contribution. The contribution will only appear in the specified context menu of a view or editor, regardless of the selection. The Team UI plugin defines a pop-up menu extension in order to consolidate all team related actions in one place. Team menu includes many subgroup slots so that team provider plugins can contribute actions and have some amount of control over the order of items in the menu. A team menu is added to the pop-up menu of all views that shows resources or object that add up resources. In this example, your plugin can use the ID of a menu and use the separator groups in order to add your own menu items separately. If you add a menu here, there are nothing under here. There are nothing to keep you from defining your own pop-up menus, action sets, or view and edit actions. However, adding your actions to predefined team menu makes it easier for the end user to find your actions. Let's look at CVS action that demonstrates some interesting points. Note that action is contributed using org.eclipse.ui.popup menus, Workbench extension point. Here are some team specific things happening in the markup. Action is filtered by a project persistent property which identifies team providers. The value of the team property must be of the format org.eclipse.team.co.repository equal your repository ID, where your repository ID is the ID provided in the org.eclipse.team.co.repository markup. This filter ensures that the CVS pop-up menu items only appear for files that appeared in the projects that have been mapped to CVS repository ID. The action is added in the group. Action is added to a group in the menu that was specified in the Team UI plugin. Implementation of an action is largely dependent on your specific provider. Now we are considering development team responsibilities in team responsibilities and collaboration in data tools platform help documentation. Development teams are primarily responsible to this. Development team should provide list of the help key constant in the form of Java source files for the help key constant interface classes. Development teams are primarily responsible to implement the Eclipse classes and method necessary to enable dynamic context sensitive help for all appropriate UI controls. Implement the interfaces classes that declare help key constants for each UI plugin. Provide list of the help key constant to documentation teams in a timely manner. Test the context sensitive help UI implementation with context sensitive help UI plugins and online documentation plugins provided by documentation teams. Java source files provided as help key list must include the help context commands to provide information about each associated UI control. Now we are considering documentation team responsibilities. It's primarily responsible to here. A documentation team has several responsibilities when delivering context sensitive help content. It's primarily responsible to develop context specific help content and context specific help search expression for appropriate UI help context. Define the concrete help context ID strings that associate abstract help context with context specific help content. Create the Java properties files that define the mapping of abstract help context to concrete help context IDs. Create the context sensitive help UI plugins that contribute Eclipse context XML files and Java properties files. Test the context sensitive help UI plugins and online documentation plugins with UI components provided by the development teams. Documentation team should rely on the Java source files for the help key constant interface classes as original and definitive sources of all help key constant strings. Creating Java property files can be somewhat automated, that is by processing the Java source files with a simple Perl script. Most of the other artifacts required for context sensitive help UI plugin can be generalized by XSL transformations of data XML map document. Now we are considering method 1 in synchronization with repository in working with team environment. To synchronize resources in the workbench with those in the repository. In one of the navigation views, select the resources that you want to synchronize. Right click and select team, then synchronize with repository. The synchronize view opens. Method 2 here. From the team synchronizing perspective, select synchronize action, then the synchronize action from the synchronize button drop down. Select your VSC type from the list of possible synchronization type and click next. Note, if there are no other repository providers registered with the workbench, then you will bypass this section altogether. 3. Select the resource scope of further synchronize by either selecting workspace. Select resources, so working set, then select finished. 4. The synchronize view will open. Note, the synchronize action is enabled by default by the synchronize action is not enabled by default in other perspectives. You can enable the action to appear in your current perspective by selecting window, then perspective, then custom perspective, then click on the commands tab and check off team. Note, it is possible that someone has committed a new version of your file since you started work on it. This will result a conflict, and care must be taken to resolve this. For this reason, conflicts are shown in all modes of the synchronized view. Important, it is preferable to update resources in Workbench first, resolve any conflict that exists by merging, then commit Workbench resources to the repository. Now we are considering setting the content type of file extension. To set the content type associated with the file extension, you can follow these steps. Team repositories distinguished between files and that contain ASCII data and those that do not. For ASCII files, additional helpful functionality is available. This includes proper end-of-line conversion between the client and the server. This ensures that Windows user and a Unix user can work on the same file without introducing incompatibilities. Auto merging of conflict. If a file contains both incoming and outgoing changes, but none of the same line as another, then the file may be automatically merged when updating. Certain file types invariably contain either ASCII data or binary data. For example, *.txt files usually contain ASCII data, and *.exe files usually contain binary data. Eclipse comes with a predefined set of file types which you may add to or modify. A set of context type associated with the file extension. To set the content type associated with the file extension, step 1, open the command link, team, then file content preference page. This page displays a list of file extensions and content type, ASCII or binary for file extension whose content type is known. Step 2, add the file extension. Click the add extension button and enter the file extension in the text prompt that appears. Click OK. Once OK is clicked, the extension will be added to the list with a content type of ASCII. Step 3, to change the content type for an existing file extension, select file extension entry and click the change button. This will toggle the type from ASCII to binary or vice versa. Step 4, to remove a file extension, select the file extension entry and click the remove button. Now we are considering comparing resources with repository versions. To compare Workbench resources with those in the repository, step 1, select the resource, select a resource in one of the navigation views. From the resource pop-up menu, select one of the following menu items. Compare with, then latest from branch name or version. Compare the Workbench resources with the latest resource currently committed to the branch that the local project is shared with, or if the local project is checked out as a version, then compare against the version. A compare editor will be opened. This editor will display a tree of all resource differences between the Workspace resource and the latest resource in the repository. Compare with, then another branch or version. Compare the Workbench resource with the specific version or branch that select in the repository. A compare editor will be opened. The editor will display a tree of all resource differences between the Workspace resource and the resources in the specified version or branch. Compare with, then history, available only on a file. Compare the Workbench file with another version of the file. Based on your preference settings, either the history view or a dialog will be open. The history view or dialog will contain a table of all available revisions of a selected file. Selecting one of the revisions will show the differences between Workspace revision and the selected revision. Tip: when comparing with the branch or version, you can specify a particular date instead of version of or a branch tag. This can be done by right-clicking the dates category in the tag selection list and choosing add date. A date tag dialog is displayed that allows you to specify a date and optionally a time. After you click OK, the date tag will appear in the tag selection list. Now we are considering to create a patch from a project here in working with patches. Step 1, select the resource that contains the modifications to be included in the patch. You can select resources that reside in the multiple project and at any level, as the create patch wizard, when run in its default mode, knows how to create a multi project patch. The patch should also be applied to the same file revisions that it is generated on. So steps should be taken to ensure that the patch is applied to the same resource lineup. The easiest way to do this is to create a patch on top of a version. Step 2, from the pop-up menu, select team, then create patch. The create patch wizard will be open. Step 3, choose where the patch should be saved. Save to clipboard. This will place the patch on the clipboard so it can be pasted into the text editor, such as an email program. To save to file system, this will place the patch in the specified file in a local file system. Save in Workspace. This will place the patch in the specified file inside one of the existing Workbench projects. For small patches, it may be reasonable to transfer the patch using the clipboard, but in most cases, the local file system is the best option to use. Step 4, you can preview and fine-tune your patch selection by expanding the resource tree represented in the change pane. Only those elements which are checked will be included in the patch. Click next to configure the how patch is generated. Step 5, choose how to configure the patch. Diff output format allows your choice of several command diff output formats. Unified is the format used by many patch application tools, including Eclipse. The format used in context and unified diffs allows to apply a patch even though line number mentioned in the hunk patch terminology is incorrect. In this case, when applying the patch, the algorithm scans both forward and backward for the set of lines matching the context given for the hunk. Patch root allows you to specify at what level your patch is rooted at. The choices are Workspace, Project, and Selection. Workspace allows you to include resources from the multiple projects in your patch and is the default option. Workspace patches can be applied to any resource in the workspace. They contain enough information to allow the apply patch wizard to configure out which resources need to be patched. Project patches are rooted at the project level, which means that they can only contain resources from one project and must be applied to the same project. Selection patches are rooted at whatever the selected resource is and must be applied to the same resource. Step 6, click finish. Step 7, transfer the patch as appropriate for the project being patched. Example, we can consider this. This is occurred under JFace Anywhere plugin on starting Eclipse, connecting an internal error occurred during connecting to Team Foundation server, and an internal error occurred during connecting to Team Foundation server com/Microsoft/TFS/client/Eclipse/project/project repository manager $project repository data. Now we are focusing on platform runtime. A plugin is the smallest unit in Eclipse platform function that can be developed and delivered separately. Usually a small tool is written as a single plugin, whereas a complex tool has its functionality split across several plugins. Except for a small kernel known as platform runtime, all of the Eclipse platform functionality is located in plugins. Here you can see how data is organized in SQL storage architecture. From the logical perspective, SQL storage represents a hybrid of OSGI's preference and a keyring. The front end is modeled in a fashion very similar to OSGI preference service specification. SQL storage is represented as a tree of nodes. Nodes provide context. For instance, bundle com.abc could use the node abc under the node com under the root node. As in preferences, the path to such node can be described as /com/abc. The data is stored under the node as key value pair. The data can be stored in encrypted form or as a clear text. The ability to store clear text data is provided so that logically related to the information such as non-encrypted username and password can be stored using the same mechanism. The code to store password associated with com.abc would look like this, and then to retrieve data, if the SQL storage is modified, it will be saved when the application is closed. Alternatively, a save can be triggered programmatically by calling iSQL preferences #flush method. Encrypt here. Default. Here root is connected to com and CVS here. Com is connected to ABC. Here you can see login, Excalibur and password here. Root is connected to CVS and CV is connected to account 1. Here logging John and password here. So here preference node CVS /CVS account get password here. Now we are considering relationship entries and password providers in SQL storage architecture. You can see the diagram here. On the back end, SQL storage can be thought of as a keyring. Each entry is associated with the password provider. Only this password provider can be used in future to decrypt the entry. SQL storage has providers to obtain the master password from the various sources described in the password providers. Even more importantly, for developers, the set of password providers is open and easily customizable. Here you can see a SQL storage here. Entry 1 Excalibur, entry and entry 2 password is connected to password provider 1 here. Master password one is inside my password provider 1 here. Entity 3 John and entity 4 1 2 3 4 5 6 7 8 are connected to password provider 2. Master password 2 is inside password provider 2. Here you can see lifecycle methods in plugins. If the plugin.xml of a plugin indicate Eclipse version equal 3.0, its prerequest list include org.eclipse.core.runtime. The default construct of the plugin class is used, and start bundle context and stop bundle context are called as lifecycle method. Since Eclipse 3.0 APIs of the plugin class can be called only when the plugin is in an active state, that is after it was started up and before it is shut down. In particular, it means that plugin API should not be called from the overrides of plugin. Here the public void start bundle context method start up this plugin. Here public void stop bundle context stop this plugin. The start portion of the life cycle is worth particular discussion. We have been already we have seen already that the information about plugins can be obtained from plugins manifest file without ever running any of the plugins code. Typically, some user actions in the Workbench causes a chain of event that requires starting of a plugin. From an implementation point of view, a plugin is never started until a class contained in a plugin needs to be loaded. The start method has been convenient place to implement initialization and registration behavior for a plugin. However, it is important to realize that your plugin can be started in many different circumstances. Something as simple as obtaining an icon to decorate an object can cause one of your plugin's classes to be loaded, thus starting your plugin. Over eager initialization can cause your plugin code and data to be loaded long before it is necessary. Therefore, it's important to look closely at your plugin's initialization task and consider alternatives to performing initialization at the startup. Registration activities such as registration listeners or starting background threads are appropriate during plugin startup if they can be performed quickly. However, it's advisable to trigger these actions as part of accessing the plugin's data if the registration activities have side effects such as initialization large data structures or performing unrelated operations. Initialization of data is best done lazily when the data is first accessed rather than automatically in the startup code. This ensures that large data structures are not built until they are truly necessary. For example, we can consider platform class. The central class of the Eclipse platform runtime. This class cannot be instantiated or subclassed by clients. All functionality is provided by statics methods. Features include the platform registry of installed plugins, the platform adapter manager, the platform log, the authorization info management, this class is in the package org.eclipse.core.runtime. As an exception example, we can consider core exception. If there are problems setting the authorization information. Reasons include the keyring could not be saved. This exception can occur in method public static void add authorization info URL serve URL string realm string auth scheme map info in class platform. Here you can see clone the platform UI repository. To clone, select file, then import, then git, then project from git, then clone URI. Enter the URI from the Gerrit web page. Here in the first line of the wizard, the Eclipse git tooling removes the git clone from the cloned URI automatically. And note that the URI automatically include your username. This make it easier to push the changes to the Eclipse Gerrit review system. If you clone the repository using the Eclipse git functionality, your local repository is already configured to push the changes to Gerrit. No additional setup step is required. This screenshot shows the selection. Please the depicted username with yours. On the next wizard page, you can select the clone all branches. The Eclipse platform project, the project uses the master branch for all bug fixes and feature works. Individual bug fixes are downported to maintainers branches, but you should always first fix the issue in the master branch. Finish this wizard by selecting next button until the option finish option becomes available. You end up with the projects from the repository imported into a workspace. You can also clone anonymously via anonymous HTTP, but if you just want to play with the source code locally and do not intend to contribute changes, in case you clone the git repository without using the Gerrit URL or not via Eclipse git, you have to adjust your push URL to provide Gerrit change. Now we are considering package org.eclipse.co.runtime provides support for the runtime platform, core utility methods, and the extension registry. Now we are considering identifier org.eclipse.co.runtime.applications.platform applications. Platform runtime supports the plugins which would like to declare main entry points, that is programs which would like to run using the platform runtime but yet control all aspects of the execution can declare themselves as an application. Declared applications can be run directly from the main platform launcher by specifying the dash application argument, where the parameter is the ID of the extension supplied to the application's extension point described here. This application is instantiated and run by the platform. Platform clients can also use the platform to look up and run the multiple applications. Now we are considering plugins and bundles in the runtime plugin model. The plugin class represent a plugin that is running in the platform. Class plugin, the abstract superclass of all plugins runtime class implementations. A plugin subclass is subclasses this class and overrides the appropriate lifecycle methods in order to react to the lifecycle request automatically issued by the platform. For compatibility reasons, the method call for those lifecycle events vary, please see the constructors and lifecycle methods section in the documentation. The package, this is in the package org.eclipse.co.runtime. The plugin class represents a plugin that is running in the platform. It is a convenient place to centralize the lifecycle aspects and overall semantics of the plugin. A plugin can implement specialized functionality for the start and stop aspect of its lifecycle. Each lifecycle methods include reference to a bundle context which can supply additional information. The start portion of the now we are considering runtime components. For example, to import only the content of the package provided by the org.eclipse.equinox.common bundle, use this line in the manifest file. The runtime components, the Eclipse runtime itself is factored into several bundles. org.eclipse.co.runtime, content type mechanism, org.eclipse.co.jobs, concurrency infrastructure, org.eclipse.co.net, network and proxy management infrastructure, org.eclipse.equinox.app, application model, org.eclipse.equinox.common, common basic functionality, org.eclipse.equinox.preferences, runtime preferences, org.eclipse.equinox.registry, extension registry, org.eclipse.equinox.security, security infrastructure, org.eclipse.co.runtime, aggregate the Eclipse runtime bundles into single capability that can be depended on. If your plugin has dependency on the org.eclipse.co.runtime bundle, then it will continue to run unchanged. However, if you would like to minimize the number of dependencies, then you are able to pick only runtime bundles that you use. Dependencies on runtime bundles may be declared using either import package or require bundle. If you would like to use import package header rather than require bundle, then you should be aware that the org.eclipse.co.runtime package is split across several bundles. The bundles that export a portion of split package org.eclipse.co.runtime use a mandatory directive. The mandatory directive requires importers to specify additional matching attribute in order to successfully wire to the exported package. For example, in import only content of the package provided by org.eclipse.equinox.common, use this line in the manifest file. To import content of package from org.eclipse.equinox.registry, here common and here registry, and org.eclipse.equinox.common bundles use this. Above examples use mandatory matching attributes common and registry respectively. This allows the bundle to get resolved its desired part of the split package. To import complete package, then do not use any matching attributes. This will resolve to complete package as exported by the org.eclipse.co.runtime aggregate bundle. Here you can see lifecycle methods in plugins. If the plugin.xml of a plugin indicate Eclipse version equal 3.0, its prerequest list include org.eclipse.co.runtime. The default constructor of the plugin class is used, and start bundle context and stop bundle context are called as lifecycle method. Since Eclipse 3.0 APIs of the plugin class can be called only when the plugin is in an active state, that is after it was started up and before it is shut down. In particular, it means that plugin API should not be called from the overrides of plugin. Here the public void start bundle context method start up this plugin. Here public void stop bundle context stop this plugin. The start portion of the life cycle is worth particular discussion. We have been already we have seen already that the information about plugins can be obtained from plugins manifest file without ever running any of the plugins code. Typically, some user actions in the Workbench causes a chain of event that requires starting of a plugin. From an implementation point of view, a plugin is never started until a class contained in a plugin needs to be loaded. The start method has been convenient place to implement initialization and registration behavior for a plugin. However, it is important to realize that your plugin can be started in many different circumstances. Something as simple as obtaining an icon to decorate an object can cause one of your plugin's classes to be loaded, thus starting your plugin. Over eager initialization can cause your plugin code and data to be loaded long before it is necessary. Therefore, it's important to look closely at your plugin's initialization task and consider alternatives to performing initialization at the startup. Registration activities such as registration listeners or starting background threads are appropriate during plugin startup if they can be performed quickly. However, it's advisable to trigger these actions as part of accessing the plugin's data if the registration activities have side effects such as initialization large data structures or performing unrelated operations. Initialization of data is best done lazily when the data is first accessed rather than automatically in the startup code. This ensures that large data structures are not built until they are truly necessary. Now we are considering preference scope in runtime preferences. Preferences are accessed using iPreference service protocol. The platform default preference service can be accessed using the platform class. The interface iPreference service, the preference service provides facilities for dealing with the default scope preference lookup order, querying the preference store for values using this order, accessing the root of the preference store node hierarchy, and exporting preferences. This is in the package org.eclipse.core.runtime.preferences. The scope of the preference is closely related to where the preference is stored. The plugin developers can decide which of the standard scopes apply for their preferences, so it can define new scopes that make sense of their plugin. Let's look at the scopes defined by the platform runtime. Instance scope preferences are stored per workspace as or per running instance of a platform. Configuration scope preferences are stored per installation of the platform. They are stored between workspaces. For example, if a user has a single installation of a platform that runs several different workspaces, preference scope at the configuration level will be shared between the workspaces. The default scope preferences represent the default values for preferences. These are not changed or stored in the platform. However, the values originate from the file stored with the plugin's product or primary feature. You can think of overall preference store as a hierarchy of nodes where each main branch of the hierarchy represents a particular scope. The children of any particular node depend upon how that scope is defined. For instance, the configuration scopes for the instance and configuration scopes, the child nodes are the preferences for a particular plugin as specified by a preference qualifier, usually the plugin's ID. If all of the sounds confusing, don't worry. If you don't care about the scopes and nodes, you need not worry about any particular scope or about which node of the tree actually contains your preference value. The preferences API will automatically traverse the nodes in the particular order, instance, configuration, default. When you query a preference value and use the supplied qualifier and preference name to find the node that actually contains the value, preferences are accessed using iPreference service protocol. The platform default preference service can be accessed using platform. Once the preference service is obtained, the preference values can be queried by using the any of the get methods provided in iPreference service. For example, the following snippet queries the value of the my preference in the plugin com.example.my plugin. Last parameter in the query method is an array of scope context to use when searching for the preference node. If the array is null, then the platform assumes that the default scope search order should be used and guesses the appropriate preferences node. If an array scope's contexts are passed, then this determines the scope lookup order that should be used to find the preference node. The default scope lookup order is always consulted if no node can be found using the specified scopes. Do something with the value. Now we are considering runtime application, the default application in runtime application model. The default application can be specified by one of the following configuration options. A given Eclipse configuration may contain many products and applications. An Eclipse configuration specifies a default application which is launched by the application container as soon as the platform runtime is up and running. The default application can be specified by one of the following configuration options. Eclipse.product identify the product to launch the platform runtime with a product supplies branding information, window icons, title bar text, etc., as well as defining the default application to run. Eclipse.application identify the application to launch the platform runtime with this option. This option overrides the default application defined by the product. Now we are considering finding out about content types in using content types in content types. To obtain a reference to the platform iContent type manager, clients can use the platform API. The interface iContent type manager. The content type manager provides facilities for file name and content based type lookup and content description. This is in the package org.eclipse.co.runtime.content. Content types are represented by the iContent type. This interface represents unique content type that knows how to read a data stream and interpret content type specific information. Content types are hierarchical in nature. For example, a content type for XML data is considered a child of the text content type. This allows new content types to leverage the attributes or behavior of more general content types. The iContent type manager is the entry point for that gives the access to most of the content types related API provided by the platform runtime. To obtain the preference to the platform iContent manager, client can use the platform API. Clients can use the platform iContent type manager to find out about content types in the system. Get all content types allows client to get all of the content types defined in the platform. Get content type allows client to obtain content type by its unique identifier. Now we are focusing on reporting progress in concurrence infrastructure. The following run method reports progress and respond to job cancellation. The interface iProgress monitor. The iProgress monitor interface is implemented by objects that monitor the progress of an activity. The methods in this interface are invoked by code that performs the activity. This is in the package org.eclipse.co.runtime. The long-running jobs, those lasting for more than a second, should report progress to the iProgress monitor that is passed to the jobs run method. The Workbench progress view will show all progress messages and units of completed work given to the monitor. The supplied progress monitor should also be used to check cancellation requests made from the progress view. When a user or plugin using job API attempt to cancel a job, the iProgress monitor method is cancelled will return true. It is the job's responsibility to frequently check the cancellation status of a job. And response to a cancellation by exiting the run method as soon as possible once it detects the cancellation. The following run method reports the progress of and respond to job cancellation. The begin task method is used to name the task in the corresponding progress view to establish the total amount of work to be done so that the view can compute progress. The subtask messages will appear as a child in the progress tree as work is done. The progress view will calculate and display the percent completion percent completion based on the amount of work reported in the worked calls. Do some work. Now we are considering network support. The networking support provided as part of the platform includes this proxy support provided by the org.eclipse.co.net.proxy package of the org.eclipse.co.net plugin. SSH2 support provided by the com.jcraft.jsch plugin. Client should make use of the API in the org.eclipse.jsh.co.package to ensure that the settings specified in the preference page are respected. Now we are considering central classes and interfaces in developing with secure storage in security. Central classes and interface, the org.eclipse.equinox.security.storage package contains several classes and interfaces that are likely going to serve as a starting point. The package org.eclipse.equinox.security.storage. This package provides an infrastructure and help utilities for Equinox secure storage. The functionality of secure storage is exposed via APIs of the org.eclipse.equinox.security bundle. The org.eclipse.equinox.security.storage package contains several classes and interfaces that are likely going to serve as starting point. Now we are considering starting a command line session in console shell. Now this minimal Equinox configuration can be started by the console available on the command line by passing dash console option, for example here. The minimal bundles set needed to start Equinox with the console on the command line is as follows: org.apache.felix.go command _version.jar, org.apache.felix.go.runtime _version.jar, org.apache.felix.go.shell _version.jar, org.apache.equinox console underscore version .jar org.eclipse osgi underscore version .jar. All these bundles are available in Equinox SDK zip file available from the Equinox download site. Extract these bundles into a directory. Then inside that directory create a configuration /config ini file with the following content here. Here you can see gogo.command and gogo.runtime, gogo.shell, equinox.console I described earlier. Now the minimal Equinox configuration can be started with the console available on the command line by passing -console option, for example here. Now we are considering LRM addition is structured text with LTR based text direction in design overview in structured text. Example strings in logical order where at represent where an LRM should be added. A LRM will be added before taking before a token if the following conditions are satisfied. The last string character before the token has BD type equal to R or AL, and the first non-neutral character in the token itself has a BD type equal to R, AL, EN or AN. Examples of string in logical order where at represent where the LRM should be added, or the last non-neutral character before the token has the BD type equal to AN and the first non-neutral character in the token has a BD type equal to R, AL or AN. Example strings in logical order where at represent where LRM should be added here. Example, we can consider this one: error log view missing by default on Eclipse platform runtime. This occurred in version 4.10 and under hardware PC Windows 10. Now we are focusing on a new tool. The platform also provides useful building blocks and frameworks that facilitate developing new tools. Now we are considering launching a program in program debug and launch support. The platform debug plugins allows your plugins to extend the platform so that your particular type of program can be launched from the Workbench, obtaining input from the user if necessary. A unique type of program can be launched in the platform is called launch configuration type. The class iLaunchConfiguration is used to describe a type of configuration. A launch configuration keeps a set of named attribute that can be used to store data specific for a particular kind of launcher. For each configuration type, there are different modes in which the configuration can be launched. The platform defines modes for running, debugging, or profiling program defined by a particular configuration. Plugins are free to implement any of all these launch modes for a particular launch configuration or define new launch modes for any launch configuration. Plugins that contribute additional types of launchers do so by providing iLaunch configuration delegate or iLaunch configuration delegate 2 that knows how to launch program given in the expected type and mode for launch configuration. Once the program is launched, an iLaunch object is used to represent the launch session. This object can be queried for information such as running processes, debug session information, and store code location. Or launch knows the configuration that was used to create it. Users interact with the launch configuration dialog to set up the parameters for different types of launchers. This configuration can be stored in a file to be shared with other users or stored locally in the workspace. Here the interface iLaunch configuration. A launch configuration describes how to launch an application. Each launch configuration is an instance of a type iLaunch configuration as described by the launch configuration type extension. Each launch configuration has a launch configuration delegate which performs actual launching of a configuration. Now this interface iLaunch configuration delegate a launch configuration delegate perform launching a specific type of launch configuration. A launch configuration delegate is defined by the delegate attributes of a launch configuration type extension. iLaunch configuration delegate 2 optional enhancement to launch configuration delegate interface, which allows launch delegates to abort a launch, build relevant projects in a workspace before launch, and create a launch object to be used in a launch. Interface iLaunch. A launch is a result of launching a debug session and or one or more system processes. Here you can see file or workspace data. And here you can see iLaunch configuration, name, location, attribute name value, and iLaunch configuration interacts with iLaunch iLaunch configuration. Launch iLaunch configuration is connected to iLaunch configuration delegate. iLaunch configuration delegate is connected to iLaunch processes, debug target, source locator. iLaunch is connected to iLaunch configuration. Sample we can consider this. This is in plugin.xml. Plugin.xml defined extensions that this plugin provides extension points are how Eclipse advertises the plugin extensions. Much like USB Hub provides a generic connector that allows many other types of devices to be plugged in. The Eclipse extension points are documented in the help system, and each has a point identifier with optional children that are point specific. In this case, the extension is defined using the org.eclipse.ui.views point, which expect a combination of category and view elements. So this will look like this here. The class in this case extends the viewPart abstract class, which is used for all views in Eclipse 3.x. The Eclipse 4 model defines views in a different way. And Eclipse 4.x SDK include 3.x compatibility layer. So these example will work in Eclipse for Eclipse 4.x SDKs. Here we can consider drawing a custom view. For the extension in plugins. An SWT canvas can be used to provide custom rendering for a view. As a starting point for drawing the clock, the canvas will use draw arc to create a circle. And step 1, remove the content of clock view, leaving behind an empty implementation of the set focus, and create part control methods. Then step 2, run the target Eclipse instance and see that clock view is now empty. Step 3, in the create partition control method, do the following. Step 1, create new canvas. Step 2, add paint listener to canvas. And step 3, get GC from paint event. And call draw arc to draw a circle. So code will look like this. And run the Eclipse instance and show the clock view. Then resize the view, and clock should change size with it. Here we can, as an example too, here we consider how to open plugins in Eclipse. Plugins for the open source IDE Eclipse let you use pre-built function in your own development projects. You can download plugins from the internet or create your own for later use. To open plugins in your Eclipse project, you import them into the project from their location on your hard drive or an Eclipse platform. Here step 1, click the file menu, select import. Step 2, click plugin development and plugins. Step 3, click the radio button under import from and choose which option you want, the current platform, a different platform, or your hard drive. Step 5, click the plugins you want to open to select them. Step 4, step 5, select an option under import as and determine what from the plugin should have. Click OK. As an error example, we can consider this plugin load error, java.lang.nullPoint exception. This is end of my presentation. Now we are considering platform architecture, platform SDK roadmap in platform plugin developer. Java Development Tools JDT. The Java Development Tools JDT plugins extend the platform Workbench by providing specialized features as for editing, viewing, compiling, debugging, and running Java code. JDT is installed as a set of plugins that are included in SDK. The Java development user guide describes how to use the Java tools. The JDT plugin developer guide describes the structure and API of the DDT if you refer the documentations. Now we are considering a minimal plugin in a simple plugin example. We all know that Hello World looks like in a plain old Java without using any user interface frameworks or other specialized library. What happens to this old standard in the context of Eclipse platform? Instead of thinking Hello World as a self-contained program, we can recast it as an extension of the platform. Since we want to say Hello World to the world, we need to configure out how to extend the Workbench to include our greeting. When we get deeper into the platform in user interface component, we will do an extensive review of the ways we can extend and customize your Workbench UI. For now, let's start with one of the simplest Workbench extension, a view. We can think of a Workbench window as a frame that represents various visual parts. These parts fall into major categories: views and editors. We look at editors later. Views provide information about some object that user is working with the Workbench. Views often change their content as the user select the different objects in the Workbench. Here you can see a Hello World view. Now we have after creating the project package and a view class for our plugin, we are ready to study some code here. Here's everything you need to your Hello World view. Copy the contents below into the class you created, replacing the auto-generated content. The view part creates the widgets that will represent the in the create part control method. In this example, we create an SWT label and set the Hello World text into it. This is about simplest view that can be created. Set the focus to my widget. For label, this doesn't make much sense, but for the more complex sets of widgets, you would decide which one gets the focus. Now we are considering extension points and the registry in runtime plugin model and runtime overview. The following code is a simplified snippet based on the Workbench implementation of the show view dialog. The interface I extension registry. The extension registry holds the master list of all discovered namespaces, extension points, and extensions. The interface I extension point, an extension point declared in the plugin, except for the list of extensions plugged into it. The information available for extension point is obtained from the declaring plugins manifest plugin.xml file. These are in the package org.eclipse.core.runtime. While the bundle aspects of a plugin may be interesting to the runtime plugin and runtime tools, it is much more common that the plugin is concerned with what extension point have been defined in the plugins and what extensions are contributed by the plugins. This information is provided by the plugin extension registry, I extension registry. Why might a plugin want to know what extensions are present? A concrete example will help show the need for this information and protocol for getting it. Recall the Workbench show view dialog, which all the available views that have been installed in the platform. We know that the category names and the view names all contributed views are specified in the plugin.xml file for a plugin for any plugin that contributes an extension for org.eclipse.ui.views. But how does the Workbench find out this information from the platform extension registry? The following code is a simplified snippet based on the Workbench implementation of show view dialog. We see above that the registry can be obtained from the platform class. The protocol I extension registry is used to find extension point named org.eclipse.ui.views. Information in the registry about particular extension points or extensions can be found in the protocol defined in I extension registry. I extension point and I extension. Javadoc for these classes provides details information about registry protocol. Once the extension definition of interest has been found, the protocol I configuration element can be used to examine the individual attributes of an extension. Get the information about each extension. Now we are considering org.eclipse.ui.views in basic Workbench extension point using commands in plugin into the Workbench. Identify org.eclipse.ui.views. This extension point is used to define additional views for the Workbench. A view is usual component within a Workbench page. This is typically used to navigate hierarchy of information like the Workspace, open an editor, or display properties for active editor. The user can make a view visible from the window, then show view menu, or close it from the view local title bar. A view is a Workbench part that can navigate a hierarchy of information or display properties for an object. Only one instance of any given view is open in a Workbench page. When a user makes selections or other changes in a view, these changes are immediately reflected in the Workbench. Views can often provide a support for corresponding editor. For example, an outline view shows structured view of the information in an editor. A properties view shows the properties of an object that is currently being edited. An extension point org.eclipse.ui.views allows plugins to add views to the Workbench. Plugins that contribute a view must register the view in their plugin.xml file and provide configuration information about the view, such as implementation class, category or group. Category or group of views to which it belongs, and the name and the icon that should be used to describe the view in menus and labels. The interface for views defined in view part, but plugins can choose to extend view part class rather than implement an view part for Scratch. We implement a minimal view extension in the Hello World example. Now we will look at the ones that aware of the other Workbench views, respond to user navigation and selection changes in the Workbench. First, let's look at the declaration of an extension in plugin XML. This would look pretty familiar, and we see that a new window info view is contributed to the Workbench. View ID, name and category are specified as we've seen before. Let's look at the view info. You can show any view in the Workbench by choosing window, then show view, then other, selecting the view from the show view list. When we show the info view, the view with the list of listed pop-ups, the list is pre-populated with some data. We will start with get familiar with create part control method. As we saw in the Hello World example, this is where the widgets that represent a view are created. We will ignore some of the code that get started. View creates and stores a list viewer. And sets the content and label providers. It also registers itself with the selection provider label provider, and contributor content provider come from JFace viewers. It obtains the service from its iView site. Which contains information about the view context, such as Workbench window, its containing page, its local services, and its plugin. We have covered a lot of common Workbench concept by studying this extension here now. Service will be providing our input. Register myself as selection provider for this view. Now we are considering standard dialogues in wizards and dialogues and wizard. The standard dialogues are designed to are designed so that you can completely specify the dialog in its constructor. We show a message dialog in action in the readme tools view action. The class message dialog, a dialog for showing messages to the user. This is in the package org.eclipse.jface.dialogs. The package org.eclipse.jface.dialogs defines a basic support for dialogs. This package provides standard dialogs for displaying user messages and obtaining simple input from the user. Message dialog displays the message to the user. You can set the dialog title, image, button text, and messages in the constructor for this dialog. You can set the message. Yep. Error dialog displays the information about an error. You can set the dialog title and the message for the dialog. You can also supply IS status object which the dialog will use to obtain an error message. Input dialog allows the user to enter text, and you can set the dialog title, default text value, and the supply an object that will validate the text input. Progress monitor dialog shows the progress to the user during the running of the long operation. The standard dialogs are designed so that you can completely specify the dialog in its constructor. We saw message dialog in action in the readme tools view section. Here you can see the dialog, open information, and etc. Now we are considering viewers in JFace UI framework. We first show the viewer in its readme tools view contribution inside the readme section view. Class list viewer, a concrete viewer based on an SWT list control. This is in the package org.eclipse.jface.viewers. Why would you ever want to use a viewer when we already seen that the Workbench UI contributions like views, editors, wizard, and dialogs can be implemented directly with SWT widgets? Viewers allow you to create widgets while still using your model object. If you use an SWT widget directly, you have to convert your objects into strings and images expected by SWT. Viewers act as an adapter for on SWT widgets, handling the common code for handling widget events that you would otherwise have to implement yourself. We first show the viewer in the readme tools view contribution inside the readme section view. Here we can see that. Note, viewers can be used to provide implementation for both Workbench views and editors. The term viewer does not imply that they are only useful for implementing views. For example, text viewer is used in the implementation in many of the Workbench plugin editors. Now we are considering widget application structure in widgets in standard widget toolkits. Since the application only displays the string hello world, it does not need to register any widget events. The class label instances of this class represent a non-selectable user interface object that displays a string or image. When separator is specified, displays a single vertical or horizontal line. This is in the package org.eclipse.swt.widgets. When you are contributing UI element using platform Workbench extensions, the mechanics of starting up SWT are handled for you by the Workbench. If you are writing an SWT application from scratch outside of the Workbench, you must understand more about SWT's application structure. A typical standalone SWT application has the following structure. Create a display which represent SWT session. Create one or more shells which serve as the main windows for the application. Create any other widgets that are needed inside the shell. Initialize the sizes and other necessary states for the widgets. register listeners for widgets events that need to be handled. Open the shell window. Run the event dispatching loop until the exit condition occurs, which is typically when the main shell window is closed by the user. Dispose the display. The following code snippet is adapted from the org.eclipse.swt.examples.helloworld.helloworld2 application. Since the application only displays the string hello world, it does not need to register for any widget events. Now we are considering form control in UI in controls in UI forms. For example, consider the following code snippet. The class form form is a custom control that renders a title and optional background image above the body composite. It can be used alone when a part of parents that are scrolled. Scrolling is required. If scrolling is required, use scrolled form instead, because it has an instance of form and adds a scrolling capability. This is the form is in the package org.eclipse.ui.forms.widgets. Form is a basic control used to host UI forms. It provides settings for a title and scrolling the content similar to the web browser. What makes the forms appealing is the fact that the content is an SWT composite that can be used as you would use it in the other context. For example, consider the following code snippet. UI forms manipulate SWT widgets in number of ways in order to achieve the desired effect. For that reason, controls are typically created using form toolkit. Normally, an instance of scrolled form is created in order to get the scrolling. When forms need to be nested, form instance provide everything except for scrolling of the form content. Form get body form content is rendered below the title. SWT widgets are created in the form using form.getBody as a parent. The constructor. This is a callback that will allow us to create a viewer and initialize it. Passing the focus request to the form. Disposes the toolkit. Now we are considering considering creation of a common navigator view in step-by-step instructions in common navigator framework. The example plugin org.eclipse.ui.examples.navigators.resources shows this. the class Common Navigator. This class provides the iView part for the Common Navigator framework in the Eclipse Workbench. This class also serves as the backbone for navigational viewers. The following types are used by this class to render the Common Navigator. Common Viewer, the viewer that renders the extensible tree, creates and manages the lifecycle of the Navigator content service. Navigate Action Service manages the instance of common action providers provided by individual extensions and content extensions. iNavigator Content Service manages instances of Navigator content extensions. Instances are created as needed and disposed of upon the disposal of the Navigator Content Service. This is in the package org.eclipse.ui.navigator. In order to use CNF-based view in the application, several steps are required, which are discussed now. The created view can be configured by binding specific contents and action to it, which the example plugin org.eclipse.ui.example.navigators.resources shows this. The first step 1, add the following dependent plugins. Add the viewer extension org.eclipse.ui.views and provide the org.eclipse.ui.navigator.common navigator as the value of the class attribute. Please note that the ID view will be required in later steps for the content and action bindings. Please note, if you are defining your own perspective in which Common Navigator is used, show title parameter must be set true in order the viewer renders correctly. True, show title. Now we are considering resources and the file system. In resources overview, interface iWorkspace. Workspaces are the basis for Eclipse platform resource management. There is only one workspace per running platform. All resources exist in the context of this workspace. This is in the package org.eclipse.core.resources. When a platform is running and the resources plugins is active, the workspace is represented by an instance of iWorkspace, which provide the protocol for accepting the resources it contains. An iWorkspace instance represents an associated collection of files and directories in one or more file systems. You can access the workspace from the resources plugin class defined in org.eclipse.core.resources. When the resources plugin is not running, the workspace exists solely in the file system and is viewed or manipulated by the user via standard file-based tools. Let's look at the now we are considering defining a nature in project natures in advanced resource concepts. The following markup adds a nature for hypothetical com.example natures plugin. Identifier org.eclipse.core.resources.natures. The workspace supports the notion of project natures or natures for short. The nature associates lifecycle behavior with the project. Natures are installed on a per project basis using the set description method defined in the org.eclipse.core.resources.iproject. They are configured when added to a project and deconfigured when removed from the project. For example, Java nature might install a Java builder and do other project configuration when added to a project. The org.eclipse.core.resources.natures extension point is used to add project nature definition. The following markups add the nature for the hypothetical com.example.natures plugin. The class identified in the extension must implement the platform interface iProject nature. The following markups this class implements plugin specific behavior associating nature specific information with the project when nature is configured. The configure and the deconfigure methods are sent by the platform when natures are added and removed from the project. You can implement configure method to add a builder to a project. Builder for a project. Add nature specific information for the project, such as adding a builder to a project's build spec. Remove the nature specific information here. Writing an undoable operation in undoable operations in advanced workbench concept. Using operations, the execute method is responsible for creating an operation that does the work formally done in the execute method and requesting that operations history execute the operations so that it can be remembered for undo and redo. The interface undoable operation undoable operation defines an operation that can be executed undone and redone. Operations typically have fully defined parameters, that is, they are usually created after the user has been queried for any input needed to define the operation. This is in the package org.eclipse.core.commands.operations. We will start by looking at a very simple example here. Recall the simple example in this is simple example here. It builds a string and then here we are considering building a string and then open a dialog. That code is omitted here. Using operations, the execute method is responsible for creating an operation that does the work formally one in the execute method and requesting that operations history execute operation so that it can be remembered for undo and redo. The operation encapsulates all behavior from run method as well as the undo and redo for operations. For simple commands, it may be possible to move all the nuts and bolts work into operation class. In this case, it may be appropriate to collapse the former handler classes into single handler class that is parameterized. The handler would The handler would simply execute the supplied operation when it is time to execute. This is largely an application design decision. When a command launches the wizard, then the operation is typically created as part of the wizard's perform finished method or wizard's pages finish method. Converting the finish method to use operation similar to converting execute method. The method is responsible for creating and executing an operation that does the work previously done inline. Build the string buffer buff. Build the string buffer buff. Build the string buffer buff. Simply recalculate the delta. Now we are considering document providers and documents and partitions in editors. The editors plugin defines its document provider as follows. Identifier org.eclipse.ui.editors.document providers. This extension point is used to define mappings between file types and document providers, so between types of editors, editor inputs, and document providers that can be used by editors. Document providers must implement the interface org.eclipse.ui.texteditor.iDocumentProvider. Edit inputs must be instance of org.eclipse.ui.iEditorInput. In the Workbench, an editor is typically open when the user selects a domain element such as a file or an element stored inside an archive file, and it's open it. When the editor is created, it is associated with an editor input which describes the project being edited. Java edit example opens when the user opens a file with the *.java extension. In this case, the input to the editor is file editor input. The platform text framework assumes a little about the editor input itself. It works with the presentation model called an iDocument for the input so that it can effectively display and manipulate text. This means that there must be a way to map from expected domain model the editor input to the presentation model. This mapping is defined in iDocument provider. Given an editor input, the document provider returns an appropriate iDocument. Java edit example inherits the text file document provider defined by the plugin org.eclipse.ui.editors. The extension org.eclipse.ui.editors.document providers is used to define mappings between editor file types or an file extension and document providers. The editors plugin defines its document provider as follows here. The extension point allows plugins to register document providers and associate them with either a text with a file extension or an editor input class. Since the Java editor example does not define its own document provider extension, it inherits the generic document provider specified for all input types that are iStorage editor document, iStorage editor input. When the user opens a file for editing, the platform manages the details of creating a proper document provider instance. If a specific document provider is registered for the extension, that will be used. If there is no specific document provider for the extension, then the editor type, input type will be used to find the appropriate provider. By using the generic platform document provider, the Java editor example can take advantage of all the features of the document provider, such as file buffering and other optimizations. Now we are considering contributing a search page in a search support. The following example is the JDT plugins contribution of the Java search page. Identify org.eclipse.search pages. This extension points allows the plugin to register search pages for specified searches. When the search action is performed on a resource, the search infrastructure locates the most specific registered search page for it. When the user selects a resource and chooses the search command, the search plugin launches a dialog containing pages for different kind of content searches. These searches are contributed using the org.eclipse.search pages extension point. Markup for contributing a search page is straightforward. Following example JTT plugins contribution of the Java search page here. The class is that the class that implement the search page must be specified. This class must implement iSearch page interface and typically extend the dialog page. The label and icon that can be used to describe search in the search dialog are also specified. Additional parameters control the size of the page and the location of the page within the search dialog. The extension attribute specify the resource on which the search page can operate. It is formed as a comma-separated file list, or from a comma-separated list of file extensions. Each file extensions should be followed by a numeric weight value, where 0 is the lowest weight and separated by a colon. The weight value is the relative value used to allow the search infrastructure to find search page most appropriate for a given resource. If a search page can select all possible resources, then asterisk should be used. In some cases, now we are considering merging file types in compare support. The platform defines storage merger for merging three files of plain text. The identifier org.eclipse.team.core.storage merges. This extension point allows the plugin to register a storage merger for specific content types. The storage merge is expected to perform a three-way merge on tree input storage and write the result to an output stream. The extension point must implement the interface org.eclipse.team.core.mapping iStorage manager. In some cases, the ability to merge files without the assist of the user is desirable. The extension point org.eclipse.team.core.storage storage merges allows you to contribute the class that merges three different files of a storage unit into single output stream. Storage merges can be associated with the file extensions or bound to a particular content type. The platform defines a storage merger for merging three files of plain text. The storage merger itself is described in the storage merger element. You must specify ID of the merger and class that implements it. You may also specify the file extensions for which the storage merger should be used. You may also use the content type binding. Element to associate content type with the storage merger. Storage mergers must implement iStorage manager. This simple interface merges that contains from 3 different storage units into a single output stream. The not so simple implementation depends upon your plugin and its content types. Now we are considering extension point in repository providers in team support. Here is the markup for CSV client. Identify org.eclipse.team.co.repository. The team plugins contains the notion of repositories. The job of a repository is to provide support for sharing resources between team members. Repositories are configured on a per project basis. Only one repository can be mapped to a project at a time. The org.eclipse.team.co.repository extension point is used to add the repository definition. Here is the markup for CVS client. The registers this registers your team provider with the team support plugin and assign an ID that should be used when your provider is associated with the project. The specified class for the repository must extend the repository provider. Now we are considering adding launchers to the platform in launching a program in program debug and launch support. The following markup shows how the Java tools declare a Java launch configuration for launching local Java programs. They identify org.eclipse.debug.co.launcher configuration types. This extension point provides a configurable mechanism for launching applications. Each launch configuration type has name, supports, name support one or more mods, run or debug, and specify delegate responsible for implementation of launching an application. As of 3.2, the types can also define a migration delegate that can be used to set resource mappings between projects and the launch configuration that launch them. Your plugin can add launch configuration types to the platform using org.eclipse.debug.co.launch configuration types extension point. This extension point allows you to declare configuration type using unique ID. You must provide the corresponding implementation of iLaunch configuration delegate. The delegate is responsible for launching its launch configuration in a specified mode. Optionally, you can implement iLaunch configuration delegate 2, which enhances the delegate interface to allow you delegate to about a launch, build relevant projects in the workspace before a launch, and control the creation of a launch object that is used in a launch. In addition to defining the delegate, you can specify which launch modes are supported by your delegate and a name that should be used when showing launchers of this type to the user. Following markup shows how the tool declare a Java launch configuration for launching local Java program. This extension defines a launch configuration delegate that can be used to run or debug programs that are launched using local Java launch configuration. Now we are considering running and build file programmatically in platform and support. The following code snippet shows an example of how to use the ant runner from within the code of another plugin. The class ant runner entry point for running and builds inside Eclipse within the same JRE. Client may instantiate this class. It is not intended to be a subclass. This is in the package org.eclipse.ant.co. The Ant support built into the Eclipse allows plugins to programmatically run Ant build files. This is done via Ant Runner class, including the eclipse.ant.co plugin. Following code snippet shows an example of how to use Ant Runner from within the code of another plugin. In the progress menu, if the progress monitor is used, it is made available to the running available for the running tasks. Note that the only one build and build can occur at any given time if the builds do not occur in a separate VMs. Now we are considering defining an intro part in welcome in user assistant support. For example, the following contribution defines a hypothetical intro part to be shown by the Workbench on startup. The identifier org.eclipse.ui.intro. This extension point is used to register implementation of special benchmark parts that are responsible for introducing a product to new users. An intro part is typically shown the first time a product is startup. Rules for associating an intro part implementation with the particular products are also contributed via this extension point. The iIntro part interface and the org.eclipse.ui.intro extension point make up the generic mechanism that can be used to create your own intro support for a given product. The main purpose of this extension is to define the class that implements iIntro part and to specify the binding between product ID and intro part. For example, the following contribution defines a hypothetical part intro part to be shown by the Workbench on startup. This contribution first defines the intro part and assign into the ID some ID. It then binds this intro part to a product whose ID is com.example.some product ID. On platform startup, the class is specified in the class attribute will be instantiated by the Workbench and presented to the user as the introduction to the product. This is the lowest level integration into the iIntro part interface. The platform supplies its own iIntro part called customizable intro part that allows for the content and presentation of the intro to be customized. Below is the snippet that defined the intro part for the Workbench. We won't go over the mechanics of the implementing intro part since we want to focus on defining the intro content. This contribution defines the customizable intro part as the intro part to be used for Eclipse SDK platform. The rest of here. Now we are considering operations API in API overview in provisioning platform P2. The following snippet shows sequence of updating everything in a running application. The class update operation. An update operation describes an operation that updates the instantable units in a profile. The following snippet shows one of most used in operation to check the updates of the profile and then install them to the background. Actually, snippet is not available. I didn't include that snippet. This is a different one. This is doing the sequence for updating everything in the running application. And this class is in the package org.eclipse.equinox.p2.operations. The operation API provides a high-level API for installing, updating, and installing software in a headless system. Operating API is defined with the progressive disclosure in mind. That is the simplest and most common operations require little knowledge of underlying concepts. Client work with the operation in two passes. The operation must first be resolved. Which means that the requirements and dependencies are calculated to determine if desired operation is compatible with what is already installed in the system. The operation can be resolved. Then the actual provisioning work, downloading an artifact, updating the system can be performed. The two-pass nature of an operation allows the resolution stage to be reported to a client to determine whether the operation should be proceed. For example, the client can determine if the resolution is acceptable or examine the detailed plan of what needs to be installed in order to continue with the operation. Resolution and provisioning phases can be performed synchronously or in a background as a job. The simple example can help demonstrate the simplicity of the operations. A common operation in many applications is to simply update an application to get the latest version of everything. This is possible with a very little code. The following snippet shows sequence of updating everything in a running application. If there's a problem resolving an operation or client code wants to something slightly different, then the little more code might be needed. For example, an operation can be configured to update an application that is not running application, or to consult a specific list of software repositories for update. Inside the operation, the underlying P2i planner is performing the resolution pace, and the underlying P2i engine is performing the actual install. However, these subsystems do not need to be understood by a client working with operations. For more information about operations, consult the Java doc for profile change operation. Code snippets for working with operations can be found in the Java doc for install operations, update operations, and install operations. Create an operation. We have the provisioning agent to be a provisioning agent. Resolve the operation to see if we can update. Result is okay. Get a job that will perform the actual work and schedule it. The preferred mechanism here, now we are considering products extension point in defining product in packaging and delivering Eclipse based products. Here is an extension definition found in the org.eclipse.platform. The identifier org.eclipse.core.runtime.products. Products are the Eclipse unit of branding. Products extensions are supplied by plugins wishing to define one or more products. There must be one product per extension, as the extension ID is used in processing and identifying the product. The preferred mechanism for defining a product based on the Eclipse platform is to contribute the org.eclipse.core.runtime.products extension point. To do this, plugin simply declares the name and the ID of its products, as well as the ID of the application. Extension that should be run when the product is invoked. This is the technique used by Eclipse platform itself in defining the Eclipse product. Here is an extension definition found in eclipse.platform, org.eclipse.platform. A product extension is defined whose application ID is org.eclipse.ui.ide.workbench. This is the application ID defined by plugging org.eclipse UI.ide on its contribution to org.eclipse.co.runtime.applications extension point here. This extension is defined with the same ID that is referenced in the application. Application property of the product extension. The fully qualified name with the plugin prefix is used when referring to the application ID from the other plugin. Using this mechanism, a separate plugin can define all the product's specific branding and then refer to the existing plugin's application as the application that is actually run when the product is started. In addition to the application, the org.eclipse.co.runtime.products extension describe products customization properties that are used to configure the product's branding information. This information is described as name properties. Let's look again that the portion of markup for a platform plugin. The possible property names are that are honored by platform for product customization are defined in iProduct constants. Now we are considering building a rich client platform application. The minimal set of plugins needed to build a rich client application is collectively known as the rich client platform. While the Eclipse platform is designed to serve an open tools platform, it is architected so that the component could be used to build just about any client application. The minimal set of plugins needed to build a rich client application is collectively known as rich client platform. Applications that don't require common resource model can be built using a subset of the platform. These rich applications are still based on the dynamic plugin model, and the UI is built using the same toolkits and extension point. Eclipse RCP applications are defined to use the dependency injection and a server-oriented architecture. The Eclipse renderer framework allows to control the appearance of the default user interface, and clients can use either default renderer for SWT or custom renderers for other UI technologies. Eclipse platform provides the E4 applications as a default entry point, but clients are free to create their own application. Rich client applications are free to use any API deemed necessary for their future set and can require any plugins above the bare minimum. Now we are considering HTTP service and JSP support. The platform SDK comes packaged with org.eclipse.equinix.htdp.jetty, an implementation of OSGI HTTP service that uses Jetty as its underlying servlet container. The package org.eclipse.equinix.htdp.jetty provides core support for the Jetty-based HTTP service. Equinix provides support for building and running OSGI-based web applications both inside RCP and application server environment. In an OSGI web application, use the OSGI HTTP service replaces the use of web.xml deployment file. The HTTP service provides means to register servlets and resources in a manner more consistent with dynamic environment in Eclipse where bundles can come and go. The platform SDK comes packaged with org.eclipse.equinix.htdp.jetty, an implementation of OSGI HTTP service that uses Jetty as its underlying servlet container. This implementation allows customization and configuration of many of the server settings important for integration. Java server pages play a central role in many Java server environments, allowing the presentation of dynamic content in on-the-fly compilation of JSP's is provided by org.eclipse.equinox.jsp.chassis JSP servlet. Now we are considering API reference in reference. The package org.eclipse.ant.co provides support for running the ant build tool in the platform. Now we are considering extension point reference and properties and in ant properties. Identifier org.eclipse.ant.co.ant properties allows plugins to define ant properties for use in ant build file. Now we are considering platform runtime available OSGI services interfaces to extend the customize the platform. org.eclipse.co.runtime.iadapter factory services contribute adapt strategies similarity to extensions of org.eclipse.co.runtime adapter. Interface iadapter factory. An adapter factory defines the behavioral extensions for one or more classes that implements the iadaptable interface. Adapter factories are registered with an adapter manager. This is in the package org.eclipse.co.runtime. Now we are considering OSGI 7 core API reference package org.osgi.dto. Bundles wishing to use this package must list the package in the import package header of the bundles manifest. This package has two types of users. The consumers that use the API in this package and the providers that implements the API in this package. OSGI Compendium Release 7, the package org.osgi.application. Bundles wishing to use this package must list the package in the import package header of the bundles manifest. This package has two types of users. The consumer that use the API in this package and the providers that implement the API in this package. Now we are considering OSGI Enterprise Release 7. The package org.osgi.jmx. Bundles wishing to use this package must list the package in the import package header of the bundles manifest. This package has two types of users: the consumers that use the API in this package and the providers that implement the API in this package. This is OSGI JMS package version 1.1. Now we are considering Eclipse the command line arguments in the Eclipse runtime options. In other reference information. The dash application ID runtime, the equivalent to settings eclipse.application to ID. Now we are considering adopting job manager implementation changes, possible deadlock in iJob change listener. In adopting 4.26 mechanisms and APIs in migrating to Eclipse 4.26 from 4.25 in plugin migration guide. Attention, the job manager implementation was changed. The all job manager implementation notified iJob change listener. About the various iJob change event without strict order in various threads. For example, schedule was scheduled method was called thread that did call schedule on the job, while done is normally called within the worker thread. In this case, repeated schedule both schedule method both notification could run in parallel. This was a race condition. The listener could not deterministically know if the job was still scheduled or already done. As a consequence, the join method could have returned too early, or the progress view did not show jobs that did still run, and probably many other things went wrong totally unnoticed. Even multiple notification could have happened in parallel in various worker threads, as there is no guarantee that the next execution is done in the same worker. To fix the indeterministic behavior of all events for the same job instance will now be sent one after another. With it is still not defined which thread jobs event will send, but new implementation will not call any iJob change listener until pending events for some job instances are processed by all registered iJob change listener. The new implementation will also wait with any job state until when it state change until all calls to iJob change listener for that job returns. The iJob change listener Java clearly specify whether the change state occurs before, during, or after listeners are notified is unspecified, and the implementation change within that broad specification. Unfortunately, some iJob change listener around rely on the old implementation. They may now deadlock. For example, the following code snippet can now deadlock. Instead, use this. The same problem may occur in all job iChange listener methods and all methods that result iJob change event being called. iJob change event being sent. The job schedule cancel and wake up and sleep and job manager shutdown. The make sure all iJob listener change listener implementation do not block the return promptly. Due to the extreme risk of new implementation, tries to identify non-conforming iJob change listener and do all fallback. When an iJob change event is not handled within 3 seconds, a timeout error is logged in a stack trace of completing threads of job manager will no longer wait until JVM is restarted. Further calls to iJob listener may occur in non-deterministic order, and job manager.join family can return too soon. It is, however, possible that there may also be some deadlocks in client's code due to change job manager implementation that may be undetected by job manager. Also note that it is undefined in which thread iJob change listener methods are called. Clients may have relied on the old implementation which called done in the UI SWT thread for UI job, but that is not the case anymore. It may happen in a background thread. It is recommended to check existing iJob change listener implementation for possible regressions if updating to the new target platform. Lock needed for reasons. Okay. May result in done. Lock needed for reasons. Schedule will notify scheduled, which may not return before previous notification returns. Can not enter while other threads hold lock. Possible deadlock. This plugin load error java.lang.nullPoint exception. Now we are considering Java development tooling JTD. Java development tools JTD plugins extend the platform Workbench by providing specialized features for editing, viewing, compiling, debugging, and running the Java code. Here you can see Java elements, how these elements are represented in the package view. The package org.eclipse.jdt code defines classes that models the element that compose a Java program. JTD uses an in-memory object model to represent the structure of a program. This structure is derived from the project's class path. The model is hierarchical. Elements of a program can be decomposed into child element. Manipulating Java element is similar to manipulating resource object. When you work with the Java element, you are actually working with the handle to some underlying model object. You must use the exist protocol to determine whether the element is actually presented in the workspace. Here you can see iJava model represent the root Java element corresponding to the workspace, the parent of all projects with the Java nature. It also gives you access to the projects without the Java nature. iJava project represent the project in the workspace, child of iJava model. compilation unit represent the Java source.java file, child of I package fragment. I package fragment use represent a set of package fragments that maps the fragments to an underlying resource with which either a folder, jar or zip file, child of iJava project. I package fragment represent a portion of a workspace that correspond to an entire package or an portion of the package, child of iPackage fragment root. All Java elements support iJava element. Some of the elements are shown in this package view. These elements implement openable interface, since they must be opened before they can be navigated. The figure here shows how these elements are represented in the package view. The Java elements that implements openable are created primarily from the information found in the underlying resource files. The same elements are represented generally in resource navigator view. This is package explorer. Here you can see iJava model root, then iJava project. Here compilation unit, iPackage fragment root. Here jar, iPackage fragments. Since 3.3, here you can see Java elements, a Java compilation unit, and a content outliner that displays the source element in compilation unit. Since 3.3, iopenables that are the root of itypes implement itype root. These are iCompilation unit and iClass file. Other elements correspond to the items that make up the Java compilation unit. Figure here shows the Java compilation unit and a content outliner that displays the source element in the compilation unit. These elements implement iResource reference interface, since they can provide corresponding source files. As these elements are selected in the content outliner, their corresponding source code is shown in the Java editor. Here you can see iPackage declaration. Represent a package declaration in a compilation unit, child of iCompilation unit. Here iImport declaration represent the single package import declaration, child of iImport container. Here you can see iType represent either a source type inside the compilation unit or binary type inside the class file. Here you can see iField represent a field inside the type, child of iType. Here you can see iMethod represent a method or constructor inside the type, child of iType. Here you can see iPackage declaration. Here I import declarations, and here iType. Here iField, and here iMethods. Now here you can see key connections between JTD and Eclipse platform. The JTD is implemented by a group of plugins with the user interface in a UI plugin and non-UI infrastructure in a separate core plugin. This separation of UI and non-UI code allows the JTD core infrastructure to be used in GUI less configuration of the Eclipse platform and by other GUI tools that incorporate Java capabilities but do not need JTD UI. This illustrates the key connections between JTD and the platform. Here you can see perspectives, views, editors, wizards, action sets, property pages, and reference pages are in the workbench. Here Java perspective package, just view, Java editor, wizards for new Java, action set, Java action set, property pages for Java built and the Java source attachment, and Java persistent pages are inside JTD UI. Here project natures, builders, marker and marker types are inside Workspace. Here Java project nature and Java builder and Java problems are inside JTD core. Java perspective, type hierarchy perspective is connected to perspectives, plug into perspectives. Packages view, type hierarchy view are connected to views. Java editor, scrapbook editor are connected to editors. Wizard for new Java project, package, class, interface. Wizard for new Java project, package, class, interface, scrapbook page are connected to wizards. Java action set, create Java project, package, class, interface, scrapbook page, open type in editor is connected to action sets. Property pages for Java build path and Java source attachment are connected to property pages. Java preference pages, Java class path, variables, code formatter, Java editor, organize imports are connected to preference pages. Here you can see project natures, builders and marker types are connected to inside Workspace. Java project nature, Java builder and Java problem are inside JTD core. Java project nature is connected to project natures, Java builder is connected to builders, Java problem is connected to marker types. Now we are considering Java elements and their resources in JTD core in JTD plugin developer guide. The following code snippet shows how to get the Java element from their corresponding resources. Many of the Java element correspond to generic resources in the workspace. When you want to create the Java element from generic resource, the class Java core is the best starting point. The following code snippet shows how to get Java element from their corresponding resources. The class Java core, the plugin runtime class for the Java model plugin containing the core UI free support for Java projects. This is in the package org.eclipse.jdd.core. Once you have a Java element, you can use the JDT API to traverse and query the model. You may also query the non-Java resources contained in a Java element. The project is not configured for Java, has no Java nature. Get the package fragment or package fragment root. Get a .java compilation unit .class file or .java package fragmented root. get the get the non-Java resource contained in my project. Now we are considering opening Java editor in Java UI utilities in JDT UI. The following snippet shows how Java UI can be used to open a Java editor and display a specific member. The class Java UI, the central access point for Java UI plugin ID id org.eclipse.jdt.ui. This class provides a statics method for creating various kind of selection dialogues to present a collection of Java element to the user and let them make a selection. Opening a Java editor on a compilation unit. This is in the package org.eclipse.jdt.ui. The methods open in editor and reveal in editor also work for class files and members contained in class files. Now we are considering launching a compiled Java program. Running Java program in JDT debug. Java programs that have been compiled in a Java project can be run by getting the appropriate IVM runner for the Java project and the running the class by name. The following code snippet shows how the class my class inside my Java project can be launched. The interface IVM runner, a VM runner starts a Java VM running a Java program. This is in the package org.eclipse.jdt.launching. Another way to launch a Java program is to create a Java application launch configuration. Launch it. The following code number shows how my class inside my Java project can be launched using a simple launch configuration. By default, the resulting running application uses a JRE and the class path associated with my Java project. Now we are considering observing JUnit test run in JTD JUnit integration. The JUnit the JDT JUnit plugins let you to listen to test runs. To observe test runs, register your listener with JDT core.add test run listener. The method public static void add test run listener. Listener adds a listener to test runs. This is in the class JUnit core, and this is in the package org.eclipse.jdt.junit. This listener will report all sessions and test cases started. Now we are considering adding annotation processes in APT in Eclipse in getting started in JTT annotation processing. You can add annotation processes to your project under Java, then compiler, then annotation processing, then factory path. Processes can be contained in a jar file or Eclipse plugins. The factory path list includes both Java 5 and Java 6 processes. Now we are considering API reference. For example, we can consider package org.eclipse.ant.launching provide support for ant launching. Now we are considering extension points reference. For example, we can consider org.eclipse.jdt.apt.core.annotation processing factory. Plugins which contribute JSR 175 annotation process should extend this extension point in order to participate in compilation. Now we are considering JDT overview map of JDT plugins in other reference information. This table is useful for determining which plugins a given plugin should include as prerequisites. The Eclipse Java development tooling provides a comprehensive Java development environment. The Java development tooling itself is divided up into a number of separate plugins. The following table shows which API packages are found in which plugins as of Eclipse 4.18. This table is useful for determining which this table is useful for determining which plugins in the given plugin should include as prerequisites. Here you can see com.sun.jdei and org.eclipse.jdei, org.eclipse.jdt.debug, and required plugin ID is org.eclipse.jdt.debug. Here org.eclipse.jdt.debug.ui. The required plugin is org.eclipse.jdt.debug.ui. org.eclipse.apg packet org.eclipse.jdt.core. Required plugin ID org.eclipse.jdt.core. API package org.eclipse.jdt.annotation. Required plugin is the same with the same name. Here API package com.sun.mirror.asterisk and org.eclipse.jdt.apt.core.asterisk. Required plugin org.eclipse.jdt.apt.core. Here the API package org.eclipse.jdt.launching. Required plugin org.eclipse.jdt.launching. Here API package org.eclipse.jdt.core.manipulation, org.eclipse.jdt.core.refactoring, and required plugin org.eclipse.jdt.core.manipulation. Here API package org.eclipse.jdt.ui. Here required plugin org.eclipse.jdt.ui. API package org.eclipse.jdt.junit. Required plugin org.eclipse.jdt.junit and org.eclipse.jdt.junit.core. Here API package junit.asterisk and org.junit.junit and required plugin org.junit. API package org.eclipse.jdt.launching and required plugin org.eclipse.ant.launching. Here API package org.eclipse.ant.ui.launching and required plugin org.eclipse.ant.ui. Now we are considering Eclipse JDT 4.26 plugin migration guide in plugging migrating to Eclipse JDT 4.26 from 4.25 in plugin migration guide. One of the goals of Eclipse 4.26 was to move Eclipse forward while remaining compatible with previous versions to the greatest extent possible. That is, plugins written against the Eclipse 4.25 API should continue to work in 4.26 in spite of the API changes. The key kinds of compatibility are API contract compatibility and binary compatibility. The API contract compatibility means that valid use of 4.25 APIs remaining valid, and for 4.26 there is no need to revisit working code. Binary compatibility means that the API method signatures etc. do not change in the ways that would cause existing compiled binary code to no longer link and run with the new 4.26 libraries. As an exception example, we can consider class format exception. Class format exception thrown by a class file reader when encountering an error in decoding information content in a .class file. This is in the package org.eclipse.jdt.co.util. Now we are focusing on plugin developer environment, PDE. The plugin development environment, PDE, supplies tools that automate the creation, manipulation, debugging, and deployment of plugins. As an example, we are considering now PDE UI in plugin development environment. PDE UI provides editors, wizards, launchers, views, and other tools to create a full-featured environment to develop and deploy the Eclipse plugins, fragments, features, update sites, RCP products, and OSGI bundles. Some of the PDE tools includes form-based manifest editors, multi-page editors that centrally manage all manifest files of a plugin or feature, RCP tools, new project creation wizards, import wizard, export wizard, launchers, views, miscellaneous tools, conversion tools, integration with JDT. Now we are considering extension and extension points in concepts. Loose coupling in Eclipse is achieved partially through the mechanism of extensions and extension points. The basic rule for binding modular software systems is to avoid tight coupling between components. If components are tightly integrated, it becomes difficult to assemble the pieces into different configuration or to replace a component with a different implementation without causing a ripple of changes across the system. Loose coupling in Eclipse is achieved particularly through the mechanism of extension and extension points. The simplest metaphor for describing extension and extension point is electrical outlet. The outlet or socket is extension point. The plug or light bulb that connects to it is the extension. As with the electrical outlets, the extension points come in a wide variety of shapes and sizes. The only extension that are designed for particular extension point will fit. When a plugin wants to allow other plugins to extend or customize portions of its functionality, it will declare an extension point. Extension point declares contract, typically a combination of XML markup and Java interfaces that extensions must conform to. Plugins that want to connect to that extension point must implement that contract in their extension. The key attribute is that the plugin is being extended knows nothing about the plugin that is connecting to the beyond the scope of that extension point contract. This allows plugin to build by different individual companies to interact seamlessly even without their knowing much about one another. Eclipse platform has many applications of extension and extension point concept. Some extensions are entirely declarative, that is, key attribute no code at all. For example, one extension point provides customized key bindings and another define custom file annotation called markers. Neither of these extension points require any code on behalf of the extension. Another category of extension point is for overriding the default behavior of the component. For example, Java development tools include the code formatter, but also supply an extension point for the third-party code formatters to be plugged in. The resources plugin has an extension point that allows certain plugins to replace the implementation of basic file operations such as moving and deletion. Yet another category of extension point is used to group related elements in the user interface. For example, extension points for providing views, editors, and wizards to the UI allow base UI plugins to group common features such as putting all import wizard into a single dialog to define consistent way of representing UI contribution from a wide variety of other plugins. Now we are considering running the build in building an RCP application from the product configuration file in PDE built in tasks. When invoking Eclipse with this application to perform build, you need to set two arguments on the command line. Class AntRunner, entry point for running and built inside Eclipse within the same JRE. Clients may instantiate that this class. It is not intended to be subclass. The package, this is in the package org.eclipse.and.co. The AntRunner here. To run the build, you will use the org.eclipse.and.co.AntRunner. When invoking Eclipse with this application to perform a build, you need to set two arguments on the command line, dash build file, and this one. This is the path of the product build.xml provided by PDE build. It is located in the org.eclipse.pd.build/script/product build directory. This is the build file that drives the whole product build process. Here you can see dash dbuild etc. This is the file path to the build configuration folder. To run the AntRun application using the following command. Now we are considering examples in API analysis and task in API tools and task in API tools. This task runs a complete API analysis of an API profile related to the baseline, including API use, binary compatibility, and bundle version number validation. The profile is the current state of the product under development. The profile is compared to an API baseline for binary compatibility, usually the previous release of a product. This will run the task creating report.xml. files inside the folder D, then report, then XML. It will use the exclude list and the .api filters files located in D, then exclude list extension external .txt and D filters to reduce the number of problems to report. The problem severities will be generated by as specified by D, then test API, then org.eclipse.pd.api.tools.prefs. Since debug is enabled, some debug tracing will show up in the ant console. Now we are considering tips and tricks. The new spice in PDE. The following spice has been added and can be accessed by Windows, then window, then spice, preference spy, bundle spy, context spy, CSS spy, CSS scratch pad, event spy, and model spy. Presentation. Thank you very much for watching it.